Well, today I'll start from the topic in the last time which we didn't able to cover. So, earthquake is the topic, first topic. These are the topics which I am going to cover today. As some of you are asking me, sir, what about the planner? It's already there in your portal. You can see earthquake, volcano and volcanism, weathering erosion, important landforms, structure composition of the atmosphere, pressure belt. Remember one thing, so many topics, in fact, most important highlights of all these I have to give because this is a crash course. So, I just want to tell you again that I do believe you must have studied certain things, but if from the scratch if I will go, it will take time. My request to all of you, that is why do study some basic things, ask me questions whenever you have any problem or anything, let us know the things. Okay, let us now go for today's topic here. So, in the last session I did discussed about the earthquake. There I was saying the place of earthquake is known as focus. The point where the origin of the earthquake is there known as focus or hypocenter. Above this you have the epicenter. Now, there are two important things about this. What are the causes of? First is causes of earthquake. Causes of earthquake, in the last point we were discussing about, first one is the physical or natural factors. Natural factors, like I said about volcanism, I said about folding, faulting, crustal deformation, isostatic imbalances. While I was talking about the isostatic imbalance in the last class, if you remember, isostatic imbalances I have already done. Iso mean equal. One point I said isostatic imbalances. Whether you got it or not, I don't know, but as you said, you are well aware about this. कुछ लोगों ने बोला कि हमें आता है ये, but हमें लगता है कुछ लोगों को नहीं भी आता होगा. So I am just saying, if this is the case of a regions, this is the asthenosphere here. It is the asthenosphere here, asthenosphere, and above this you have the lithosphere. Above this you have this is the lithosphere. What happened that every part of the earth surface is in a balanced position here. Already it is in a balanced position. This balancing mechanism known as isostacy. Iso mean equal. Iso mean equal. Stacy mean static mean stacy. In fact, S-T-A-S-Y. Stacy mean standing. So, equal standing of all relief features over the earth, whether it is a mountain or a plateau or a plain, everything is in a equal position. This is isostacy. They are in a balanced position. They are in a balanced position here. Isostacy means this. They are in a balanced position. Now, as I said, isostatic imbalances, I was talking about reservoir induced earthquake. In the anthropogenic factor, I was talking about, second factor was man-made or human or anthropogenic factors. Anthropogenic factor, in which one I said reservoir induced earthquake. Reservoir induced earthquake. Here, if we will construct a reservoir here, let us say we will construct a reservoir here. Now, what happened? Because of this, we have more and more water. It will have more and more water. Now, it will create stress here. A regions पे ये stress create करेगा. It will create stress because of weight, and this may leads to, there is a possibility that here you have stress. This stress may leads to possibility of earthquake, and you have for that region you will have earthquake in these regions, as it was saying. See, earthquake will be there because of this. This leads to the earthquake here. This is reservoir induced earthquake. A reservoir we have created, it will have more stress here. So, more pressure this side leads to imbalances, and this is called reservoir induced earthquake. The best example is Koyna earthquake. Koyna Dam earthquake. Earthquake in Koyna Dam. Best example is Koyna earthquake here. So this type of question can be asked, like where you have this earthquake and all. So question can be asked on this. Hope you will able to do. Now one more thing, earthquake can be measured under two important aspects. दो important scale है. जो one is about measurement of the earthquake, measurement of the earthquake. Here I will say one is known as intensity, another one is known as you know, intensity of the earthquake. Another one is magnitude of the earthquake. Magnitude. Earthquake. What is the magnitude and what is the intensity? Do you have any idea? Magnitude and intensity, among these two, if you will see, one is about the amount of energy released during an earthquake. एक earthquake होता तो कितना amount का energy release होता है? How much release? Energy release is in that particular magnitude. Magnitude is जैसे कि intensity and magnitude. ये magnitude it represents the amount of energy released during an earthquake. But here intensity is what? Extent of loss, that is of property and life. कितना लॉस हुआ है प्रॉपर्टी लाइफ का, ये मेंशन करता है. दिस इज measured through which scale? If I will go for the scale, intensity is measured with the Mercalli scale, modified Mercalli scale, and Rochefoucauld scale. Mercalli, modified Mercalli and Rochefoucauld scale. Three scales are there. And in magnitude is by Richter scale. Remember, Mercalli scale is a fixed value. It is 1 to 10. 1 to 10 grades you have. A 1 to 12 scale here. Like Mercalli scale, ये open ended, Richter is open ended log scale. ये होता है fixed value. These are scale here is a fixed value scale. यहाँ पे grading है, fixed value में है, 1 से 10 तक होगा, 1 से 12 तक है values. But Richter scale is open ended scale. It is not confined one or not related to a particular limit. आज तक जो है ना 9.8, 9.6 is the highest recorded one Richter scale में South American earthquake. So these are like very different here. And let me tell you, Richter scale and these two are completely different. ये the seismic zone map of India is on the basis of modified Mercalli scale. इसी के basis पे इंडिया की seismic zone map जो national NDMA has prepared this one. Richter scale is usually used for scientific study, but for administrative purpose, modified Mercalli scale is very important. For administrative purpose, modified Mercalli scale is more important. Okay, is it clear to you? ये जो Richter scale है, मैंने कहा Richter scale is open-ended scale. Open-ended scale, so एनर्जी रिलीज कितना है and all these things it shows in the energy release Richter scale, but extent of death and destruction is clubbed in this what you call intensity scale. So, my friends, a very important things in case of this an earthquake, based on our requirement you can go for this intensity scale. For example, 1 is like not felt except very few people understand the special condition डिटेक्टेड मोस्टली बाय द इंस्ट्रूमेंट. 1 जो है ना, 1 जो होगा यहाँ पे पता ही नहीं चलेगा किसी को 1 वैल्यू जो है. इट इज ओनली इन इंस्ट्रूमेंट, सेंसिटिव इंस्ट्रूमेंट कैन ओनली सी. ओके, सो इन दिस केस ऑल्सो. उसके बाद 2 में होगा ओनली द लैब कैन डिटेक्ट एंड देयर इज लाइक लेट वेरी लेस अर्थक्वेक इज सो in fact bigger, mean the earthquake impact will be not perceptible. In 3 there is possibility of shaking of the ground is there, people will feel this. In 4 likewise there is great. By 10 it is destructive, by 12 it is completely catastrophic. So this type of grading is there, modified is the Mercalli scale mein. But Richter scale is amount of energy released it is. So it is completely different here. Please remember this too. My concern is like there is questions can be asked on this. As an administrator, which one is good? Modified Mercalli scale is more appropriate for you. As a scientist, we need this one. Richter scale is better for us, for analysis and all. I hope you got it. Now, the seismic zone map of India used by the National Disaster Management Authority is based on the modified Mercalli scale. Modified Mercalli scale. It is by the modified Mercalli scale. Please remember this. This is by the modified Mercalli scale, my friend. You must remember. Through the modified Mercalli scale only we have prepared this. Yesterday's test, it was Richter's also has 0 to 10 till date we got it, my dear. Here he was asking a question, one of my friend, but sir, intensity should be open-minded because we cannot measure of loss of life, but we can measure the amount of energy released during an earthquake. My friends, open-minded mean the extent of death. ये नहीं कि कितना घर कितना मकान ये हुआ. It is about qualitative norm में ज़्यादा ये देते हैं. On an average condition. समझ में आया कि नहीं? आप थोड़ा ठीक से देखो. Another things, in yesterday's test it was written that Richter scale also has a value of 0 to 10. 0 to 10 till date. मैंने कहा ना 9.6 highest till date. That is the cause that we are having. इससे आगे हमारा नहीं हुआ है अभी तक. But it is open ended scale, you remember. So आप देखिए एनडीएमए का देखो यहाँ पे, नेशनल डिजास्टर मैनेजमेंट अथॉरिटी का मैं दिखाता हूँ आपको. NDMA has given this is seismic zone map of India. Seismic zone intensity map of India on the basis of intensity. It is on the basis of intensity of earthquake. We have different zones here. Zone 1 and 2. Now it is mixed up into low risk zone. This is a low risk zone here because there is no earthquake in this zone. Moderate risk zone is this one near the bordering this. 4th one you see, 4 number को देखिए, the entire Himalaya and Tarai regions and all, as well as in Gujarat one part here because of this is splitting, that's why Gujarat this part. And zone 5 very high risks, देखो आप Kutch regions as well as in Himalaya this part and northeastern regions, very active, seismically active zone these are. So based on this can be asked here. Okay, this can be asked. You please remember, this is very important. Around 59% of the land area of India is liable to seismic hazard damage as per the NDMA. I have just given this from the NDMA. You can see these things. It is there. So very, very important this one. You must remember. So आपका जो स्केल वाला बात कर रहे हैं ना, आप देख लीजिए डब्ल्यू के हैमलिन का एक बुक है, बहुत बढ़िया से डिस्क्राइब कर रखा है. इफ यू वांट, बट नॉट नीडेड फॉर प्रीलिम माय डियर. ओके, जो बताया दैट्स यू लुक एट दैट, दिस इज एनफ फॉर यू. always you remember this. It is a fixed value scale. This is a fixed value in the sense 1 to 10. Close ended. Na fixed value mean close ended. Fixed value mean close ended. 1 to 10 और 1 to 12. क्लोज एंडेड नहीं हुआ का. यहाँ पे तो जितना आगे बढ़ेगा बढ़ेगा, ये आगे चलता जाएगा. ठीक है. On that basis it is there. Okay, fine. Let's like NDM is based on the modified Mercalli scale. We have India has second, third, fourth and fifth zones. Okay. In this way we have divided India into how many zones? 1, 2, 3, 4. 4 zones में है. फर्स्ट एंड सेकंड. पहले 5 था, अभी क्लब करके एक को हटा दिया, ये इस पे मर्ज कर दिए, तो 5 zones you have. You remember one thing, no part is completely free from, in fact, no part of India is 100% free from earthquake or anything. Okay. Earthquake, so we have zone 1, जो आपको नहीं होगा, जो बोल रहे हैं ना कि there will be no earthquake. It's not like that. Earthquake will be there everywhere because the causes of earthquake, as I have just said, is very varied, and earthquake is more in Himalaya because of more and more number of that fault line which I was talking in the last class. Okay, fine. These are the earthquake mapping, zoning. I just said earthquake are due to most important regions. Major earthquake belt of the world, if you'll see, what are the major earthquake belts of the world? Major earthquake belts of the world. First and most important one, first one is definitely you can say like the Pacific belt. I mean the area surrounding the Pacific Ocean, because there are convergence and divergence of the plates at anywhere. There is convergence or divergence. That's the cause that the Pacific belt is the first. Second one is mid-Atlantic belt. At the middle part of Atlantic Ocean, mid-Atlantic belt, we have a huge area because of divergence of the plate. In the last class we were talking about plate tectonics. Divergence of the plate leads to this type of earthquake. Third one is mid-continental belt. Mid-continental belt which extend from Alps to the Himalayas. Alps to the Himalaya, the entire regions, mid-continental belt, Alps mountain to the Himalayan mountain, the entire zone you have mid-continental belt. And the fourth one is the East African belt, East African belt, the Rift Valley, where you have East African region, you have huge area, huge Rift Valley regions, that is also very, very important. This is here is the region, and inter and intraplate seismicity, जो छूट गया बाकी उस पे seismicity. I mean the zone where you have inter and intraplate, between two plates, and even one plate is fracturing, and this is also forming responsible for subsequently earthquake in different regions. These are the 5 zone, East African belt and this. Let me tell you, let me show you a very important point here. Okay, where you have the most important earthquake zone. So let me show you plate tectonics maps, and I'll just show you this. I hope you will able to do. You will able to appreciate this. You can see here. This entire zone which is surrounding your which is surrounding these regions, like let me go for one more. You see here in this map, this is the Pacific Ocean. So, region around the Pacific Ocean, this one is Eurasian plate, this side American plate, this is Nazca plate, or this is American Antarctican plate, Australian plate. So, this entire zone, we have more and more earthquake you are having here, first point. Second point, if I will say, like these regions, like same way, if I will say this particular area now, अगर हम देखेंगे ये एरिया को इधर, मिड अटलांटिक बेल्ट इज हियर, मिड अटलांटिक बेल्ट, this is the mid Atlantic belt, mid Atlantic belt is this one, mid Atlantic, this is the circum-Pacific belt, circum-Pacific belt you have this one, this is mid Atlantic belt, ये हो जाता है ईस्ट अफ्रीकन बेल्ट, देखिए आप, this is the East African belt, okay, and this is the mid continental belt, mid continental belt. So, all these are like in this way we have so many major earthquake zone or belts of the world. ये यहाँ से, here it is with the Himalaya, Alps to Himalaya, the entire regions you have, Alps mountain to the Himalaya, this is this entire zone you are having. So, this is one zone, circum-Pacific belt, one zone is mid-Atlantic belt, third one I said from the Mediterranean Sea, mid-continental Mediterranean Sea, Alps mountain to the Himalaya. Fourth one I am saying the regions around, this is the East African belt, and the fifth is interplate seismicity, mean between the plates even in different regions you have seismic activities are also there, interplate seismicity. So, you have circum-Pacific, mid-Atlantic, mid-continental, East African, and intraplate seismicity. Between the plates as well as in the major plate even there is fracture and a new earthquake zones are developing, no part. For example, the Indian plate is a very, if you look at the Indian plate, it is stable one almost, but a Gujarat area is splitting, that is why Gujarat area have earthquake. And this is interplate or intraplate seismicity I am saying. ये देखो आप गुजरात में these regions, this area is zone 5, this area here it is, beyond this is zone 4. Why it is zone 5 and zone 4? This area here it is zone 3. Why it is so? Because of breaking of this area, I told you earlier that ये region में बहुत सारे fault line develop हो रहा है. I told you earlier also, there are fault line development is there, and these cracks are developing, numerous cracks are developing because of stress and all. So, because of this you have interplate seismicity, mean क्या है? Between the plate or intraplate, interplate, between the plate as well as inside the plate, one plate fracturing of this and there is development. A lot of new areas are developing for that region only. So, please remember this. Let me now go for the I think earthquake belt. Any question you will get in between this only. There is no other questions. I think that you will get it from earthquake. Then this one. Let us look at now volcano and volcanism. Volcano and volcanism. The most important point here about volcano and volcanism. What is a volcano, causes of volcanism, and so many things we need to do. I will go for the next topic now. Volcano and volcanism. Volcano is a landform, is a dome or conical shaped landform associated with magmatic or lava eruption. Mouth of a volcano is called as crater. Crater is the mouth of a volcano, and wide mouth of the volcano developed due to explosion is called as caldera. It is called as caldera. See, crater and caldera are two different things. I hope you got it now, the difference between them. Crater and caldera. Crater is a mouth, caldera is the because of explosion. Whenever you will get a huge mouth, they are known as caldera. Crater and caldera, two different things I am saying. Okay. See here. See, the lavatic eruption here is there and lava flow like this. This is, you know, the magma chamber. This is a vent. This is a conduit, sorry. Conduit. The mouth here, it is known as vent. This is called as the vent. Vent is nothing but ये जो आपकी this mouth is called as vent, but look at here, this depression which you will get here, it is called as crater. Crater is the depression which is there. ये mouth जो है ये है vent, ये है conduit. This is the conduit. This is magma chamber. You know that this is also the magma chamber. This is the conduit. This is the crater. And this particular point here, ये point जो होगा, इसको बोलेंगे vent. Okay, in both the cases, there is two types of volcano here. One, it is called as this type of volcano where it move very quickly, the lava move. This is the dome shaped or shield volcano. And this side you have cone shaped volcano. A dome shaped volcano, this is cone shaped volcano. This is basaltic lava. This is made up of basaltic lava. This is here is mostly made up of acidic lava. so it cannot go much quickly, ये जल्दी जा नहीं पाएगा. This is the cause, you know, you have like this completely different here. The flow of magma will be very slow in this case. Here it is, it goes very quickly. Earlier I have already said, in case of the plateau and all these development, I have already mentioned certain things, that there is basaltic lava, they give only plateau because of this only, because it move very quickly, and basaltic plateau I told you. Now this acidic lava, they sometimes during the eruption itself, acidic lava में क्या होगा, it cool down on its way, यहीं पे आता है तो ठंडा हो गया, it will clog these passage, plug कर देगा उसको, and this leads to explosion also sometimes. Accumulation of stress leads to explosion. ये नीचे से प्रेशर देता रहेगा और ये पूरी तरह से ये पूरे एरिया जो है ना एक्सप्लोड कर जाएगा ये, बिकॉज ऑफ दिस एज ए, यू नो, यहाँ पे क्या करेगा ये, दिस विल प्लग दिस, ये इसको प्लग कर देता है, एंड फॉर दैट रीजन, यू नो, देयर इज ए पॉसिबिलिटी इवन ये रीजन्स को यूजुअली दिस रीजन में हैव, देखो आप, बिकॉज ऑफ दिस एक्सप्लोजन, ये एक्सप्लोजन ऐसे होगा कि ये पूरा उड़ जाता है. ये क्या हो गया, ये हो गया क्या, कैल्डेरा. व्हाट इज दिस, कैल्डेरा क्रेटर, देखा आपने, बिकॉज ऑफ एक्सप्लोजन अर्लियर व्हाट एवर इट वॉज देयर, अर्लियर ये यहाँ तक था, यू हैव सीन अर्लियर ये यहाँ तक था, नाउ इट गॉट ऑल दिस थिंग्स. You got it? कौन सेट वल्कानो, ये एक्सप्लोजन हो गया तो क्या हो गया, एक्सप्लोजन होगा तो देखो, दिस वाज द वल्कानो एसिडिक लावा कॉन्सेप्ट, एक्सप्लोजन से ये होगा, ये इट इज नोन एज ए कैल्डेरा, दिस इज व्हाट इज ए क्रेटर, ये एक्सप्लोजन हो जाएगा, बिकॉज ऑफ एक्सप्लोजन दिस इज ए ह्यूज माउथ नोन एज कैल्डेरा. आई होप नाउ इट इज क्लियर टू ऑल ऑफ यू. नाउ एज आई हैव जस्ट मेंशन अबाउट दिस volcano, there are three types of volcano based on life, like, you know, active volcano, dormant and extinct volcano. But let me tell you, first I'll as all of us were aware about this, that volcanic eruption takes place because of what are the factors. First factor is plate tectonics, crustal deformation, formation of the magma chamber due to when the magma, due to any cause, if there is like, you know, liquefaction or melting of the material inside the earth interior. Please note down here, magma, the volcanic eruption usually occurs due to, first is plate tectonics, causes of volcanism, First cause is plate tectonics. Second cause is crustal deformation and change in the state of matter. मैंटल जोन में क्या है, if there is a melting in the mental zone, there is a melting in the mental zone itself. Mental जो layer है, intermediate layer है, in that melting takes place, partial melting. Because of change in the pressure, because of any crustal deformation above, its pressure will be there. For an example, the melting point of different material changes differently because of pressure. Pressure के वजह से melting point changes होता है. For example, silica. If you give more pressure to silica and you just give temperature to that one, there is possibility more temperature, the melting point will change. If there is no pressure, melting point will be different. Any material on the earth surface, because of pressure, there is a change in the state of matter also. Crustal deformation and changes in the state of matter mean because of the geothermal energy and pressure. Impact of geothermal energy and pressure, there is changes in the state of matter. Melting होगा inside. That is also a cause. Third point is, ये तो हुआ third, development of inside the earth interior. There are few points known as hotspot and all. You know about the what you call, with increasing depth there is geothermal gradient. ये जो है ना crustal deformation, change in the state of the matter. Okay, another one you can see geothermal gradient and melting of materials inside. Okay, 1 degree Celsius with every 32 meter depth. So, it is like, okay. Another one, sometimes it is due to presence of the hot spot and molten magma chambers. देखिए, there are different factors is there. Some regions we have already supplied molten materials are already there. Due to any cause, if there is a displacement anywhere on the earth, it has triggering effect and there is possibility of volcanic eruption. So, which is called as the hot spot, the permanent region from where continuously magma is going up, they are hot spot. Any factor because of which melting of the material in the mantle takes place is the factor of volcanic eruption. Subsequently, it leads to volcanic eruption. Okay, we have types of volcano. Let me I now go for the types of volcano. Based on explosivity, types of volcano. Based on explosivity, the volcanoes can be of like different types. Silent to violent, if I will go silent volcano to violent volcano, you have Hawaiian type, Hawaii is in USA, Pacific Ocean island, Hawaiian type. Then we have Strombolian type, then we have Vulcanian type. Hawaii in the Pacific Ocean, it. Hawaii, it is a hotspot volcano. Hawaii is a hotspot volcano. You might be knowing about this. This is a very, very important one. Hawaiian type. They have the magma is magma split. Very quickly it moves. Silent eruption you are having. Here you are going up. I mean, there is a gradual increase in their explosivity. Hawaiian type is silent. Strombolian type, Mount Stromboli you have. Mount Stromboli. So, that is bit explosive one. Volcanian is more explosive. Pelian type, more explosive than Plinian type. So, explosivity increases. here decrease in explosivity. Most explosive plinian type, least is Hawaiian type. This is a general method of categorization based on the behavior of the volcano. We have different type. मैंने जैसे कहा कि एक्टिव volcano, dormant volcano, there are also volcano like an active volcano where the volcano eruption is going on now also. Second type based on the period of eruption, period and time of eruption. One very important type of volcano here, as you know, active volcano, then dormant volcano, then extinct volcano. Active volcano कौन सा है? What are the active volcano? Active volcano where eruption is going on now. Example, first we can say Fujisan or Mount Fuji in Japan. We have in India, Barren Island. Fujisan is in Japan. Ojas. दल सलादो साउथ अमेरिका एंडीज में है. In Andes it is located, Ojas del Salado. Can you see this? Ojas del Salado in Andes. Based on the period of and time of eruption, you have this is like, I am just giving some example. We have volcanic eruption even recently in some part of the world. स्पेन में भी बढ़ता वोल्केनिक इरप्शन हुआ था, आपको पता होगा. एक्टिव वोल्केनो में माउंट एटना, स्ट्रम्बोली, पिनातुबो, माउंट एटना, स्ट्रम्बोली, पिनातुबो, all these are Mount Etna and Stromboli, they are in Italy. Pinatubo is in Philippines. We have in Spain, volcanic eruption in Spain. So you can say recent volcanic eruptions in which are regions, like you can see the regions here like in Indonesia, Tengger caldera, Vanuatu, Reykjanes, Iceland में Reykjanes के पास. Okay, they are like, you need to see the eruption of this magma particularly in different regions of the world. Hawaii का Kilauea, Kilaua in Hawaii, USA, this is very, very important. Kilauea Island. This is a volcano, active volcano, here it is. Pinatubo. आपके सबसे another one you can see, like the most important one, there is a volcano, lighthouse of the Mediterranean. Stromboli is known as lighthouse of the Mediterranean. It is known as the lighthouse of the Mediterranean. While doing the newspaper or current affairs, if anywhere you will get new Any idea? Please locate that also. But we have like in recently, this is a Kilauea, is another one, and near Reykjavik in Iceland, there is volcanic eruption in Iceland also. Iceland volcanic. You have volcanic eruption Reunion Island also. It is there already. Reunion volcanic eruption is there. Reunion Island. That was very, it is a, in fact, very old one. Now also eruption is going on. By the way, we have one more very important, like in the South America, there is one eruption here in these regions. Ojas del Salado, of a smaller one, okay. Mount Etna, Stromboli, Pinatubo, Kilauea. Kilauea को याद करिए. स्पेन में, in the Spain country में Spain, we have a volcanic eruption. In Europe, let me just see, volcanic eruption in Europe, if you'll see, in Spain, that is a very important one. La Palma, yes, La Palma, that is very important. La Palma eruption in Spain, active one. These are the active volcanic eruption. All these regions are known for volcanic eruption in the recent past. Which is more viscous? Which one is more viscous? जो viscous होगा तो क्या अगर जा नहीं पाएगा तो viscous कौन सा होगा? Acidic. Why acidic basalt? Why acidic and basaltic lava? It depends on silica. Silica content के ऊपर depend करेगा. If silica is more, so in that case you have Vesuvian. Vesuvian type, आपने जो बोला Vesuvian type, we also, ये जो आपको बता रहा हूँ, Hawaiian, Strombolian, Vulcanian, Plinian, Strombolian के बाद यहाँ पे Vesuvian भी करते हैं. There are other way of classification also. Thank you very much. Vesuvian type also there, yes. Based on acidic or basaltic, based on the composition. Based on the composition it is. In the last class I did told you to study something from G.C. Liang. Have you studied that? Acidic and basaltic lava. I have already mentioned earlier, acidic lava less temperature, basaltic lava more temperature, acidic lava 700 degree, basaltic lava 1100 degrees Celsius minimum temperature. Density will be more in case of acidic lava, that's why they cannot move quickly. Acidic lava are more explosive in nature because of more, you can say, silica content, and in basaltic lava they are less explosive, silent eruption is there, they move very quickly. These are the factors here. I hope it is clear to you, my friend who was asking this. Mount Pilay, Vesuvius and Mount Krakatoa is also active. Yes, it is Mount Pilay, Vesuvius is also Krakatoa. Krakatoa is active now. Yes, thank you very much, my friend. In Southeast Asia, Indonesia, Krakatoa is also a very important one, and it is also an active one. What is there? We need to prepare all these, like Mount Pilay. Mount Pilay, West Indies mein, West Indies. Vesuvius. Where is Vesuvius? Italy. Vesuvius. And you have, as you said, Krakatoa. Krakatoa is also, it is in Southeast Asia. Krakatoa. Philippines, Indonesia, these regions you have active volcano now also. Let me now tell you what are the causes of volcanism I have just mentioned. What are the major area where you have dormant volcano also there. Where is dormant volcano? Dormant volcano, ये याद नहीं करने से भी चलेगा, active को याद करो. You just remember the active one. Dormant volcano which has at present there is no At present, there is no eruption, but there is a possibility that in near future there is a possibility of more eruption of magma. So, dormant volcano are those in the last, in fact, in a couple of decade may have some eruption, and it is there like dormant volcano. This is generally we can say some of the dormant volcano now they are active also, and it is like like Kilimanjaro. Kilimanjaro, in Africa it is there. Kilimanjaro, Mount Kilimanjaro is a very good example here. Mount Kilimanjaro dormant, now it became an active one. Mount Kilimanjaro, Mount Margareta, all these are in Africa. They are dormant. Kilimanjaro में बीच में कभी eruption मतलब gaseous material and all this came out even sometimes. By the way, these are certainly extinct volcanoes which are dead. Most of the volcanoes you will find out in our Indian peninsula. They are dead volcano. Most of these. We have conical or dome shaped features you will find out there. Okay, they are extinct volcano. Extinct volcano, they are dead volcano. Only remains of this one is there, like in the Deccan Plateau region. Deccan Plateau. We have a very extinct volcano, we can say, in case of our Narcondam. Narcondam in Andaman and Nicobar. Andaman and Nicobar. Narcondam is a very good example of this type of volcanic eruption. Extinct volcano. It is also an extinct volcano. Okay. It is also an extinct volcano. Dormant volcano and extinct volcano. Okay. As I mentioned about this type of all these, volcano which I have just categorized. There are a lot of ways. There is a term known as stratovolcano, unique one cone volcano, multiple cone volcano. Stratovolcano में क्या होगा कि when the material is coming out, first you will have the lava, then maybe volcanic ashes and the dust particles. Again there is pyroclastic material, then again there is lava. Successively one after one compositional variation is there. So you have a volcano known as stratovolcano, which is a stratified volcano. Again I am saying, if this is a volcano here, this volcano successively there is, here is magmatic eruption is there successively, and this is like, stratified. Based on why it is, layer by layer you have different compositional differences is there. First we have lavatic eruption, then again subsequently dust and ashes and dust particles, whatever is there, volcanic ashes and dust particle, they got deposited. After this solidification, there is again eruption is there. At that time, pyroclastic material, the volcanic bomb, volcanic, that's a huge glowing materials which thrown up to greater height, they fall down gradually with the dust and all. Their composition will be different from the earlier one. Then again, magma will be there. So gradually this type of a stratovolcano, stratified volcano is there, stratovolcano. You can see these things like these stratovolcano are very, very important. These are like an example here I have just given. This is called as stratovolcano. Okay. What are the causes of volcanism? I told you, but what are the major volcanic belts of the world? Major volcanic belts of the world. Major volcanic belts of the world. What are the major volcanic belts? The first and most important one, first one, the Pacific Ring of Fire. Pacific Ring of Fire. Largest, it has more than 65% of the total active volcanoes of the world. It has more active volcano than any other regions. Now, if this is the Pacific plate here, as you know, this is Pacific plate. This side you have Eurasian plate. This is Australian plate. This is Antarctican plate. This is South American plate. North American plate. This one here is Nazca plate. Now these plates are there, so this is on and around surrounding this. You have here so many volcanoes are there. These volcanoes, whatever is these volcanoes, Mount Erebus in Antarctica, Mount Erebus. Here you have Mount Mayon. Then you are saying all the you have Krakatoa, for example, Mount Krakatoa, Mount Pinatubo. Here you have Japan में Mount Fuji San. Here you have Cotopaxi, Chimborazo, Ojas del Salado. You see, on the Pacific plate, this is the Pacific plate here. In the Pacific plate margin, you have so many active volcanoes are there. Just I have named a few. So many active volcanoes in these regions. So active volcanoes are more in number. More Pacific Ring of Fire, you can see the Pacific Ring of Fire, the region surrounding the Pacific Ocean, maximum number of volcanoes you will find out in these regions. Okay. So, in the volcanic eruption, as you have seen, You have Pacific Ring of Fire. This is the Pacific Ring of Fire. You have like here. ये देखो आप, all these are like in Southeast Asia and East Asian part. This is like Japan here. Here is so many volcanoes are there. Pacific Ring of Fire. I was saying about this Pacific Ring of Fire. These are. So what I am saying is all these regions, whatever I have just mentioned, this is the first one. Second major region is Mid-Atlantic Belt. Mid-Atlantic Belt at the middle part of Atlantic Ocean. Middle part. Divergence of the plate leads to this. The mid-oceanic ridge, mid-Atlantic ridge is the best example. Mid-Atlantic ridge or mid-oceanic ridge, mid-Atlantic ridge, the best example here, which plays a very dominant role, very important role. Mid-Atlantic ridge, because of divergence of the two plates, it is happening. This is such a huge volcano. From north to south, if you see linear way, this is mid-Atlantic belt. Then we have Mediterranean belt. Mediterranean sea regions, Mediterranean belt. In and around the Mediterranean Sea, this is Mediterranean belt. In and around the Mediterranean Sea, these regions we have. Mediterranean belt, which is around the Mediterranean Sea regions. The most important area this is also. Mediterranean belt, the most important area. Here, you know about this Stromboli, Vesuvius, Mount Etna, all these are there. Fourth region, East African belt. This is also there, East African belt. Eastern part of Africa, East African belt. The most important one is East African belt. Because of divergence, due to divergence of plate, East African belt है. So these are certain things which you need to know. So ये सब था आपका major regions, divergence and faulting. Not always that. There are also transform fault also it is forming. Divergence is there in some area have transform fault also. These are hotspot volcano are like near the hotspot you are having, like Reunion Island, volcano of Reunion Island, the Hawaiian Island and all, they are hotspot volcano. Hotspot volcano मैंने कहा, hotspot volcano. I hope you got it now. Regarding volcano, there is no such any other things like less like if at all you will get any question from this part only in volcano and volcanism. Okay. So possibility is there. So by the way, after we have done in the last class volcano and volcanism, now I will go for weathering and erosion, important landforms, structural composition of the atmosphere, pressure belt. Weathering and erosion, this particular point I would like to discuss now. Any question from whatever I have discussed, please let me know. इससे कुछ कहना है तो बोलिए, so that I will go for the other topic now. बताओ. Is it clear to all of you? Now, regarding this, don't spend more than half an hour on these topics. Can we say when there is a high magnitude of earthquake, there are chances of volcanic eruption? See my friends, magnitude का बात किया आपने. You didn't say about the intensity. So, there is a possibility if it will split. Depends on, even the earthquake is there, if there is faulting is needed. There is a possibility. We cannot rule out, but not always true here. Not always true, because there are so much of अगर ऐसा अगर होता तो वोल्केनिक इरप्शन में भी अर्थक्वेक सभी टाइम होते ना, बहुत ज़्यादा. माउंट क्राकाटोआ इरप्शन हुआ. बिकॉज ऑफ माउंट क्राकाटोआ इरप्शन, what happened? We have it has impact on the Earth's rotational velocity also. It has tremendous impact. In Southeast Asia, the explosion was in Southeast Asia. We heard up to India and Australia. The impact was such high. But the earthquake is, at that time, earthquake was only 9.6 it was. Okay. So, we cannot always able to correlate the things 100%, as per the explosion, which has the ability even to influence the earth rotational velocity, should have more energy release. So, we can say sometimes there is an exception also, but yes, there is a possibility is there based on the rock type. Okay, let us go for next topic now. Can you go for this, weathering and erosion? Weathering is the disintegration and decomposition of the rocks in situ. In situ means in a fixed place, but erosion is the removal of the rocks or upper part of the earth's crust due to removal of the rocks or upper part of the earth crust by different agents of erosion. Okay, different agents of erosion. I hope you got it. Disintegration and decomposition of the rocks in situ is called as weathering, but removal of the rocks or upper part of the earth crust due by different agents of erosion, like running water, glacier, wind, sea wave, etc. is called as erosion. Weathering is in situ. It is in a fixed place. In situ means in a fixed place. No transportation involved. Transportation involved. With the transportation तो होना ही है यहाँ, displacement is there in case of erosion. But weathering में, if you will keep a particular, you see that if we will keep this table in a rooftop, after 10 years if you will come and just see, it will partly decomposed or fully decomposed one. This decomposed one, this is weathering. But by agents of erosion, by any agent, if it is getting eroded, it taken away from one place to another, this is erosion. Erosion is by agents of erosion, transportation involved, but here it is weathering is different. So, I hope you got the difference between these two. Weathering is disintegration and decomposition, I said. weathering. I think we did discuss to some extent all about this one in the case of rock type. Sedimentary rock के time पे कुछ किए थे ना? We have already done. So weathering. Erosion is not done. So erosion I will discuss in detail. What is this erosion? Erosion, removal of the rock type, I said. Okay, now one of your friend is asking, and in all cases convergence, divergence and transform plates leads to earthquake and volcano? No. In all cases you have earthquake but no volcano. Volcano will be there only in case of divergence and convergence. Please remember. अभी आपका क्वेश्चन आ रहा है, it's too late, but anyway, as you asked me, volcanic eruption will takes place only in case of divergence and in convergence. Two things: if there is oceanic plate is converging, then volcanic eruption will be there, or oceanic continental is converging, volcanic eruption you will have. एक प्लेट अगर नीचे जाता है, denser plate goes down, melt away, then you have volcanic eruption. You remember. So, transform fault boundary doesn't have any volcanic eruption. Earthquake होगा मगर volcanic eruption नहीं होगा. Please, okay, you got it now, my friend? आपको ये समझ में आया क्या? Okay. As I said about weathering and erosion, weathering I have said, I have already mentioned about this, so I'll just for the sake of completion only I'll need to give certain things. So weathering are of weathering, it can be physical weathering. क्या होगा ये? टेम्परेचर, प्रेशर, ह्यूमिडिटी, बाय टेम्परेचर, प्रेशर एंड ह्यूमिडिटी, फिजिकल वेदरिंग. ठीक है. आप देखो प्रेशर से क्या होता है, प्रेशर का बात किया था मैं, एक्सफोलिएशन और ओनियन peeling weathering. Onion peeling weathering, as if we are peeling up the onion layer by layer, there is weathering is like this. Okay, physical weathering. Second one is chemical weathering. It is because of chemicals like carbonation, ऑक्सीडेशन एग्जाम्पल है आपका, एग्जाम्पल है रोस्टिंग ऑफ आयरन, कार्बोनेशन एग्जाम्पल लाइमस्टोन caves because of carbonation. Third type of weathering is biological weathering. Biological weathering by plant and animal. I have already explained earlier, so please remember these are the things. I will go for now erosion. Weathering is always in situ. Weathering is always in situ in a fixed place. But what about erosion? Erosion पे चलते हैं. By the way, weathering helps in erosion. Please remember. Erosion, I said, is the removal of rocks by different agents. If flowing water, it will have fluvial action, will be fluvial action. Flowing water, fluvial action. Then moving glacier, glacial action. Now strong wind, aeolian action. Sea wave, marine action. ground water, the associated erosional action is karst action. So many times different type of landform it will have by different agents of erosion, you remember. We'll just see some of the important one. जो सबसे important है landform में, that I will do certain things. There are, when there is flowing water में fluvial action में क्या होगा? In case of flowing water or fluvial action, erosion होगा तो क्या होगा? You have like here, क्या क्या इन्वॉल्व होगा जी बताओ? प्रोसेस क्या क्या इन्वॉल्व होगा, क्या बता सकते हो? एनीवन? प्रोसेस, इरोजनल प्रोसेस क्या होगा बताओ? एनीवन? हियर यू हैव वन इज फ्लोइंग वाटर से, फ्लूवियल एक्शन से पहला होगा इरोजन, वैली डीपेनिंग, वैली कटिंग. सो यू हैव फर्स्ट वन, you have hydraulic action, cavitation is there, solution, attrition, abrasion. Do you know about this? No. Hydraulic action, kinetic energy of the stream will erode, cavitation will be there. Solution, the soluble part minerals in the soil will get dissolved, forming a cavity. Attrition, bombardment between different particles inside the river itself, bombardment will be there, attrition. Abrasion, when a river is flowing, the rock particles, whatever it move inside, they glide with the surface of the river valley, abrase the things, abrasion. These are the most important few erosional processes. You got it now? Erosional process I said, like hydraulic action, solution, attrition, abrasion. Cavitation is there. Hopefully you got it. किसको समझ में नहीं आया तो बोलो. Is it okay? Fluvial action is okay to all of you. Hydraulic action, action of the river, strong water while it goes, kinetic energy is there, kinetic energy impact will have, and cavitation. Solution, it dissolve the mineral, soluble mineral. Attrition, आपस में bombard करेगा क्या? Inside the river, the boulder, pebble, cobbles, they will strike with each other. Abrasion, the boulder, pebbles, etc., they will have friction with the surface. Abrasion. These are some of the important, most important few features. Hope you got it. तो ग्लेशियर में क्या होगा भाई बताओ? In case of glacier, you will find out here, very interesting. यहाँ पे abrasion. Another one is plucking. Two most important one. Abrasion, what is that? When the glacier moves, it will abrase on the way, it takes away everything on the way, it will polish the surface. Abrasion. Plucking. मैं एक इस पे दे देता हूं, then I will discuss about the landform later on. Okay? Plucking will be there. Abrasion and plucking. Moving ice. Glacier क्या है? A huge body of block of ice. Okay? On certain material it takes, and while it moves, it abrases everything. Everything on its way will get abrased. It will get polished. Abrasion. Please remember. अच्छा ये एरिया जो हम करा रहे हैं, if you have any problem, let me know. I know that some of you have some problem. We are weak in some particular concept here. So please do participate on this. बाकी everything in the mains you have done. It's exclusively for the prelim. Prelim में नहीं आते हैं कभी कभी, but they asked last year mains में भी आ गया fjord coast. ओके, सो इफ यू आर गेटिंग प्लीज लेट मी नो. नहीं हो रहा है प्रॉब्लम बताओ. प्रॉब्लम है फ्लोइंग वाटर, फ्लूवियल एक्शन, हाइड्रोलिक एक्शन, सोल्यूशन, एट्रिशन, अब्राशन, ये सब क्लियर है ना. देन वी हैव अब्राशन एंड प्लॉकिंग. प्लॉकिंग क्या है? व्हेन ए ग्लेशियर मूव इट एवरेज एवरीथिंग, but at the edge while it reach its weight also gives pressure and part of this will collapse. प्लॉकिंग, अरे सेब खाते हो ना, प्लग करते हो, याद है? देखो प्लॉकिंग, प्लॉकिंग, प्लॉकिंग मीन when the glacier move and at a particular edge surface, resistant rock is there, at its edge it is reached here. Now it will give pressure and will pluck part of this one. Plucking, plucking, you got it. Abrasion, plucking. Okay, wind action. Wind, here you have like one place abrasion is there. When the wind blows, the dust particle, the sand fragment, sand etc. They will collide with each other, and they will also with the surface they polish the surface, they abrade the surface. Attrition, wind particles, they collide with each other. With the wind, the sand particles, they will collide with each other, bombard with each other. Attrition will be there. Abrasion and attrition, and from a particular region, the sand, strong wind in the arid area, it take away the material, sand particularly, from the surface. Do you remember? This is known as deflation. Deflation. Abrasion क्या है? It will have it will average, it will make where it move over the surface, घिसेगा इसके साथ. Abrasion. Attrition, bombardment between them. Deflation, it take away sand of one region to another part. Wherever it take away deflation, hollow it form. Deflation is a very important process, that's why. Deflation. I hope you got it. Deflation. Abrasion, attrition, deflation. Okay? Three most important one. Saltation मतलब leap and bounce. ये जो wind होगा ना, wind में क्या होता है? The sand particles move like this, from here to here, from here to here, from here to here, like this. और finer one क्या करेगा? From here to here, because this finer one, it can leap and bounce like this. Finest one will go like, based on the particle size, it can move here and there. This type of characteristic, this is called as here saltation. Saltation is the process of movement of the sand particles. Saltation is the process of movement of the sand particles. The process of movement of the sand particles by strong wind is known as saltation. The process of movement of the sand by strong wind is known as saltation. It is nothing but leap and bounce. क्या बोला मैं? Leap and bounce of the particles. Leap and bounce of the particles. Leap and bounce of the particles here. In case of saltation, leap and bounce of the particles. They will jump and jump like wind के ऊपर. आप देखो ये. Is it clear to you? Strong wind जब बहेगा कहीं पे, जो सैंड है, सैंड सब आपस में, सैंड भी चलेगा, तो लीप एंड यहाँ पे आया, फिर यहाँ पे, फिर ऐसे जंप करेगा पार्टिकल का साइज के हिसाब से. लार्जर पार्टिकल स्मॉल डिस्टेंस, स्मॉलर पार्टिकल लार्ज डिस्टेंस. लीप एंड बाउंस इज नोन एज saltation. During this project, this period, they will bombard with each other. This is known as attrition. it will take away from one part. यहाँ से ले गया material को, ये हो गया deflation. From here it is take away deflation. The sand is being deflated away here. Abrasion, when they are moving even at the lower part, surface में, it will abrase. Strong wind will abrase. The sand particles will get abrased with the surface. Abrasion. Hope that you got it. Is it clear? Okay. Now, if there is sea wave, what are the processes involved here in case of sea wave? In case of the sea wave, the processes involved will be like, one हो गया cavitation, hydraulic action. Solution, abrasion, attrition. ये सब जहाँ ये सब होगा, ये जो भी है ये सब ही होगा. Sea wave also hydraulic action, solution, abrasion, attrition, same thing. Sea wave at the coast, it will have impact. When the wave go and strike on the coast, hydraulic action, it dissolve the minerals, solution. When in the coast you have the sand particles, they move, they will abrase the surface, abrasion. And attrition, the particles they will bombard with each other, attrition. ये process यहाँ भी होंगे. My friends, have you ever experienced this in the sea beach? Sea beach में आप खड़े हैं without a shoe or a चप्पल है, आप अगर खड़े हो barefoot, so you will feel like as if the sand is going away. Tide आया, फिर जब जाता है tide, you will feel like as if something is going down from the sand is going away from your feet. So these are like erosion. This is a type of erosion where because of the hydraulic action it happens. Because of the hydraulic action it happens. Okay. Is it clear to you? Hydraulic action, sea wave, marine action, sea wave. Ground water में क्या होगा? Mostly it is solution. Ground water में solution is the most important factor here. Solution. और corrosion कहते हैं, CORROSION, corrosion. Solution और corrosion same term. Abrasion और corrosion same term. Abrasion को corrosion भी कहते हैं. Abrasion का अलग नाम है CORRASION और abrasion. Remember, corrosion और abrasion. Corrosion और solution. Cast में, because whenever the water percolates inside the limestone rich regions, whenever the water percolates goes inside the limestone rich region, solution action started and everything got like उसके पानी के साथ घुल जाएगा. Solution, it dissolve with the water forming a cavity. Cast, groundwater, cast action, solution you will have. Very important. So now what are the type of landform you will have in different type, we will see. I hope processes involved is done. You got it now? Processes involved. Once it is done, I will go for now landforms. Landforms are of two types. One is known as erosional landform. Second one is known as depositional landform. Depositional landform. There are two types of landform. Erosional landform, because of erosion, if any landform will develop erosional. Because of deposition, it is depositional. Two major types of landform you will find out, erosional and depositional. Okay. If I will go for fluvial by river, what are the landform you will get by river? River के जरिए क्या क्या हो सकता है? What type of landform we can have developed by river? Fluvial action. Fluvial action से क्या होगा? Erosional landform में first is V-shaped valley. Second one is waterfall or waterfall gorge. We will have a V-shaped valley, we will have a waterfall, we will have gorge, and because of fluvial action, maybe subsequently interlocking spore. It is erosional and depositional both होगा ये. This is erosional plus depositional. इरोजनल प्लस डिपोजिशनल होते हैं. डिपोजिशनल लैंडफॉर्म में आएंगे. अच्छा, इरोजनल में फाइनली यू कैन गो फॉर वन मोर थिंग, पेनी प्लेन. These are the most important few things. V-shaped valley क्या है? When a river flow, you will have a V-shaped valley here. This is the river where you have the water is flowing in this river system. It will have a V-shaped valley. Why V-shaped valley? Because of the laminar movement of the liquid or water, laminar flow of the river. You know what is laminar flow? When the water flow, both the bank you will have friction, below you have friction. So, due to which velocity will be less, but at the middle part, upper part, the velocity will be more. So, this is here, the water will flow very quickly and it will have more action, and at the middle part you have more erosion, forming a V-shaped valley. V-shaped valley fluvial action से बनते हैं in general, remember. So, V-shaped valley you got it now, V-shaped valley. Waterfall, because of differential erosion maybe or more erosion in the lower part, differential erosion से भी हो सकता है. ऐसे waterfall will be like this. If the water from this part is coming from height और यहाँ पे अगर गड्ढा बना लिया, if there is a pockets here like this erosional one, this is called as what? This is called as plunge pool. Plunge pool, erosional one, erosional valley type, cavity type is formed known as plunge pool in case of a waterfall. Waterfall क्या है? Steep I-shaped valley here. I-shaped, very steep valley. Differential erosion से होता है और down warping से continental part got downward, maybe for that region. Now, what is gorge? Gorge are I-shaped valley. This gorge. Gorge are I-shaped valley. ऐसे valley होता है. They are like this. Steep valley both sides because of steep vertical erosion. Gorge. Indus river has a gorge. Satluj has a gorge. Got it? Gorge. Is the gorge, you got it now? Gorge को समझ में आया क्या है gorge? Have you got it? What is a gorge? Again I am saying, gorge is a very steep, V-shaped valley got turned into a very steep valley because of resistant rock and its erosion at the both sides. It is not gorge. Clear? Now peneplain. Peneplain are eroded plain developed by a river. Erosion के बाद पानी के प्रेशर से because of the water action, erosion will be there. And eroded plain finally which is developed is known as peneplain. Peneplains are eroded plains, I said. Peneplains are eroded plain. Always you remember. Example of this is Chhattisgarh plain. Chhattisgarh plain developed by Mahanadi. Chhattisgarh plain in Chhattisgarh developed by Mahanadi is the best example of peneplain. Any plain which is developed due to erosion is peneplain. Remember. Is it clear to you? Erosional landform अभी जितना बोला सही है. No problem with you. Interlocking spur पे आएंगे अभी. Is it clear to you? Erosional landform. Is it done? Erosional landform. Please respond. You write there, fluvial erosional landform. Okay. Yes, sir, में नहीं होगा. Fluvial erosional. Let me know if needed anything. Let me see that. But I must know that you got it. If not, then tell me. Where is the point? V-shaped valley, waterfall, gorge, peneplain. Interlocking spur, to this I will come later on. Okay, these are the area which is very, very, very important. Please. Okay, very good. Depositional landform are at the mouth you have deposition of, what is there? Deposition. It can be an alluvial plain. It can be a delta. It can be a delta, alluvial plain. Depositional में आएंगे. Alluvial plain has a delta. It can be a delta or a. Remember this. Can we say V-shaped valley later became gorge? Yes, of course. You got it now. V-shaped valley at the beginning, then it became a gorge. Yes. Initially ऐसे होगा ही. Alluvial plain, जो sediment जो गया ना वहाँ डिपोजिट हो जाएगा. इसको बोलते हैं क्या? Alluvial plain. Alluvium से delta at the mouth. I'll tell you what are the condition for the development of delta, type of delta अभी कराएंगे जो प्रीलिम के लिए बहुत जरूरी है. Okay. Now I will say, थोड़ा मैं एक डायग्राम लेता हूँ इंटरलॉकिंग स्पर के लिए. लेट मी टेल यू दिस. देखो, let us say here is a mountain, right? And this river is flowing final to the nearby ocean. Okay, fine. Now this river is originated here and going toward this side. Finally meeting at the ocean. Remember this part here. This is known as the upper valley of a river. This is the middle valley of a river. This is the lower valley of a river. You remember one thing in the upper valley. One thing you please remember. Here always valley deepening or vertical erosion is maximum. Here you have mostly middle case में valley widening or lateral erosion is more. Here we have deposition of sediments. यहाँ पे वैली अगर बहुत डीप करेगा तो यहाँ पे क्या होता है, वी शेप्ड वैली बनेंगे. यहाँ पे क्या बनेगा, गॉर्ज बनेगा. हियर वी हैव न्यूमरस वाटरफॉल. बट यहाँ पे क्या है, वैली वाइडनिंग. यहाँ पे वाइड होगा, वाइड वैली, वाइड रिवर वैली एंड meandering of river. रिवर meandering होगा. Meandering of the river starts here and here. In this case, depositional already written. Here, distributaries of the river develops, forming delta. Meandering of river forming oxbow lake. And interlocking spur. Oxbow lake here we have two things will develop. पहला है interlocking spur as well as second one है कह रहा हूँ oxbow lake. Last year you got a question on oxbow lake, interlocking spur, meandering of the river. देखो आप सही, भीषण वैली यू गॉट इट, गॉर्ज यू गॉट इट, वाटरफॉल यू गॉट इट, अपर वैली में होगा. लोअर पार्ट में डेल्टा फॉर्मेशन विल बी देयर. Meandering of the river start in the middle part. Now I'd like to discuss about this, why meandering start and what type of landform will be there. Erosion will be more in the upper part because of vertical deepening, more erosion, and this side the material will goes downstream. अगर ये अंदर जा रहा है ना and valley widening is there, the sediment get started depositing here. Gradient is less here, you see. Less gradient, more and more water. तो spilling off होगा. Spilling off हो गया, बैंक से बाहर चले जाएंगे पानी. Water will go out of this, forming a flood plain. क्या बोलते हैं उसको? Flood plain. Wide river valley. यहाँ पे और एक लिखिए FLOOD, flood plain. Flood plain will develop here. In this time, we have flood plain will develop. Middle valley regions, we have flood plain development. Flood plain क्या है? Because of the spilling up of the water during heavy rainfall and all, the bank will get submerged. That like on both sides you have water from the river will spill up it and it deposits sediments, very finer sediment at the coast, at the margin, and this is called as the flood plain. Flood plain, the plain which are developed during a flood because of deposition of sediments. Sedimentary deposits से जो flood जो plain बनेगा known as flood plain. If this is the river here, let us say here is a river. ये river ऐसे flow कर रहा है. This is the river which is flowing here, right? During the flooding time, you have like this much of sediment is there. This is the flood plain here. इससे बाहर जब आ जाएंगे, ये है flood plain. This is the flood plain here. The water will go from here to here. This is here is flood plain. इसको क्या कहेंगे? Flood plain. This is the flood plain. This is the flood plain. Flood plain, both sides you are having flood plain. Is it clear to you? Flooding से होते हैं flood plain. Wide river valley will have, flood plains will have meandering of the river. Meandering क्यों होगा? More and more sediment leads to meandering. Let me now go for this. How it develops interlocking spur in oxbow lake. देखिए, when a river is flowing here, it started meandering here. देखा आपने? If this is the river, आपको लग रहा होगा कि ये होता नहीं होता है, जरूर होता है. Now this meandering is because of what? Meandering of river. Meandering of river. Why the river meanders? The sediments get deposited. Whatever sediment coming from upper reaches get deposited here. The sediment from upper part will get deposited here. Sediments will get deposited here. Now, आप यहाँ पे देखिए, in this case, more pressure, more erosion will be there at which part? Here we have more erosion. होगा कि नहीं होगा बताओ? Here we have more erosion. When it is coming, here we have more erosion. Now the time will come. In this meandering path, time will come that this region, whatever water is coming from this side, it will breach like this. It will breach like this. देखिए आप, ऐसा था ये. Here more and more erosion, then again more erosion. You see, ऐसे बन गया है. Now what will happen, you see? There is a possibility. There is a great possibility even that this meandering path will change. देखो आप, ये हो गया आपका ऑक्सबो लेक. Again I am just rewind. See here how it was. देखिए, this is like this. Look at very carefully. Flow of water is like this. Here you have more and more erosion. Now what is happening? Because of more and more erosion, subsequently the flow of water got diverted. This is a lake. This lake is known as Oxbow Lake. You got it now? Step by step it will develop because of more and more erosion. Step by step there is development due to the erosion here. How is the first course of river made? The initial one. इतना लेट में पूछ रहे हो भाई? चलो ठीक है, I'll Alexa. Just wait. ये जो रिवर है यहाँ ऑक्सबो लेक है. लेट मी एक्सप्लेन इट. एग्जाम्पल दे आर आस्किंग. एग्जाम्पल ऑफ ऑक्सबो लेक. ऑक्सबो लेक की एग्जाम्पल, फर्स्ट एग्जाम्पल कन्वर लेक. कन्वर लेक in Bihar. My friend from Bihar, tell me here where it is. Developed by Budi Gandak. Budi Gandak river. है ना? बेगूसराय के पास है क्या? Next one, my friend from Srinagar. Hi. You see which lake is there? Ular Lake. Ular Lake by Jhelum river. My friends from Odisha, do you know where you have this in Odisha Oxbow Lake? Ansupa Lake by Mahanadi. Best example of this one. These two आप याद कर लीजिए, अंसुपा, उलार एंड कन्वर लेक. कवरताल बोलते हैं कन्वर को, कवरताल. कन्वर लेक इज नोन एज कवरताल. Is it clear to you? Three example I have here: Kanwar, Walar and Ansupa. They developed Oxbow Lake, these are. Okay, now a friend is asking here, how is the first course of river made? Initial course जो होता है, if rainfall is more, if more rainfall is there, what will happen? So the water get accumulated here. So based on the slope, water will flow. They are known as consequent stream. Consequence of the slope, consequent stream. Okay, while it flow, subsequently another consequent river will, smaller one will join that. They are known as tributary. They are subsequent stream. consequent stream के साथ मिलता है. Which one? Subsequent stream. Maybe a new recently developed consequent stream meets there, known as resequent stream. Recently developed resequent stream. So, likewise you have different types. Based on the slope only the river will flow, and the fast river system or stream developed because of the slope only. They develop by the slope, please remember. I hope you got it, my friend. So, we are discussing about this oxbow lake formation and all. Now, if meandering of the river is there is a river which is meandering gradually, right? So, in this river, you can see one thing. Erosion will be more on this part. Then here you have more erosion. Then you have more erosion here. This side erosion. This side erosion. This side erosion. And deposition of sediment will be in the opposite side. Here you have opposition, deposition, 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 deposition and deposition. This side you have erosion, here is deposition, here is deposition, this is erosion, deposition, erosion, deposition, erosion, deposition, erosion. You got it now? This side more erosion, why? Because of, see the stream how it is meandering. Meandering leads to here more and more kinetic energy. So, this part you have more erosion, this side you have more eroded valley. This eroded valley are known as cliff. What you call? Cliff. And this side deposition is known as slip of slope. Slip of slope. Got it? One side you have cliff, other side you have slip of slope. So, if you will see in this way, if you have cliff, slip of slope, cliff, slip of slope, cliff, slip of slope, like this it is there. We have in this case here a erosion, deposition, erosion, deposition, erosion, deposition, like this. River is like this. You can see here. I am saying this side erosion is there, here it is erosion, deposition, erosion, deposition, erosion, deposition, erosion, deposition. This side you have more erosion, here you have more erosion, here you have more erosion, here you have more erosion, erosion and erosion. Because while twisting of this stream, we have one side will have more erosion. So, erosion means cliff, deposition means slip of slope. Let us say, ये जो है ना देखो, cliff, slip of slope, cliff, slip of slope, like this it is there. This type of valley, as if like in a chain में क्या होता है? In a chain, you have interlock like this type, interlock like it is there, interlocking spur. That's what is called as interlocking spur. Can you see this? You can see. देखो interlock जैसा लग रहा है कि नहीं? Interlocking spur. So, this is called as, this type of shape of landform is called as the interlocking spur. Look at here. Can you see these things? Clearly, interlocking spur how it is? Meandering and leads to interlocking spur in these regions. But interlocking spur is in one side you have erosion, then I say deposition, both are involved here in interlocking spur. I hope it is clear now. Okay? Clear to all of you? Interlocking spur. So, in the diagram which I have drawn, where I was discussing about this, we have wide river valley, flood plain, I told you, interlocking spur you will have, wide valley होगा, flood plain, flooding से बचेंगे, meandering, interlocking spur, oxbow lake, all these things in middle. In the lower part, deposition will be there. Distributaries of the rivers, delta will form. When the river finally it joins the ocean. Where it joins the ocean, what will happen now? See here. When this is the, let us say, coast, this river is flowing here, and the river is finally draining into this sea, right? So what will happen while it is flowing here? It deposits also sediments in between. In some region we have some sediments. Here is some sediments. These sediments leads to splitting of this into two part here. Here it goes. This is here is, maybe it will have a like this, and two island like it is formed here. See, this may leads to subsequently, let us say here sediment is there. It will strike over these regions and it will move in this way. This may leads to, see here, this may leads to the formation of possibility of branching of the river into two part. Possibility of branching of the river into two parts here. Look at here, this will form what? आप देख लो यहाँ पे, this is forming this is here is like, this may leads to formation of this type of delta. This is a delta here. Braided rivers profile and subsequently we have a delta. Before joining the ocean, it got split up into several distributaries here, you see. This is a distributary. It will have several distributaries in between. Deposition of sediment. This is known as a delta. It is called as a delta. So delta is a depositional platform. When and where it will develop? It will develop at the mouth of a river. It depends on the nature of the coast. It is completely depends on the nature of the coast. Okay, here is a question from your friend. सर V-set वैली गॉर्ज कैसे हो रहे हैं? Why so much difference? My friend, V-set वैली जो है ना जनरली वेरी कॉमन वन. गॉर्ज होने के लिए दोनों साइड में, V-set वैली के दोनों साइड में अगर थोड़ा रेजिस्टेंट रॉक हो ना, तो जब फ्लडिंग होगा, ज़्यादा पानी आएगा तो क्या होगा, नीचे से ज़्यादा इरोजन होगा, तभी जाके होते हैं. ऑलवेज गर्ज नहीं होगा. अंडर सर्टेन सर्कमस्टेंसेस ओनली यू हैव गर्ज. ओके, गॉट इट फ्रेंड? इंटरलॉकिंग्स पर समझ नहीं आया. ओके 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 फाइन, नो प्रॉब्लम. मियांडरिंग तो समझ में आया ना? आप प्लीज इंटरेक्ट करो. इफ यू गॉट द मियांडरिंग पाथ हियर, जहां पे पानी जब आ रहे हैं ना, जहां पे ट्विस्ट और टर्न है, व्हेरेवर इट इज ए पानी की कोर्स करंट ज्यादा होगा कि नहीं? इधर कहीं पे भी आपको पता है, नदी अगर ऐसे मोड़ता है, यहां पे ज्यादा आएगा कि नहीं प्रेशर पानी का? इधर होगा कि नहीं ज्यादा प्रेशर, ज्यादा इरोजन इधर होगा. सो दिस इज ए इरोडेड वैली हो गया. ये इरोजन, इधर भी इरोजन हो गया. इरोजन होगा तो डिपोजिशन इधर करेगा. ये इरोजन होगा तो यहाँ पे डिपोजिशन करेगा। ओके, इरोजन इन वन साइड मीन डिपोजिशन मीन अदर बैंक। अरे नदी को देखा है कभी? नदी को आप सूखा हुआ ड्राई बेड भी पास में कोई नदी है देखो आप, वन साइड में थोड़ा गहरा होगा, अनदर साइड यू हैव सेडिमेंटेशन लाइक दिस, चैनल डेवलपमेंट होता है ये। ओके, इंटरलॉकिंग स्पर इसको कहते हैं, अल्टरनेट डिपोजिशनल इरोजनल, डिपोजिशनल इरोजनल ऐसे रहेगा। सो यू हैव इंटरलॉकिंग स्पर, it is in the middle stage, you will find it in middle stage. Okay, plunge pool is like plucking happened in water, not glacier. My friend, plunge pool is while you will the waterfall में ऊपर से पानी गिरता है, at because of the impact of gravity and the kinetic, the amount of water is flowing, what will happen? It will have more impact there, kinetic energy, and नीचे क्या होगा? Erosion होगा. That is like a swimming pool, like you will find out the plunge pool, because the water is plunging into this pool, plunge pool. Okay, glacial नहीं है, plunge pool is always, वो है जो आप बोल रहे हो पेटरनेस्टर लेक है, अलग है वो, that is different. Glacial नहीं, fluvial में ही होगा plunge pool. Okay, flood plains and oxbow lakes are formed in middle course of lower course of river. Flood plains, yes, flood plains are developed, started from middle and goes up to lower course. Oxbow lake भी start होता है from middle, goes up to the older one. ठीक है, middle course में develop होगा, lower course में जाके complete fullest development. Starting at all these, both of them are started from the middle course. मैं मिडिल कोर्स का बात कर रहा हूं, मिडिल स्टेज का बात नहीं कर रहा हूं, प्लीज रिमेंबर। ओके, आई होप इट इज क्लियर। इंटरलॉकिंग स्पर समझ में आया कि भाई? बोलो यार, आप बोलते ही नहीं हो आप लोग। एज सच इन द लेस टाइम we have to cover a lot of things, but if you will not ask or not give the immediate response, how I will able to do? Okay, in G.C. Young book there is a lot of things that are given. This type of things, important one you need to see. Some of you are saying, sir, after looking at previous year questions, it's like very difficult for us. See, UPSC required long term preparation, fundamental things you need to do. If you haven't done, you take some time, but you have to do. Crash course will give you, if you have some idea, then it will be very easy for you to weaving the things. Okay, but if not, then you please concentrate on whatever I am saying. जितना कहा जा रहा है उसको बढ़िया से करिए, जो टॉपिक है इम्पोर्टेंट है जो। ओके, और नहीं आता है, मैं तो कल भी इवन आई हैव गिवन डिटेल्स ऑफ दिस, even contact number I have given. For what? I want you to do well here. Okay, now while a river meets the ocean, sediments will get deposited, and ये जो sediment deposition है उसको बोलते हैं braided river profile. क्या बोलते हैं? braided river profile. ब्रेडेड रिवर कहते हैं किसको? whenever sediment get deposited, after some years what will happen? These sediments get deposited, then splitting of these takes place. देखो आप, ये इरोजन करके ये हो गया डिस्ट्रीब्यूटरी, दिस इज ए डिस्ट्रीब्यूटरी, ये एक डिस्ट्रीब्यूटरी, ये भी एक डिस्ट्रीब्यूटरी, इधर एक हो गया डिस्ट्रीब्यूटरी, ये हो गया मेन चैनल, तो डिस्ट्रीब्यूटरी सब आ गए। सो डिस्ट्रीब्यूटरी एंड द मेन चैनल डेवलपमेंट विल बी देयर, ऐसे डेवलप करेंगे सब, डिस्ट्रीब्यूटरी एंड द मेन चैनल, लाइक दिस इट विल डेवलप। ओके, लाइक दिस यू नीड टू डू। You got it, I hope. Now it will form a डेल्टा शेप लैंडफॉर्म फाइनली। ये फाइनल जो लैंडफॉर्म है कैसा लग रहा है ये बताओ, डेल्टा शेप है कि नहीं? ये आपकी डेल्टा लेटर शेप्ड हो गया। इट इज नोन एज ए डेल्टा, क्योंकि ये डेल्टा शेप्ड है, इसको बोलते हैं डेल्टा। ग्रीक डेल्टा शेप, दैट्स अ डेल्टा। शेप ऑफ दिस इज लाइक दिस, सो इट इज नोन एज डेल्टा। यू गॉट इट नाउ? इसको डेल्टा क्यों, देखो शेप ऐसा ऐसा है, सो इट इज नोन एज डेल्टा। Braided river and delta, there are different type of delta, my friends. Delta usually develop whenever there are condition like first condition, enough supply of sediments, sediment आना चाहिए upper coast से। Second, no strong wave here, ज़्यादा बड़ा strong wave होगा तो ये क्या करेगा, it will take away the sediment, so it should have absence of very strong wave. Third point, at the mouth, this region, you know, there is no down warping. अगर ये डाउन वार्पिंग है यहाँ पे, वहाँ नीचे जा रहा है ये, तभी भी नहीं होगा। डाउन वार्पिंग शुड नॉट बी देयर, इट शुड हैव लाइक यू नो, इट मीन्स एट द माउथ यू शुड नॉट हैव ए सबमर्जन कोस्ट। इमर्जन कोस्ट इज ओके, सबमर्जन कोस्ट नहीं चाहिए। कोस्ट शुड नॉट बी ए सबमर्जन कोस्ट, ओके। सो इन दैट कंडीशन देयर इज डेवलपमेंट ऑफ डेल्टा। So deltas are of different shape. Based on the shape, it can be arcuate delta. Arcuate mean ARC. Arcuate mean fan shaped delta. First is arcuate delta. ARCUATE. Arcuate delta mean fan shaped delta. थोड़ा सा चेंजेस होता है शेप में, इट कैन बी फैन शेप, इट कैन बी आर्कुएट डेल्टा। बेस्ट एग्जाम्पल इज गंगा, हुआंगहो, पो, राइन। गंगा, हुआंगहो, पो रिवर, राइन रिवर। गंगा इन इंडिया, गंगा इन इंडिया, बांग्लादेश, सुंदरबन डेल्टा। हुआंगहो इन चाइना, पो इन इटली, राइन इन जर्मनी, नॉर्थ सी के पास जाके ये राइन डेल्टा है। आर्कुएट डेल्टा, आर्क शेप की डेल्टा है। क्वेश्चन आते हैं व्हाट टाइप ऑफ डेल्टा इज देयर इन दिस पर्टिकुलर रीजन। आई होप यू विल एबल टू डू दिस। आर्क शेप्ड और आर्कुएट डेल्टा, गॉट इट? आर्कुएट मीन फैन शेप्ड। सेकेंड वन इज बर्ड्स फुट, second one is bird's foot delta. Bird's foot delta, it looks like bird's foot, like you know, digitated बोलते हैं, इसको बोलते हैं digitated delta also. It is also called as a digitated delta. Bird's foot or digitated delta. Digitated, this type delta form outgrowth of natural levee. आपका ये जो ना, this is bird's foot, very irregular, ऐसे रहेगा bird's foot like this, outgrowth like this, ऐसे deposition, bird's foot, this type of delta. ये डेल्टा क्या था? आर्कुएट, आर्कुएट, आर्क शेप, फैन शेप्ड. This is bird's foot. Okay, Mississippi, Missouri delta in USA, Gulf of Mexico region. Best example is Mississippi, Missouri delta is the bird foot delta, the best example in the world it is. Okay. Third type is estuarine delta. Estuarine delta, delta at the mouth of an estuary. The delta at the mouth of a river near its estuary. They are very unique. Very unique, you will find out this type of estuarine delta. Okay. These are very narrow and linear delta. एक अगर कोई भी river, let us say this is an estuary, okay. This is the ocean. In the ocean, a river is finally draining into the estuary, right? This is a river. So what will happen? This river will deposit here sediments. When it is like a very linear way, there is sediments are there at the mouth here itself. There is an estuary. So not inside, it is inside here you will have like this type of linear delta you will find out. This is very exceptional case. Best developed delta, estuarine delta, is of river let me tell you in our Narmada estuary we have delta, Tapi estuary we have development, very बहुत छोटे छोटे हैं ये Narmada and Tapi. We have also river like Amazon river, Congo river, These delta are estuarine delta. Deltas in the estuary, inside the estuary. Okay, deltas inside the estuary. These very unique cases you will find out here. Okay, got it? Fourth type of delta is cusped delta. Cusped delta mean tooth shaped delta. Tooth shaped delta. So here you will have like this is a river channel in which they develop. This type of cusped delta, you will find out cusped delta, symmetrical delta होता है ये. Best example is there is a river known as Tiber river in Italy. Tiber river delta in Italy. Best example. Cusped delta. I will show you here. Tiber river image. Tiber river delta is best example. This is the river, Tiber river delta. This is. In fact, it is here. Tiber river. You can see, you can find out this, like river delta, very different from others. Satellite images can give the better idea on this. Tiber river delta is like cusped, दांत जैसा आपके tooth shaped delta. They are cusped delta. I hope you got it now. Lacustrine delta mean inside the lake, if the delta is forming inside the delta, lacustrine. Fifth one, lacustrine delta. Formation of delta inside a lake. Lacustrine delta, because while it draining the lake inside the lake, so the in fact they are very important here. This type of delta Caspian Sea में है. Caspian Sea, in the Caspian Sea, example Volga river delta inside the Caspian Sea. Very huge delta is there, Volga river. Volga delta, Volga river delta. Let me show you satellite picture. If it is available, you see here, Volga river delta. Best example. Volga river delta, you can see that this Volga river delta is the best example here. Volga river delta will have like all best example you can say. This is Volga river delta. Satellite pictures of Volga river delta, you will see that Volga inside the Caspian. Caspian Sea is a lake, you please remember. Volga delta is I have just given. So these are like an example I have given here. I hope you got it now. The most important things you know about this is like different type of what you call landform. It develops because of this particular characteristics. Glacial, other landforms, among these a fluvial landform जो है बहुत ही important है. That's why I have done this. Hope you will spend some time and look at this. NCERT or JCLog, you can see the images whatever they are. Concept is this much. I hope you got it. Let me see if any questions you have. Cuspid is more looking like a foot. मेरा drawing ऐसे आए. सर PYQ डेल्टा से कैसे आए हुए हैं? सीधे questions will be direct, Nile river has what type of delta, or matching question statement is correct, which one they have given. डेल्टा meandering सेम है लग रहा है सर, प्लीज क्लैरिफाई. ए भाई, डेल्टा इज ए डिपोजिशनल लैंडफॉर्म at the mouth, meandering in the river path where it is like, okay, the river which is draining, meandering river. आप लोगों को इतना भी पता नहीं तो मैं क्या करूं भाई. ओके, लेट मी सी meandering river. एक फोटो दिखाता हूं, रिवर इमेज करता हूं. ये देखो, this is a meandering river. Okay, a river is meandering gradually. ये ठीक रहेगा विकिपीडिया से. You can see this. River has meander path. देखो ये रिवर कहाँ से आ रही है. Here it is coming like this, ऐसे होते हुए ऐसे जा रहे हैं ना. तो यहाँ से जब आ रही है इधर, यहाँ पे ये अगर जोड़ गया तो ये ऑक्सबो लेक हुआ कि नहीं यहाँ. दैट्स व्हाट आई एम सेइंग. थोड़ा समझो, कुछ भी पढ़ा नहीं लग रहा है भाई. चलो ठीक है, कोई बात नहीं. इज इट क्लियर? ओके. एस्चुरी क्या होता है? Estuary is a deep valley at the mouth of a river. Estuary is a deep valley at the mouth of a river, generally formed because of, mostly due to submergence of the river valley or the coast. Submerge कर जाता है पानी में तभी. एस्चुरी इसको कहते हैं, वेरी डीप प्रोफाइल होता है, वेयर इनफैक्ट स्टीप स्लोपी कंडीशन प्रिवेल, दैट्स वाई जनरली पोर्ट के लिए अच्छा होता है। तो डेल्टा के आगे मैंने आपको जो बनाया था, इफ यू हैव सीन एट द माउथ, आई हैव डन टू थिंग्स देयर, इफ यू हैव सीन दिस, लेट मी लुक एट द एस्चुरी हियर, एस्चुरी यहाँ पे एस्चुरी है, यहाँ पे पोर्ट बन जाता है, यहाँ पे डेप्थ ज़्यादा है, पोर्ट बनेगा, यहाँ पे एस्चुरी है। एस्चुरी में ये डीप ड्राउन वैली, ये जो है ना नदी आ रही है, दिस इज द रिवर हियर, दिस रिवर इज ड्रेनिंग इनटू दिस, फॉर्मिंग ए river, part of the river valley submerged in the ocean is estuary. Okay, deep one. It is suitable for formation of port, natural port. Next one, ये जो आपने बोला डेल्टा meandering सेम है, लग रही है, तो डेल्टा तो अलग है, meandering समझ में आया कि नहीं भाई? You got it. This is the meander and delta I have already done. डेल्टा के सैटेलाइट पे पिक्चर में दिखाता हूँ, डेल्टा और इमेजेस। ओके, देखते हैं कोई डेल्टा का इमेजेस कोई होगा। ये देखो कितना सुंदर दिया है, दिस इज ए डेल्टा, सी हियर, दिस इज द रिवर डेल्टा एट द माउथ ऑफ ए रिवर। ये कैसे लग रहा है? ये रिवर फाइनली ड्रेनिंग इनटू द सी। कैन यू सी दिस? ये भी डेल्टा है, ऐसे रिवर इज फ्लोइंग, यहाँ से नाइल रिवर की डेल्टा है, सैटेलाइट पिक्चर है ये रिवर इज फ्लोइंग लाइक दिस। रिवर देखो आप, डिस्ट्रीब्यूटर सब है, रिवर ये सब जा रहे हैं, डेल्टा है ये पूरे रीजन्स। डेल्टा इज गोइंग टू द माउथ ऑफ द रिवर। Okay, it is done. Again one more question, delta or meandering difference, I hope you got it. सर PYQ डेल्टा से कैसे आए हुए क्वेश्चंस आएंगे डायरेक्टली कि टाइप ऑफ द डेल्टा एंड द नेम ऑफ द रिवर, ओके, and may be condition for the development of delta. Cuspid is more looking like a foot. Yes, it is. Cuspid, दांत जैसा लगता है, ऐसे होगा, tooth shaped है, cuspid delta tooth shaped होंगे. So these are certain things. I hope you will able to get the things here. Right. आफ्टर दिस ग्लेशियल एक्शन पे चलता हूँ, कुछ इंपॉर्टेंट ऑन ग्लेशियर पार्ट आई विल डिस्कस, नॉट ऑल, जो हमारा एग्जाम पॉइंट ऑफ व्यू से बहुत बहुत इंपॉर्टेंट है। अच्छा, ये तो इरोजनल और डिपोजिशनल लैंडफॉर्म हुआ, फ्लूवियल यू नीड टू डू, आई होप यू हैव डन ऑफ दिस। नाउ ग्लेशियल एक्शन, ग्लेशियल लैंडफॉर्म, आई विल जस्ट से समथिंग इन द ग्लेशियल लैंडफॉर्म एक्शन। व्हाट इज द एक्शन ऑफ दिस वन? एक्शन आई टोल्ड यू, इरोजन में abrasion and plucking. When a glacier moves, it forms a valley which is U-shaped valley. U-shaped valley, glacial valley is glacial valley. U-shaped valley बनाती है. You remember first point. रिवर जैसे, रिवर ऑलवेज फॉर्म ए वी शेड वैली, ग्लेशियर ऑलवेज इट विल फॉर्म ए यू शेड वैली, ग्लेशियर विल ऑलवेज फॉर्म्स ए यू शेड वैली, ओके, ग्लेशियर विल ऑलवेज फॉर्म्स ए यू शेड वैली, प्लीज रिमेंबर, यू शेड वैली आर फॉर्म्ड बाय ए ग्लेशियर, एंड व्हेन दिस यू शेड वैली गॉट सबमर्ज इन वाटर, पानी में डूब गया, अगर ये पूरे पानी में डूब गया तो इसको बोलते हैं एक फ्योर्ड or fjord, FJORD. This fjord is the submerged U-shaped valley. At the coast is known as fjord. Fjord क्या है? Submerged U-shaped valley at the coast. Please remember. जब U-shaped valley अगर submerge कर गया तो इसको बोलते हैं क्या है? फ्योर्ड कहते हैं। जैसे आपको थोड़ी देर पहले एस्चुरी बताया था, एस्चुरी रिवर वैली, भी शेड वैली जब सबमर्ज करता है ये होता है क्या, दैट इज नोन एज एस्चुरी। एस्चुरी इज द सबमर्जेंस ऑफ भी शेड वैली एंड फ्योर्ड इज द सबमर्जेंस ऑफ U said valley. U said valley submerge and it form the U said valley will form what? The U said valley will always form by the glacier. U said valley are formed by the glacier, and very importantly you must remember this U said valley when it got submerged it forms a estuary. You see the beautiful picture here of estuary. Estuary, at the mouth of the river you have the estuary, but what is fjord? Sorry, fjord पे चलते हैं. This type of beautiful valleys, देखो आप ये पूरे रीजन जो है ना, दिस इज ए fjord. Fjord you can see, U shaped valley developed by the glacier. यहाँ पे कभी ग्लेशियर इधर से आया होगा, because of that only when it got submerged in water it became a fjord coast, and fjord coast wherever is there is beautiful, and the fjord coast are responsible for more and more natural port. ये यहाँ पे देख रहा है ना आप, नदी जैसा लग रहा है, it is a fjord coast है, this is a fjord coast, remember, and this fjord coast is the best example fjord coast you will have here. ये देख रहे हो ना ये, here these are fjord coast, all these are fjord, very irregular coast you have because of glacial erosion. Which is this country? कौन सा country है ये? You can say this is Nordic country जो, Norway, Sweden, Denmark and all these, you know, these countries, these regions you are having this, Norway coast, northern part, we have this type of coast. So I hope you got it now. This is the best example here, fjord coast. Fjord coast are highly irregular coast here, highly irregular with more and more number of your natural ports. Hopefully you will may get question from this part like. And another things, let me tell you, when the glacier, this is the glacial erosion से बना, deposition से एक होता है moraine. What is that? Glacial deposition से moraines. Moraines are depositional landform by a glacier. When a glacier moves, अगर एक glacier ऐसे move कर रहा है, इधर जा रहा है glacier, and at this glacier's margin we have deposition of sediments here. These sediments are unsorted one. Unsorted mean कुछ होगा different type का होंगे यहाँ पे. Unsorted materials are there. They are known as moraines. These are called moraines. Moraines. Moraines are of different types, but you remember जो साइड में होगा lateral moraine, दोनों साइड होंगे, तो आगे होगा तो end of the glacier, end moraine or terminal moraine. There are different name for the moraines here. So images of the moraine I can show you. Moraine is a depositional landform. Moraines, glacial depositional landforms. Moraines की images हम देखते हैं अभी देखो. When a glacier moves, when a glacier is moving, you see here, when a glacier is moving in any regions, a glacier is moving here. देखा आपने? Moraines deposit. A glacier move कर रहा है तो ये साइड पे मोरेनिक डिपोजिट, ग्लेशियर आ रहा है. दिस ग्लेशियर, मूविंग रिवर ऑफ आइस इज ग्लेशियर, साइड डिपोजिट होगा. दिस इज कॉल्ड एज मोरेन. Moraines are glacially deposited materials. Let me show you one more images National Geographic one will give us better one. You see, when a glacier moves, a glacier जा रहा है, साइड डिपोजिट होगा लेटरल मोरेन है, एंड इफ इट इज लाइक, देखो, इज ए ग्लेशियर व्हेन इट मूव, डिफरेंट टाइप ऑफ, ये ग्लेशियर मूव कर रहा है, ये अनसर्टेड मटेरियल आर नोन एज मोरेन्स. अनसर्टेड मटेरियल मीन कुछ भी है ठीक से शॉर्टिंग नहीं है, बड़े बड़े बोल्डर, पेबल, कोबल्स कुछ भी हो सकते हैं, दीज आर मोरेन. सो ये जो ग्लेशियर है मोरेन, आप यहाँ पे देखो, here you can see, if it is a glacier here, a glacier is flowing in this way, glacier is flowing in this way, देखा आपने, ग्लेशियर ऐसे फ्लो कर रहा है ऐसे, तो ग्लेशियर का, this is a glacier which is moving in this way, this is another glacier is moving in this way. ये हो गया आपका टर्मिनल मोरेन, टर्मिनल मोरेन. साइड पे जो होगा दैट इज नोन एज लेटरल मोरेन. ये दोनों लेटरल मोरेन मिल जाएंगे तो हो जाता है इसको मीडियल मोरेन. मैं इसको ड्रॉ कर लेता हूँ. हियर इट इज नॉट क्लियर, सो लेट मी ड्रॉ इट. लुक एट हियर केयरफुली. व्हेन ए ग्लेशियर मूव्स इन ए पर्टिकुलर डायरेक्शन, this is a glacier is moving in this direction, another glacier is moving in this direction, let us say. दोनों ग्लेशियर यहां पे एट देयर, यहां पे डिपोजिट करेगा, साइड भी डिपोजिट करता है. इसको कहते हैं क्या? दिस इज कॉल्ड एज lateral moraine. This is also called as here lateral moraine. This is here is known as terminal or end moraine. Remember, moraines are unsorted rock fragments, sand, silt, boulders, etc. deposited at the margins of a glacier. At the margins of a glacier, all these things are deposited. They are called as moraine. Unsorted material, rock fragments, sand, silt, boulders, sand, silt, boulders are deposited. They are called as, here is साइड में जो होगा वो हो गया लेटरल मोरेन. आप देखो यहां पे भी तो ऐसे मोरेन बनेंगे. हियर ऑल्सो देयर विल बी मोरेन्स. हियर व्हाट एवर मोरेन दिस इज एंड मोरेन, एंड मोरेन. बट यहां पे भी एक मोरेन होगा, ये लेटरल मोरेन, दोनों लेटरल मोरेन यहां मिल गए हैं. दिस इज नोन एज द मीडियल मोरेन. मीडियल मोरेन. द moraine, two glacier while they meets nearby, lateral moraine of the two glaciers also join together to form this, what is this moraine? Medial moraine. Please remember, they are called as the medial moraine. डिफरेंस बिटवीन फ्योर्ड एंड गॉर्ज, आपको दिख रहा था वो गॉर्ज जैसा, क्योंकि आपने समुद्र को देख नहीं पाया। याद रखें, पहला, फ्योर्ड इज ग्लेशियली डेवलप्ड, गॉर्ज इज डेवलप्ड बाय द रिवर, फर्स्ट पॉइंट। सेकेंड, फ्योर्ड इज ऑलवेज एट द कोस्ट, कोस्ट में होगा वो, फ्योर्ड इज ए कोस्टल टाइप, गॉर्ज इज ए लैंडफॉर्म इन द माउंटेनियस रीजन, ओके, ये कोस्ट में होगा। फ्योर्ड इज वेरी डीप, gorge is also deep, gorge is because of erosion by the river, no doubt, gorge also deeper one, but U shaped valley नहीं होगा, gorge is always I shaped valley, I जैसा, I shaped, and fjord are U shaped valley. Glacier depositional landform, moraine versus river depositional landform, my friends, ग्लेशियर का जो लैंडफॉर्म होगा डिपोजिशनल, ये बड़े बड़े बोल्डर, एक ग्लेशियर जा रही है, इफ ए ग्लेशियर इज मूविंग, नाउ यू थिंक इफ ए ग्लेशियर इज मूविंग लाइक दिस, इट विल टेक एवरीथिंग ऑन इट्स वे, जो भी चीज आएगा रास्ते में सबको लेके जाएगा, यहां डिपोजिट होते रहेंगे। सामने में डिपोजिट हुआ उसको क्या कहेंगे, एंड मोरेन और टर्मिनल मोरेन, बोथ साइड जो होगा इसको बोलते हैं लेटरल मोरेन, समझ में आया। नाउ व्हाट हैपन हियर, ये जो मटेरियल होगा ना, सैंड, सिल्ट, बोल्डर, मगर वहां पे इन द आवर रिवर में ये अनसॉर्टेड नहीं होगा, सॉर्टेड होता है, फाइनर मटेरियल बहुत दूर जाते हैं, कोर्स मटेरियल पास में रहेंगे, है कि नहीं। आप कोई भी एक नदी में जाओ, यू गो इनसाइड ए रिवर, यू विल फाइंड आउट रिवर इज जॉइनिंग द ओशियन, लेट अस से डेल्टा रीजन्स, नियर द कोस्ट यू हैव सैंड, उससे पहले होगा बोल्डर हो सकता है, जितना अंदर जाओगे सिल्ट होगा, उसके बाद क्ले होगा इनसाइड, बट ऐसे नहीं है यहाँ, नो सॉर्टिंग आउट, अनसॉर्टेड लिखा ना, मिक्सचर ऑफ एवरीथिंग यू विल गेट हियर। सो देयर आर टू ग्लेशियर, लेट अस से दिस इज टू ग्लेशियर्स हियर, हियर इज वन अदर, दोनों ग्लेशियर का जो मिडिल में, ये ग्लेशियर का ये टर्मिनल मोरेन है, दिस साइड इज व्हिच मोरेन, लेटरल मोरेन, दोनों ग्लेशियर के लेटरल मोरेन जब मिल जाएंगे तो ये हो गया मीडियल मोरेन। मीडियल मोरेन इज बिटवीन, इट इज डेवलप्ड ड्यू टू कन्वर्जेंस ऑफ टू ग्लेशियर्स, एंड द ग्लेशियर्स व्हाइल दे मीट्स दे विल गेट, ये देखो दोनों मिल गया मीडियल मोरेन, ये लेटरल है, ये लेटरल है, दोनों मिल गया, यहाँ पे ऐसे आ रहे हैं, ग्लेशियर मिल गया था, ठीक है। होप यू गॉट इट नाउ। नाउ meander, estuary, delta, meander versus river depositional landform, meander, estuary and delta. Delta is depositional, meander is the case of, you know, what is a meander? Meander is a zigzag path developed by the river. Estuary is a completely submerged platform inside the ocean.
Okay, I found this on the
Got it now? और चाहिए कुछ तो बोलो भाई, आप दुखी नहीं होना है। You got it or not? Glacial depositional landform, you said moraine versus river depositional landform, दोनों मिला। meander, estuary and delta. meander तो, अरे meander रिवर जो है ना, बिफोर ज्वाइनिंग द ओशियन ऐसे होता है, इसको meander कहते हैं, समुद्र से मिलने से पहले। मुझे लग रहा है यू मस्ट बी फ्रॉम समवेयर अवे फ्रॉम द रिवर, रिवर वैली, तुम समुद्र देखा नहीं होगा लग रहा है? अभी भी मैं सैटेलाइट पिक्चर भी देखा है यार, आप लोग ना कुछ भी पढ़ता नहीं है, यू डोंट नो द meander, you don't know, estuary you don't know, this is not good. पूछा तो ठीक है, मगर आज मैं रिक्वेस्ट कर रहा हूं आप थोड़ा पढ़ लीजिए, नहीं आता है, आई हैव गिवन लाइक यू कॉल मी, बट आई रिक्वेस्ट यू मस्ट डू दिस, इट्स सो बेसिक थिंग्स। एस्चुरी क्या है? एक रिवर वैली है पानी का। अच्छा एक चीज, इन द लास्ट क्लास आई डिड मेंशन कोणार्क was built up inside the ocean, now it is away from the coast, बोला था ये। I said also Gujarat coast पे if you'll see the what you call Dwarka is now submerged inside. Now what happened? Also I have mentioned in the last class, I was just doing that the subsidence of the western part of India, मैंने बताया था ना आपको, तो the river valley what it was there earlier got submerged, तो एस्चुरी हुआ, इसलिए वेस्ट कोस्ट में ज्यादा एस्चुरी है। दैट इज द कॉज वेस्ट कोस्ट मोर एंड मोर नेचुरल पोर्ट्स आर देयर। Okay, thank you very much. Learning, very nice. Thank you very much. Any problem, tell us. Yeah, come on. ये क्या है कि because these are some basic things, you must able to imagine the things. Very interesting these are all. Geography is what you can see, we can observe. इसमें कुछ है ही नहीं ऐसे कि कोई डिफिकल्टी लगे. आपका ये जो meander का है, meandering are this, एक क्वेश्चन आया भी सकता है, नहीं भी आ सकता है. वेटेज ज़्यादा नहीं देना है हमें, टाइम बहुत कम है. सो आई विल से ये जो है ना दिस रीजन्स पर्टिकुलरली द केस ऑफ ग्लेशियल लैंडफॉर्म, यू रिमेंबर meanders, this is what is that, moraines are very very important. Moraines, three types of moraine I said, lateral, terminal, medial. और भी है, ग्राउंड मोरेन है, और एक बोलते हैं व्हेन द ग्लेशियर मूव डाउन, पिघल जाता है ना ग्लेशियर, इट कैनॉट कैरी मटेरियल, सो इन बिटवीन छोड़ता जाएगा मटेरियल को. दीज आर नोन एज ग्राउंड मोरेन. ग्राउंड में मटेरियल छोड़ते जाता है, जो मटेरियल जो बड़े बड़े बोल्डर पेबल्स है ना, उसको एज इट इज छोड़ के आगे चला जाएगा. तो दीज आर नोन एज ग्राउंड मोरेन ऑल्सो. वेरी नाइसली गिवन फोटोग्राफ्स आर देयर इन योर GC Leong book. I found, what I feel or perceive based on the questions, what I am getting and all, you haven't prepared properly. I thought like to take the questions and solve answer and all, quickly to move, but it will be difficult, I think. So I request you all, those who have not yet practiced or not yet given the concept, fundamental things, are requested again to go back to that basic things, just see that, or listen to the class carefully and page number whatever I will say, just study that. Page number or chapter of one thing. Moraines I have said, in GC Leong there is a glacial landform chapter in which moraines are given. Only moraines आप देखो, moraines are important for this. Okay. So rest are not very important, but these are like some of the important landform, as I said. These are the most important landforms. You must see these landforms. So as I was saying, this is weathering, erosion we have done. Important landforms, these are the things which we have done. So landform में कुछ पूछना है तो बताइए specifically if you want to ask anything, because landform is a very vast area, but you need to confine yourself to, I am saying, two things, because river is important, because landform related things they are asking question. Glacier, because of melting of the glacier nowadays more, so they are in news. That's why I am saying these two are very important. Only these two landform you can see, you cannot cover the entire things. Okay. Got it? Okay. Okay. Done? Okay, fine. So I will go for structure and composition of the atmosphere. Structure and आपको जियोमॉर्फोलॉजी में वॉट एवर इंपॉर्टेंट एरिया आई जस्ट सेड, विल यू बी एबल टू डू दैट? जितना मैंने ये टॉपिक ज़्यादा नहीं करना, यू जस्ट हैव टू गो फॉर दिस. एक है टाइप ऑफ कोस्ट, एक होगा टाइप ऑफ कोस्ट में एक एस्चुरी जैसा है. लेट अस से मैंने एक वन मोर यू कैन सी टाइप्स ऑफ कोस्ट. वन इज type of submerged coast. One is estuarine coast, Dalmatian coast, fjord coast, deltaic coast. अच्छा, एस्चुराइन कोस्ट आपको याद हो जाएगा, वॉट एवर आई सेड, एस्चुराइन कोस्ट याद होगा. व्हेन ए रिवर वैली और ए वेरी स्टीप स्लोप एट द माउथ विल हैव बिकॉज ऑफ राइज इन द सी लेवल और सिंकिंग ऑफ द कॉन्टिनेंटल पार्ट. ठीक है, रिवर एस्चुराइन कोस्ट याद होगा क्या? इफ दिस इज द कोस्ट, एस्चुराइन कोस्ट है वेस्ट कोस्ट ऑफ इंडिया, western coast of India, that is Narmada, Tapi. डालमाटियन कोस्ट देखो, अगर कहीं पे ये लेट अस से देयर आर माउंटेन्स, these mountains got submerged in the water ड्यू टू एनी कॉज, ये पानी में डूब गया. इट वॉज ए कंटिन्यूअस माउंटेन, लेट अस से इट वॉज ए कंटिन्यूअस माउंटेन अर्लियर. पहले एक बड़ा सा माउंटेन ऐसे था, एक माउंटेन ऐसे था, एक माउंटेन ऐसे था. सब्सिक्वेंटली व्हाट हैपेंड, पानी का लेवल बढ़ गया, तो ये जो माउंटेन है इतना बड़े बड़े सब माउंटेन सब क्या हो गया, ये सब माउंटेन डूब गए पानी में, ऐसे बन गया कोस्ट में. द माउंटेन्स विच आर पैरेलल टू द कोस्ट गॉट सबमर्ज्ड. क्यों सबमर्ज किया? मे बी बिकॉज ऑफ टेक्टोनिक एक्टिविटी और राइज इन द सी लेवल, कुछ भी चीज हो, अगर सबमर्ज कर जाएगा तो एक स्पॉटेड आइलैंड टाइप ये सब बना. इसको बोलते हैं डालमाटियन कोस्ट. डालमाटियन कोस्ट याद होगा. सबमर्जेंस ऑफ mountains parallel mountains located at the coastal margins. कोस्ट की मार्जिन में सब डूब जाएंगे पानी में. सबमर्जेंस ऑफ द पैरेलल माउंटेन्स एट द कोस्टल मार्जिन. Someone is now saying, sir, रोचे मोटेनी लैंडफॉर्म ड्यू टू इरोजन. यस, इरोजन से होते हैं, डिपोजिशन नहीं है. रोचे मोटेनी एंड क्रैग एंड टेल बोथ आर इरोजनल. वो ग्लेशियल इरोडेड है, उतना डीप में तो नहीं पूछेगा. आप देखो यहाँ पे, यू गॉट इट नाउ. सबमर्जेंस ऑफ parallel mountain located at the coastal margin are called as Dalmatian coast. कारवार कोस्ट, हमारा यहाँ पे कारवार कोस्ट है ना. कारवार किधर है? कर्नाटका में. डू यू नो? डालमाटियन कोस्ट इमेज. ये देखो, कैन यू सी दिस? क्रोएशिया की कोस्ट में देखो, ये देयर आर सो मेनी स्मॉल आइलैंड्स आर देयर इन द कोस्ट. देख रहे हैं, ये दीज आर माउंटेन, सबमर्ज माउंटेन. इनफैक्ट practically these are submerged mountain. This is called as Dalmatian coast. You got it now? Dalmatian coast. Dalmatian coast. आप देखो इंडिया की कारवार कोस्ट इमेज. Karwar coast has such type of Dalmatia type. Dalmatian type of coast here, Karwar coast. In India, you have Karwar coast has such type of Dalmatian type coast you have. Very beautiful coast you have. Where is Karwar? Karnataka. You see here, these are, you can you see these things? If it is not clear, let me. ये देखो एक आइलैंड है, ये देखो एक आइलैंड है, ये देखो एक आइलैंड है, इधर भी है, ये सब जुड़ा हुआ है। दे आर पार्ट ऑफ माउंटेन कोई होगा, इट इज सेटेलाइट इमेज, यू कैन सी a photograph, aerial photograph, you can see this. Dalmatian coast are the coast where the parallel mountains in the coast they got subsequently submerged. ठीक है. Fjord coast I told you these are U-shaped valley which got submerged. U-shaped valley, U-shaped valley जो submerged हो गया. Glacial U-shaped valley, glacial U-shaped valley, submerged glacial U-shaped valley is this one. Submerged glacial U-shaped valley is this valley. Deltaic coast, depositional delta, at the mouth of a river. रिवर माउथ में डेल्टाइक कोस्ट होते हैं, डेल्टाइक कोस्ट. So these are certain things. I hope you got it. There is no problem, I hope. Got it now? Clear? Let me now go for the topic as I was talking about. So, this is their structure and composition of the atmosphere. Now, I will do this, then the pressure belt also there. Structure and composition of the atmosphere. My friend, as all of us were well aware about this topic, like from climatology you will get good number of questions, friends. The topic which I will deal, बहुत ही ज़्यादा क्वेश्चन आएगा. You remember, this is about climatology I am saying now. In the climatology part, I say first I am talking about structure and composition of the atmosphere, structure and composition of the atmosphere. See, Earth atmosphere gradually evolved through time with the evolution of the Earth itself. Okay, when the Earth got cooled down from stellar material, I told you earlier that when it got cooled down, the upper part got solidified, denser material got accreted at the center. I have already said this, the densest material got accreted at the center, lighter one towards periphery. The uppermost part, solid uppermost part it developed, known as the crust. During this period, cooling period, it radiated gases. It in fact gradually the atmosphere was formed because of the gradual occurrence of gravity, development of gravity of the earth, gravitational field. Now what happened during this phase, when that it got cooled down, it released different type of gases known as the degassing phenomena. This is associated with large scale volcanic eruption also. So the present atmosphere is an outcome of gradual cooling, solidification and degassing phenomena. Please note down this part. The present atmosphere of the earth is an outcome of gradual cooling, solidification and degassing phenomena, outcome of gradual cooling, solidification and degassing, outcome of gradual cooling, solidification and degassing phenomena over the Earth's crust. Degassing का मतलब ये है कि different type of gaseous material, it gradually different type of gaseous material were released by the Earth atmosphere. I hope you got it. By the way, if you will see our atmosphere, there is a fixed concentration of different gases. Like as all of us were well aware, we have nitrogen, you have oxygen, you have argon. Nitrogen is 78 point, nitrogen 78.08%, you know, 78.08, oxygen is 20.94, 20.94%. You have like same way, we have minerals, the gases like argon, argon is 0.934, argon 0.93. Then you have carbon dioxide 0.003 or 03%. Carbon dioxide 0.03, 031 कर दो better है, 031%. So ये जो है ना, these are the gases which are fixed. Now what is happening? Gradually, a small change in their proportion may have catastrophic impact. कार्बन डाइऑक्साइड थोड़ा सा भी अगर घट जाएगा, बढ़ जाएगा, तो टेम्परेचर कंडीशन ऑन द अर्थ एटमोस्फियर विल definitely it will change. Drastic change will happen. So the structure and composition of the atmosphere is greatly related with what? It is greatly related with the Earth's gradual evolution also. By the way, as I have just said, our Earth has different atmosphere. We usually call, these are like, you know, one by one, if you will go up from the Earth's surface towards up, if you will go, we have different concentration of gases. Denser gases you will find out in the lower part and less denser gases towards up if you will go. Look at here, ये तो gases है, there are different other things also. There is also dust particles, there is also water vapor. They are also present. Presence of dust particle and water vapor plays a very important role on cloud development of cloud. They are different impact also. Development of cloud is greatly associated with the presence of concentration of the dust particles as well as the presence of the water vapor. What is the percentage of water vapor, how much is there, what exactly is the phenomena, we need to see this very very carefully. बहुत ही important है ये वाला जो है ना dust particle water vapor के, you need to see based on this characteristics of the cloud also will have. Now let us look at, if it is there, I will say our atmosphere is divided into various distinct layers or zones on the basis of its composition, its structure and composition. These are our Earth atmosphere is divided into various structure and various layers on the basis of structure and composition. Number 1, troposphere. Number 2, stratosphere. Number 3, mesosphere. Number 4, ionosphere. Number 5, exosphere. Again I am saying our Earth atmosphere is divided into several distinct zones of troposphere, stratosphere, mesosphere, ionosphere, exosphere. Can you just see these things? Check it out. Yes, troposphere, stratosphere, mesosphere, ionosphere and exosphere. These are the zones here. Clear, eh? The upper part ionosphere is known as thermosphere also. Thermosphere. Is it okay? This is also known as the thermosphere. Which one? These two are also called as thermosphere sometime. What is there we will see now. First I will go for the troposphere. What is there in the troposphere? Troposphere is the zone of mixing of all gases. Okay? Tropos. The tropos mean mixing. Mixing of all different gases is troposphere. Zone of mixing of all gases is troposphere. Troposphere is the zone of mixing of all different type of gases. Troposphere. Right? In this troposphere, as I have just mentioned, zone of mixing of all gases, troposphere, lowest layer of the atmosphere. This particular region is in fact, truly speaking, this is the zone which is responsible for almost all atmospheric phenomena. Lowest layer in our atmosphere. Its thickness varies from the equator to the poles. Equator to the poles. Its thickness varies from equator to the poles. It is 8 km near poles and 18 km at the equator. At the equator it is 18 km. 18 km at the equator. 8 to 18 km variation is there. Why this variation? Let us see now. Why this variation? We will see now. let us say this is the earth, okay. If this is the earth here, the equator, okay. Remember, this is the troposphere here. This is the troposphere. Here you have the equator. This is the pole, North Pole. Here you have the South Pole. Remember at the equator, temperature is very high. Because of which what happened? This air parcel goes upward. Why? High temperature leads to high convectional instability. At the equatorial region, you have temperature is much more. Temperature is more at the equatorial region. Temperature is very high at the equatorial zone. So, more convectional instability takes place. This leads to the vertical rise in the air parcel. Okay. Up to 18 km disturbances you will have in the upper part at the equator, 0 degree equator it is, 90 degree it is pole. So, near the equator, the most important thing here happen. What is there? Near the equator, the convectional instability is much high. So, the convectional, this part, you know, it moved upward. Okay. So, here you see here that the equatorial region, at the equatorial region there is vertical rise in the air parcel. Why? High temperature leads to low density of air. Low density of air leads to upward rising of the air parcel. When the air parcel will move upward, it goes upward, because in the upper part of the atmosphere the pressure is bit less, so it got diverged like ऐसे हो जाएगा. When it goes up, it goes like diverge like this, goes up, diverge like this, right? And this leads to, when it goes up, it diverges, and this particular phenomena leads to more convectional instability. This leads to increase in the height of the zone of mixing of different gases. So, here it is up to 18 km height, it goes up to 18 km height, here also up to 18 km height, here is nearly 8 km, here is nearly 8 km. So, this particular zone is primarily associated with thermal factor, temperature. You remember, with increasing height there is a decrease in the temperature also in the troposphere. This is known as the lapse rate. आप देखो, आप अगर कोई हिल स्टेशन में जाते हो, हाइट के साथ साथ टेम्परेचर घटता है ना, व्हाई इट इज देयर? Can you see this? And look at it, very, very important it is in fact. Okay. Okay. Now, you can see this like okay, fine. Look at here. In this case, if this is the earth here, here temperature is more at the equator, because of which, you know, high temperature, convectional instability is more. So, air will move upward here, it is going upward. It is like, you know, convectional instability is there. If you remember, I told you earlier that we have a very, very important one point. I told you earlier that whenever you are boiling the water in a particular regions, whenever you are boiling the water from below goes upward, and it will have like, you know, circular movement. Likewise, air will get a convectional instability here, so it move upward, it goes upward. Because it goes upward, here the mixing zone is much higher, but here it is like, you know, this polar area you have at the poles. What is here? At the poles you have, at these both north and south pole, high pressure belt. Sinking of the air you have here. Air is sinking, due to which the convectional instability is not there. Sinking of the air leads to lowering of the zone of mixing of gases. So, you have 8 km here, 18 km here. I hope you got it now. Here you have 8 km at the poles, at the equator you have 18 km, and this is here is the zone of mixing of all gases known as troposphere. Okay, clear? Hai? Next point, troposphere is associated with almost all major atmospheric phenomena like almost all atmospheric phenomena like cloud formation, precipitation, cyclone, anticyclone, cyclone, anticyclone, cloud formation, precipitation, cyclone, anticyclone, etc. जो भी है एटमोस्फेरिक सर्कुलेशन एवरीथिंग रिलेटेड विद दिस पर्टिकुलर जोन, क्लाउड फॉर्मेशन लेके अभी तक कोई भी है, एवरीवेयर इट इज एसोसिएटेड. ओके, troposphere is associated with almost all a major atmospheric phenomena like cloud formation, precipitation, cyclone, anticyclone, etc. Why? Because this zone comprises more than 95% of all atmospheric moisture and more than 95 more than 99% of all atmospheric moisture and 95% of all atmospheric dust particles. I told you wherever you have dust particle and wherever you have moisture, they will definitely act in a different way and it will have major impact. This will also happen with this particular region. तो क्या होगा? What will happen here? Let us see. I said almost all major atmospheric phenomena is associated with it. Almost all major atmospheric phenomena is associated with it. You remember that this zone has one more very interesting thing. With increasing height, there is a decrease in temperature. In the troposphere, there is a decrease in temperature with increasing height, called as or known as इसको क्या कहते हैं? lapse rate. Lapse rate is around 6.5 degrees Celsius per kilometer. Okay, you got it? Just look at this. What is lapse rate? I'll ask you. Lapse rate होता क्या है? Can anyone tell me? क्यों होता है ऐसा? Any idea why there is a lapse rate? Why there is a decrease in temperature with increasing height from the surface? Decrease in temperature with increasing height from the surface. Yes, no idea. There is a decrease in high temperature with increasing height, because let me tell you, our Earth atmosphere get heated up due to terrestrial radiation. आपका हमारा तो अर्थ का जो एटमोस्फियर है ना, you remember always, if this is the Earth surface here, if this is the Earth surface, from the sun you are getting the, as you know, all of us were well aware, you are getting here the short wavelength, and it is radiating as long wavelength. This is incoming solar radiation known as insolation. Outgoing one is known as terrestrial radiation. Incoming solar sunlight, insolation. Short wave insolation. Outgoing long wave terrestrial radiation. Okay? Well, it is going out. While it is coming, it is known as terrestrial. It is here is coming. It is known as the, what is this? Insolation, incoming solar radiation. Well, it is going back after reflecting terrestrial radiation. Very good, very good. Thank you very much. Chalo, answer. I got the answer. Due to decrease in the density of air with increasing height. Very good. There is a decrease in the density of air with height. Yes. Denser air, less denser air. Lightest air is here. Because of sun's heat on the surface we have, here insolation आ गया short wave में, terrestrial radiation से ही atmosphere get heated up. ठीक है वंशिका? Due to less water vapor present at height. Yeah, that is also a cause. Water vapor is less. That is also one triggering factor. Yes. Long wave terrestrial radiation reflect back from the earth's surface. Very good. Also heated up due to terrestrial radiation. Yes. Earth atmosphere get heated up by the short wave nahi. It is atmosphere get heated up by the long wave terrestrial radiation. Okay. Which impact will goes on decreasing if will go up. Very good. Thank you very much. आप लोगों को पता है. I am really very happy. So climatology में थोड़ा पढ़ा है क्या है लग रहा है. जियोमोफोलॉजी में पूरा एकदम वहाँ पे बेसिक थिंग्स यू गॉट इट, थैंक यू वेरी मच, you have some idea, very good. Now what I am saying is, as you know, here it is coming, short wave is coming here, reflected back as a long wave, terrestrial, and earth atmosphere got heated up because this one, terrestrial radiation. Now while it comes down, reflected back from here, density of air is more in this part, so more quickly it can transfer, but here it will go up, density of air is less. These are the major factor, two major factor for which with increasing height there is decrease in temperature. Okay. Now the terrestrial radiation, here it is differ at different with the different gases. If you have dry air, dry air, normal air, then you have wet air, wet or moist air, wet or moist air, three types of air you have. If you have a, let us say you are somewhere with your friend, let us say here is the place with dry air, here is a place with normal air, here is another place with, hello, this is dry air, normal air, moist air. Now you tell me one thing, wet air or moist air. In these three cases, ABC three places, let us say, ABC की जगह मैं नाम लिखता हूँ, ये लगा जैसलमेर, you are at Jaisalmer, here at, let us say, Bhopal, and here someone at, let us say, Kolkata, Kolkata. Jaisalmer, Bhopal and Kolkata, three places I am saying. At one place you have dry air, we have normal air and wet air. Kolkata you have moist air, let us say. Among these three places, if we will see, ये तीनों जगह में, if we will look at the rate of change of temperature with height, it will differ. जैसे मैंने कहा था ना, normal लाफ रेट कितना है 6.5 डिग्री सेल्सियस पर 6.5 degree Celsius per kilometer. It will decrease with increasing height. This is called a normal lapse rate. Normally it is this. So at Jaisalmer, but if the dry air is there, it cool down very quickly, heated up very quickly. You know that the air with the moisture अगर है तो वो temperature को retain करेगा long time. You know it. You have the dry air here, dry air, cooling of the air will be very quick, also warming up will be very quick. So in the case of dry air, Jaisalmer, it is in fact nearly 9.5 degrees Celsius per kilometer change, and compared to this is Kolkata, if you will go for, it is around 4.5 degrees Celsius per kilometer. So ये on an average जो है ना तीनों जगह पे अलग अलग होंगे. So at the same, let us say if I will go for 10 kilometer height in both all these places, whatever 10 kilometer height, if I will go for 10 kilometer height from the surface, whatever may be, it will turn into a minus 95 degrees Celsius, it is minus 65 degrees Celsius, minus 45 degrees Celsius. So likewise, even if it is 0 degree here at the surface at all places, let us assume, then it will be like this. इक्वल टेम्परेचर अगर तीनों जगह लेते हैं तो ऊपर जाते जाते टेम्परेचर घट जाएंगे. ओके. So in this case, this type of variation, they are asking question: wet adiabatic lapse rate, dry adiabatic lapse rate, normal lapse rate. This is known as the wet adiabatic lapse rate. ये जो है ना, this is known as the wet adiabatic lapse rate, this one. This is here dry adiabatic lapse rate, dry adiabatic lapse rate, dry adiabatic lapse rate. This is here is normal lapse rate, normal lapse rate, normal lapse rate. Three types of lapse rate you have: dry, moist, and this. So, in case of dry lapse rate, in fact, sudden change in the temperature will have. In case of moist, it takes time, and that's why you have climatic phenomena also will have differences. You see, in the desert regions, during the night, the temperature goes down even to single digit. In the daytime, it is around 45-50 degrees Celsius. Night time, it goes to 9 to 10 degrees Celsius. So, this type of variation is because of dry air there. Okay. So, ये जो है it means moisture plays a very important role. 6.5 degree is the general lapse rate here in this case. So, if I will go for these particular regions, as I have just drawing this diagram showing this area. So, temperature will decrease here with increasing depth, increasing height. You see here is sinking of the air because of cold air is denser, so it is sinking, it is going upward. I have just said this is known as tropopause. If this is the surface, troposphere, stratosphere, mesosphere, ionosphere, and beyond this you have the exosphere. This one here is the tropopause, stratopause, mesopause, tropopause is the transitional zone between troposphere and stratosphere. Stratopause between stratosphere and mesosphere, mesosphere between mesosphere and ionosphere. I hope you got it. Done, this is done. So you have, if it is 8 kilometer here, here it is 18 kilometer. You can see this, height wise you can see 50, 80, 480 kilometer. There is a change in the atmosphere with increasing height. Beyond this exosphere is, in fact, beyond this, the lower part up to 80 kilometers is known as homosphere. This is homosphere. Then you have the heterosphere. Beyond this, this is the heterosphere. Here mixing of the gases is there, so homosphere. Beyond this, heterosphere because of distinct layer with different type of gases. Based on the density, you have different type of gases, that's the cause. Okay, this much is clear to you, I hope. Now let me tell you something more about these regions. Like, as I have said, troposphere, stratosphere, mesosphere, ionosphere and exosphere, these zones are there. Troposphere I have already mentioned almost all climatic phenomena is there. Stratosphere temperature gradually increases here because of ozone concentration, increasing ozone concentration. Interestingly, at this zone, temperature decreases with increasing height, then again it will be constant, again it will decrease, then the constant, then again it will increase, that is constant, then again it will increase and increase and increase. Temperature will decreases with respect to height here. Where it is increasing, where it is decreasing, based on this it is there. We can see. Can you see this? Here I am saying that with increasing height there is a decrease in temperature, and then there is almost constant, then again increase. This zone has mostly of O3. The you have from here to here, you have the ozone layer. Ozone will be there in these regions. There is an increase in temperature with increasing height here because of the increasing concentration of the ozone. Beyond the stratopause, it is decreasing because the temperature decreases because of decreasing concentration of ozone. It will be almost consistent, then again it will increase. Okay, stratosphere पे लिखो. Stratosphere, please note down out. Troposphere you have written all these things. Troposphere, I hope you got it. Troposphere, stratosphere, relatively stable air, little vertical motion of air, what a stable air, little vertical motion of the air here. Ozone, there is an increase in temperature with increasing height. In this region, increase in temperature with increasing height due to increasing ozone concentration. Due to the increase in the ozone concentration, it is increasing temperature with increasing height. Due to the increasing ozone concentration. At stratopause, the temperature is almost constant or uniform, then again it decreases with height. At stratopause, it is almost constant and again it decreases with height. Okay. In mesosphere, mesosphere is the middle zone of the atmosphere. Mesosphere, middle zone, 50 to 80 kilometer. There is a temperature decrease in temperature with height. Okay. Here it is 0 degree to minus 90 degree Celsius temperature decreases in fact. In the mesosphere, there is a decrease in temperature from 0 degree at mesopause to 0 degree at stratopause to mesopause nearly minus 90 degree. Decrease in temperature here is very sharp. Mesosphere. Then again temperature increases in the ionosphere. अच्छा mesosphere में because there is completely no such any ozone concentration is not there, so you have no such any temperature increase. decrease होगा. Okay. Now beyond this, we have the very well known zone called as the ionosphere. Ionosphere has free ions and radicals here. In the ionosphere you have free ions and radicals. Here you have free ions and radicals. Ionosphere mein. Because ions are, they react with each other, ions. Because of ionic exchange, they release temperature. Likho, in the ionosphere, there are free ion and radicals. Because of ionic exchange, it releases temperature, so temperature is more. Because of ionic exchange, temperature it releases and it is more in this region. But there is no medium to carry them. There is no medium to carry them. Because there is no medium to carry them, that's why we will not feel its impact. Will not feel its impact because there is no medium to carry it. You got it now? No medium to carry it, that's why you will not feel its impact. Will not feel its impact. Okay? This is here, ionosphere. Free ions and radicals you have here. Beyond the ionosphere, we have the exosphere. Now, ionosphere is called as the thermosphere also because of increase in temperature. Ionosphere has two different, very important distinct layer, Appleton and Kennelly heaviside layer. In the ionosphere you have Appleton layer and Kennelly heaviside layer. Both are part of the ionosphere. And this ionosphere, it helps in ionosphere these layers of ionosphere helps in the long distance radio communication. It helps in the long distance radio communication. You remember this. It will help, it generally helps in the long distance radio communication. Okay? So the Appleton ये है F1 F2 layer बोला जाता है F1 F2 in fact lot of layers are there not needed in detail but you remember Kennelly heaviside and Appleton layer they are known for this one ionosphere, they are known for long distance radio wave communication. You must remember this much. Beyond this is exosphere. Exosphere has no such anything like exosphere has again temperature will increase, they are rarefied, highly rarefied atmosphere you have. Next one, exosphere is highly rarefied atmosphere with charged particles and free radicals. So here ionic exchange is much more, temperature increases very high temperature, there is great increase in the temperature level here. Temperature increases very quickly here, temperatures also, very high temperature. But even if an astronaut will expose his hand, not feel the impact here because there is no medium to carry them. There is no medium to carry these. Okay? So these are the things here about the earth atmosphere. I would like to say this much only. Now, one thing here, remember, the regions of these regions is also known for, ये regions में क्या होगा बताओ? We have I mean, I am saying this is known for, well known for lower stratosphere, upper troposphere is known for air communication. Flight के लिए अच्छा है, flight routes के लिए, because friction will be less, air will be less, and that is like very easy to travel through this region. Oh, सबसे important है, you must remember this. Okay, this much is clear. I'll go for now structure and atmosphere हो गया. I'll go for now atmospheric. Here I have done this. Do solve the questions from whatever question bank you have. Structure and common atmosphere. Pressure belt and wind system will go for now. Pressure belt and the wind system. See here, the earth atmosphere, owing to its different temperature condition and all, the earth atmosphere has different pressure belt. Pressure belts of our atmosphere. See, we have if this is the earth here, our earth has these important pressure belt in fact. This is a high pressure condition and here it is the low pressure condition. 4 high pressure and low pressure, 3 low pressure conditions you have. And total atmospheric circulation is on the basis of this. This zone is known as, here it is called as polar high pressure. This is also polar high. This one is subtropical high. Here also subtropical high. Subpolar low. Equatorial low. Subpolar low. This is 90 degrees south, 60 degrees south, 30 degrees south, 0 degree, 30 degree north, 60 degree north, 90 degree north. Okay, done. Equatorial low, subtropical high, subpolar low and polar high. These are the major pressure belt in our atmosphere. Please remember this. This is developed because of high temperature. These are the high and low pressure. Now you must be thinking like some of you, what is high pressure, what is low pressure, is not it? Okay. If you don't know, or do you have any idea, anyone having any problem on this, understanding high and low pressure? Do you need any clarification on high and low pressure? What is high pressure, what is low pressure? Chahiye kya? Nahi chahiye. I assume that you know it. If you don't know, please remember, whenever cold condition, whenever we are talking about pressure in a region, the weight of the air above us, this is the pressure. If you have high temperature, the density of air is less, so low pressure. If it is low temperature, cold condition, density of air is more, so it is high pressure. Okay? In any region, if you have a high pressure, the wind will blow from the high to low pressure area. Here, these are the most important, these are the pressure belt. These pressure belts, they move north or south based on the apparent movement of the sun. आपको बताया था मैं, sun will move from 23.5 degree north to 23.5 degree south. With this pressure belt also move north and south. Here, if the sun is at the above the equator, एकदम equator के ऊपर है, तो ऐसे pressure belt होंगे. This pressure belt. Remember, among these pressure belts, these are the equatorial low. Equatorial low is thermally developed. Thermally developed means because of temperature it is developed. It is developed due to temperature, high temperature. Equatorial low is thermally developed. Because of high temperature, it got developed because of high temperature. High temperature, so density is low. That's why air is density low. Polar high is thermally developed due to cold condition and low temperature. very low temperature, cold condition, low temperature and cold condition. You must remember this. Polar and these are but rest. Subtropical high and subpolar low. Subpolar low pressure belts are dynamically produced. It means they are developed because of not temperature, other factors are there. टेम्परेचर नहीं है, अदर फैक्टर्स है. सब ट्रॉपिकल हाई कितना डिग्री में है? एट 30 डिग्री लैटिट्यूड एंड सब पोलर लो एट 60 डिग्री लैटिट्यूड. दे आर डेवलप्ड ड्यू टू अदर फैक्टर, नॉट द टेम्परेचर फैक्टर. They are developed due to the other factors, not temperature factor. They are developed due to other factors, I am saying. What is that other factors? They are due to dynamic produce. बोला मैं ये जो है ना, temperature is the major cause here. For this temperature is cause. For this temperature is cause. This is temperature is cause. Now these four, this and this and this, they are dynamically produced. क्या बोला मैं? Dynamically produced or dynamically developed. क्या dynamically developed है? What does it mean dynamically developed का मतलब क्या है? Temperature is not the only factor here, other factors are there. देखो दोनों साइड में अगर दो लो प्रेशर है तो बीच में ऑब्वियसली हाई प्रेशर होगा. अगर दो लो प्रेशर है इधर, देखो आप, हियर इज ए लो प्रेशर, हियर इज ए लो प्रेशर, बीच में हाई होना ही है. नाउ ये जो है हाई प्रेशर है, ये लो प्रेशर है, यानी कोल्ड एयर जब भी आते हैं ना, देखो यहाँ पे कोल्ड एयर इधर से आते हैं, यहाँ पे वार्म एरिया है तो वार्म एयर गोज डाउन, कोल्ड एयर लिफ्टेड अप, लो प्रेशर बन जाता है. आई विल डिस्कस दिस इन डिटेल इफ नीडेड. कोरिलेशन इफेक्ट इज डिफरेंट माय डियर. कन्वेक्शनल इंस्टेबिलिटी नहीं है यहाँ पे. इक्वेटोरियल लो थर्मली डेवलप्ड, ये कन्वेक्शनल इंस्टेबिलिटी से हुआ है. थर्मली डेवलप्ड ड्यू टू द कोल्ड कंडीशन. ठीक है. सब ट्रॉपिकल एंड सब पोलर हाई प्रेशर, सब ट्रॉपिकल हाई, सब पोलर लो, डायनेमिकली प्रोड्यूस मीन here because of two area with different pressure condition. That's why this is not because of this temperature factor, other factors are there. Earth's यहाँ पे मेजर कंडीशन, मेजर फैक्टर है अर्थ रोटेशन is also a cause here. Why? What is the cause here? Earth rotation is also a very important cause, no doubt. Earth rotation is a very important cause. Most important factor is earth rotation, no doubt. Now the factor here, why it is so? If I will go for the factor, what is responsible for this? डायनेमिक फैक्टर का मतलब क्या होता है? देखिए आप यहाँ पे, बिकॉज दिस साइड कोल्ड एयर इज कमिंग, ये वार्म एयर को आ रहा है, कोल्ड एयर नीचे सिंक कर जाएगा. कोल्ड एयर विल सिंक डाउन, यहाँ का जो वार्म एयर है इट विल मूव अप। ये देखिए, there is cold air is going in this way, cold air will sink down, warm air will rise up because of density difference of the air. Once it is there, अगर once यहाँ पे अगर low pressure बन गया, here we have a low pressure already, it means either low pressure, either be low pressure, too low pressure, in between this air will have a high pressure condition automatically. Okay, to maintain equilibrium, dynamically produced condition develop just to maintain the equilibrium between two areas. To bring out equilibrium only it happens. To bring out the equilibrium, you remember, this is very, very important to note. Due to divergence of air upward, equator and to poles. Yes, this is one cause, no doubt. Somebody said temperature inversion, temperature variation. हाँ, ये भी है. Both the, ठीक है. Thank you very much. At least you know. Thank you. Differences in temperature. So इधर air जो इधर आएगी ना, this will goes down. This air it will moved up, and here is low pressure. And because it is low pressure, air is moving up here this side. Air is going in this way. तो यहाँ पे sinking of the air होगा. That's why. Okay? I hope you got it now. मैं कह रहा हूँ this development is primarily because, देखो आप, sorry, here there is sinking of temperature, air, cold air will sink down. Here it will go up because of convectional instability. अगर ये ऊपर जा रही है यहाँ पे कोल्ड एयर आ रही है, कोल्ड एयर विल सिंक डाउन, वार्म एयर को ये ऊपर उठा लेगा. ओके, ऊपर जाके ये डाइवर्सिफाइड होके ऐसे रहेंगे. ओके, नाउ दिस एयर, बिकॉज एयर इज कमिंग इन दिस वे एंड दिस वे, बोथ दोनों साइड आ रहे हैं, यहाँ पे ये एयर सिंक करेगा नीचे. It will sink down and it forms a complete cycle here. Complete cycle it will develop because of this. This is known as the polar cell, Ferrel cell, Hadley cell. Hadley cell, Ferrel cell, polar cell. ये हाई प्रेशर बन जाएगा इसीलिए क्योंकि ये सिंकिंग ऑफ द एयर दोनों जगह देखो, यहाँ पे ऊपर जा रही है एयर, सो ये हो गया आपका लो प्रेशर कंडीशन हियर ऑल्सो एंड हियर ऑल्सो. एयर इज मूविंग अपवर्ड. So again I am saying the development of these pressure belt here is primarily associated with what? The development of the pressure belt here is associated with, here you can see, here more temperature leads to thermally, it moved upward. Here less temperature sinking of the air is coming toward this side. Here in the warm air it is coming warm territory, so it will sink down, warm air will move up, forming a low pressure condition. When the warm air move up, in the upper part there is less density, so it will diverge. When it goes up and it got linked up with this, a cell it will develop. Now what happened? The vertical rising air this side and this side also vertically rising. So in between you have dragging of the air and you have formation of a high pressure air. Sinking of the air leads to high pressure, you know. So you have here high pressure, so it will form a cell here, Hadley cell. This side is another cell between these two, Ferrel cell. So Hadley cell between 0 to 30 degree, Ferrel cell between 30 to 60 degree. ये 0 डिग्री है, ये 30 डिग्री है, ये 60 डिग्री है, this is 90 degree north. So we have in this way, there are different cells, 3 cells. This is known as the tricellular model. इसको बोलते हैं क्या? Tricellular model of the Earth's atmosphere. Earth's atmosphere. Tricellular model of the Earth's atmosphere. You got it now? Tricellular model of the Earth's atmosphere you are having here. 3 cell model, Ferrel cell, Hadley cell and the polar cell. 3 Ferrel cell, देखो Hadley cell, Ferrel cell and polar cell, 3 cells model. 3 cells, they are finally rotating and forming this entire circulation. Hope you got it now. Yes. So this is all about your atmosphere pressure belt. Question can be asked, which are the thermally direct cells? Thermally direct cell तो equatorial है, thermally product of course is polar also, dynamically produced ये दोनों है. Total atmospheric circulation is somewhere related with this cell only. So today I would like to discuss about wind system, cyclone and anticyclone, cloud, precipitation, major climatic regions and ocean bottom relief. They are the topic in fact which we are going to discuss today. So first is about the wind circulation or global wind circulation. In the last class I did mention about pressure belt. In the pressure belt I said there are 7 pressure belt, equatorial low, then you have subtropical high, subpolar low and the polar high. These are the belt which I have already mentioned. I hope you remember that. Because of these pressure belts, what happened here? The wind will blow from the high to low pressure area. Wind will blow from the high to low pressure area. Alright. You have a low pressure cell here, low pressure here and low pressure here, and this side you have the high pressure at the polar regions, high pressure at subtropical region, subtropical high north, polar high north. So these are the pressure belt here. Because of this pressure belt, what happened here? The wind will blow from the high to low pressure conditions. So wind will blow from high to low pressure zone. So ऐसे आना है wind को. Wind is supposed to blow from here to here and here to here like this. Because of the Earth's rotation, okay, rotation of the Earth and the Coriolis force, this wind will divert from its normal path towards north in the northern hemisphere and right in the southern hemisphere, which is called as Coriolis effect. So what will happen here? While the air is, this is like it is supposed to blow from high to low. ऐसे आना चाहिए ना ये, हाई प्रेशर से लो प्रेशर को ऐसे आना चाहिए. It should be like this, high to low in this way, high to low in this way it should be. The winds are supposed to come in this way, is not it? From the high pressure to the low pressure, high pressure to low pressure wind is supposed to blow in this way. But interestingly, what will happen because of the impact of earth rotation and Coriolis force, it will turn towards right hand side, towards right like this. Remember, wind is the flow of air due to pressure gradient, okay. So wind blows from high pressure cell to low pressure zone, high pressure to low pressure. Remember, due to Earth's rotation, and Coriolis effect, and Earth's rotation and consequent Coriolis effect, it diverts from its normal path towards right in northern hemisphere and left in southern hemisphere. You remember this. I am saying in the northern hemisphere, from the normal direction towards right, it will divert, southern hemisphere towards left because of the earth rotation and the consequent Coriolis force. So आप अगर ये देखेंगे, ये अगर नॉर्मल पाथ है टुवर्ड्स राइट, सो इफ इट इज द नॉर्मल पाथ, इट शुड बी द नॉर्मल पाथ टुवर्ड्स राइट, मीन इट विल डाइवर्ट इन दिस वे. ये उसका राइट नहीं होगा क्या? देखो आप, गति की दिशा में दाहिने तरफ, फ्रॉम एनीवेयर इफ इट इज टर्निंग टुवर्ड्स राइट इन द फ्लो डायरेक्शन टुवर्ड्स राइट, तो ये होगा इसे. Here it will blow in this way, like towards right mean 1 or 2. किधर होगा बताओ? This where in the which side you will have 1 or 2? यहाँ पे here it will go towards 1 or 2. Can anyone tell me? Yes. All of you are here? Two. Okay, very good. So it will turn towards right, mean towards 2. It will turn towards 2. ऐसे turn कर जाएगी. All the air will turn towards right here like this. 2. And same way if you got, ये जैसा है ऐसे होगा यहाँ भी. Here it will turn towards right. So it will be like this. I hope it is clear. This wind is blowing in this direction. So always you remember, naming of the wind is on the basis of which coordinate it is located in. Based on the coordinate, this is north, south, east, west. If wind is blowing from here to here, this is called as origin point is north, southwest, so it is southwesterly wind. ये हो गया क्या? Southwesterly. Okay. If it is going from here to here, this type of wind, this will be northeasterly. It is northeasterly wind. You got it? So you have wind name is based on the origin coordinate. कहाँ से originated है? From where it is originated? So on the basis of this you can see this is your easterly, this is your westerly wind. These are known as, this wind is called as, here is polar easterlies. Please remember, polar easterlies. Polar easterlies. This is known as the westerlies. Westerlies. This is known as the trade wind or easterlies. Easterlies. Three types of wind you are having. Polar easterlies. So, ये wind का नाम क्या है? Here you will have same way the wind will blow from here in this direction. ये towards left होगा, in the southern hemisphere towards left like this, and here towards left mean like this it will be. And here towards left mean like this, wind will blow in this way, wind will blow in this way. So, this wind here is called as, this is the easterlies or trade wind, trade wind. Second one is you have your westerlies, westerlies wind, and the third one is polar easterlies, polar easterlies of southern hemisphere. So, these are the wind system which we got. Wind system we got. It means the easterly wind is influencing the climate of low latitude, westerlies of mid latitude, and the polar regions is influenced by the polar easterlies here, polar easterlies. Okay. So, again I am saying we have the easterly wind will influence the low latitude, westerly, mid latitude, and polar easterly high latitude. I hope it is clear to you all. So, this region is influenced by the polar wind, this middle region by westerly wind, this equatorial region is by which wind? This equatorial region is influenced by the easterly wind or trade winds. So, this is here is the case. I hope you got it now. Mostly you got it now. Clear? Eh? Due to Earth's rotation and Coriolis effect, wind will divert from its normal path towards right in northern hemisphere, left in southern hemisphere, and this will happen. Hope you got it here. Right. Now, the question here is about this, the wind circulation, how it impact the climate and all other things we will see. Remember, this easterly wind will influence the climate of which region? Climate of the any continent with the right hand side mean east coast. Easterly wind influence east coast. Westerly wind influence western coast. So, if it is coming from the ocean, the wind is coming, and here is a continent. If you have a continental part here, and in that case what will happen here? If there is a continent, western side means right side will be influenced by the easterlies, left side or western side by the westerlies, and in the polar region also right side means easterlies wind. So, this is where how they develops. This very important point, this is very, very important. Got it? Global wind circulation. In this you got it now. So, we can say easterlies wind influences climate of low latitudes. Low latitudes mean that is 0 to 30 degree latitude. Already I have already said earlier a box in which I have already mentioned this. You remember that? Major climatic regions of the world, something I have said. Let me implement that. If you remember, I have given a table like this in the first class. And here I said, this is the region, we can see, this is 0 degree, 10 degree, 30 degree, 45 degree, 60 degree and 90 degree. And I have already mentioned about the climatic region, if you remember. This I said is the regions of whatever climate, polar cold climate. Polar cold climate. My friend, this is hot and wet equatorial climate. Equatorial climate. And this is here is Laurentia. Laurentian climate. This is here is China type climate. This is monsoon type climate. This one is Siberian climate. If you remember this is steppe climate. This one here is savanna climate. And here it is like, in the east coast, British climate. Then you have Mediterranean climate. Mediterranean climate. Then you have hot desert climate. If you remember, I have already mentioned about all these things earlier, but today I will discuss about in normal condition what will happen here. You see, this is the regions where you have low pressure condition is there. This is the area where you have the low pressure condition. Okay, there is low pressure. And here is the region where you have the high pressure condition. Here is the region where you have the high pressure condition. And again a low pressure condition is here. At 60 degree you have a low pressure condition in general. I have already said about this. This is low pressure, and here it is high pressure, this is high pressure. And you know that this region is influenced by here, which wind is, this is low pressure here. So, this side you have can you get these things? Is it okay? This is here is they are the wind here, you can see. This is the polar easterlies wind. This one here is westerlies wind, and this is here is easterlies wind. Polar westerlies, easterlies, polar easterlies. You see that these are the wind system here. So, in this climatic type you can see here monsoon will get more rainfall, savanna will get moderate rainfall, very low rainfall in hot desert or no rainfall, because you see high pressure conditions, sinking of the air is coming from the above, it is going down and it is going in this way, continental, dry continental easterly, but here it is coming from the ocean. You know that this is a ocean here and this is also a ocean. I have already mentioned these things earlier. A ocean hai, two ocean, 0 to 90 degree differences. Here it is from the high pressure to low pressure wind is blowing. So because the wind is blowing from high to low pressure here coming from the ocean and striking here at the coast, giving rainfall to the monsoon, moderate to the savanna and very less rainfall in the hot desert. Gradually the intensity of rainfall is decreasing from the east coast toward the west. Here देखो आप, here you have more rainfall. The monsoon climate will have, because of that only, because it's coming from the ocean, the wind is there. So here are 150 centimeter rainfall, 100 to 100 cm rainfall, 150. Here is around 100 cm rainfall. Here is less than 50 cm rainfall, less than 50 centimeter. Okay. Savanna 50 to 100 cm of rainfall, 100 to 150 cm rainfall monsoon. You know it. And इक्वेटोरियल रीजन मोर देन 250 सेंटीमीटर रेनफॉल हियर, बहुत ज़्यादा बारिश होता है बिकॉज ऑफ कन्वेक्शनल इंस्टेबिलिटी हियर, मोर कन्वेक्शनल इंस्टेबिलिटी एंड मोर रेनफॉल हियर यू आर हैविंग. नाउ एज आई जस्ट हैव मेंशन अबाउट दिस, monsoon will get more rainfall because of the easterly wind coming from the ocean and striking here. You have very less rainfall savanna, least in the hot desert regions. But again at this particular part, hot wet equatorial climate, because of very low pressure condition, the air parcel will move upward. Here the air parcel will move upward because of more convection and instability, more temperature. Because the air parcel will move upward, more cloud formation, more rainfall here. I hope it is clear to you. Now here you have more rainfall. Here you have 100 to 150 cm, 50 to 100 cm, less than 50 cm rainfall, around 25 cm rainfall here in fact. Mediterranean regions, this region receives again got influenced by the westerly wind, but I hope it is clear to you. Equatorial, monsoon, savanna and hot deserts. My friend, you must remember monsoon जो है ना, monsoon is associated with complete reversal of the wind system in every 6 months. ये जो monsoon है, क्यों? Because the sun is here, now sun will go down, now sun will come here. ये जो low pressure है यहाँ तक चला आता है, low pressure belt will come up to here. So at that time no monsoon you have at that time. Okay, it depends on where is the sun, sun का position क्या है, based on that only. So monsoon climatic condition in case of India it is different. Worldwide if you will see it has some modification. India, because of peninsular India you have this. Let us look at here hot wet equatorial climate. This is influenced by this one, easterly. Monsoon, savanna and hot desert, they are by the easterlies. Polar easterlies is influencing on the polar climate. Westerly wind is influencing Mediterranean, British, Steppe, Siberia, China, Laurentia, all these. But आपको पता है कि there is a change every time, you know. ये जो pressure belt है, this pressure belt may go up to here it can come here. ये pressure belt जो है ना थोड़ा ऊपर नीचे होता है. Because of what? It goes up or down because of what? Because of the apparent movement of the sun, this pressure belt also goes up and come down. You remember, average position is this one. This low pressure also goes up as well as down. This low pressure is also, it will go up. यहाँ तक चला जाएगा because of summer. Then again it come down, then goes down also. So ये जो है ना, ये low pressure condition shift north or south of the equator. With this, you know, wind belt also shift north or south. You remember this. So this region is influenced partly, greatly by the which one? The easterly wind. Upper part by the polar easterly wind. In between you have the westerly wind. Westerly wind is influencing which one? Mediterranean, Steppe, China, British, Siberia, Laurentia. But you see, जब summer season में ये जब ऊपर चला जाएगा, this will go up to here. And this wind will go up to here. ये. So at that time what will happen? Wind will, देखो आप, please look at here. Wind will blow from here to here. ये आएगा ना, कौन सा summer season में? So it will never give rainfall. No westerly, तो summer Mediterranean में बारिश नहीं होता है. Mediterranean season doesn't have rainfall, winter rainfall, summer rainfall because of this cause only. Summer season no rainfall in Mediterranean, dryness. यहाँ पे भी देखिए आप, ये जो Mediterranean regions है, यहाँ बारिश कभी भी नहीं होता है समर सीजन में. प्लीज रिमेंबर, स्टेपी में भी नहीं होगा बारिश. स्टेपी में थोड़ा बहुत कन्वेक्शनल इंस्टेबिलिटी से हो सकते हैं. ओके, दिस यू मस्ट। पर चाइना में जरूर बारिश होगा। चाइना में समर में बारिश ज़्यादा होंगे बिकॉज ऑफ दिस कॉज। ओके, प्लीज रिमेंबर दिस। नाउ again let me take them to the original position wherever they are. So it is here. This is the original position of this. This is the original position. Okay. So I am saying this movement of this particular pressure belt north or south is related with the what? Apparent movement of the sun. Please remember this. ये तो आपके ये रीजन्स का हो गया। आपको बताया था मैं, इफ यू वांट टू स्टडी you can have spent some time on looking at this characteristics of monsoon, equatorial, hot desert. आपके लिए मैंने उस दिन चैप्टर भी बता दिया था। इफ यू हैव स्टडीड, नहीं पढ़ा तो कोई बात नहीं, देखो यहाँ पे 1 2 3 4, ये 4 को थोड़ा देख लेना है। मानसून, इक्वेटोरियल, हॉट डेजर्ट, मेडिटेरेनियन। लेट मी टेल यू दिस 4 इक्वेटोरियल क्लाइमेट जो होते हैं, कैरेक्टरिस्टिक्स यू वांट टू राइट, प्लीज रिमेंबर। इक्वेटोरियल क्लाइमेट हैज मैक्सिमम रेनफॉल among all the climatic type in the world. Equatorial climate सबसे ज़्यादा बारिश होता है। ओके, एंड दिस इज लाइक मोस्टली कन्वेक्शनल रेनफॉल। ज़्यादा many because of more and more temperature, what happen here? Usually in this case ज़्यादा टेम्परेचर होगा तो कन्वेक्शनल इंस्टेबिलिटी होता है, एयर विल गो अप, इट फॉर्म क्लाउड एंड गिव रेनफॉल। दिस इज कन्वेक्शनल रेनफॉल हियर। हॉट वेट इक्वेटोरियल क्लाइमेट में ये होगा। Now monsoon में there is a wind coming from the ocean, that's why it will have. Savanna has moderate, hot desert has because continental wind is going there. यहाँ का wind जो होगा dry wind होगा ना, वो जा रहे हैं, so there is no rainfall here. So this is all about this. Now Mediterranean regions, I said winter में बारिश ज़्यादा होगा क्योंकि winter में ये नीचे आ गया है। समर में क्या होता है, ये हाई प्रेशर जो है ना ऊपर थोड़ा चले जाते हैं। मैंने कहा था सन का मूवमेंट ऊपर और नीचे होते हैं, किसका? इक्वेटर की। So here you have like the more and more impact of the wind coming from the ocean, westerly wind during the winter. So winter में rainfall पूरे रीजन में ये होगा, यहाँ पे रेनफॉल होगा, स्नोफॉल होगा एंड दिस इज देयर। बट समर में, समर सीजन में यहाँ पे रेनफॉल नहीं होंगे, विंटर में ही रेनफॉल होगा मेडिटेरेनियन। सो मैं इसको लिख देता हूँ कब कब कहाँ पे रेनफॉल होता है और क्यों होते हैं, यू विल गेट टू नो। लेट मी यूज दिस रेड इंक फॉर दिस। दिस इज हियर इज वाई। वाई मीन साल भर बारिश होगा, ईयर राउंड। एस मीन समर में ज़्यादा बरस, समर में बारिश, समर में बारिश। एन मीन नो रेनफॉल और वेरी लेस और नो रेनफॉल। ओके, हियर इज ऑल्सो एन मीन नो रेनफॉल, नेग्लिजिबल रेनफॉल। ओके, नेग्लिजिबल है। और ये सवाना भी एस, समर समर समर। मेडिटेरेनियन में होगा डब्ल्यू मीन विंटर रेनफॉल। ब्रिटिश में होता है ऑटम, ए मीन ऑटम, AUTUMN, ऑटम सीजन में ज़्यादा बारिश होता है। हालांकि बारिश साल भर बारिश होंगे, थ्रू आउट देयर रेनफॉल ऑलमोस्ट, बट मोर रेनफॉल ड्यूरिंग दिस टाइम ओनली। इज इट क्लियर टू यू? Is it okay? Hope it is clear to all of you. ये समर में ज़्यादा बारिश होता है, ये समर में SSS मीन समर समर, ऑल दीज आर समर सीजन। W मीन विंटर रेनफॉल, N मीन नो रेनफॉल, नो रेनफॉल, A मीन ऑटम सीजन मैक्सिमम रेनफॉल, बिकॉज एट दैट टाइम ये जो है ना, ये जो समर में यहाँ तक जाता है फिर आता है, इस बीच में इंटेंसिफिकेशन ज़्यादा होता है। इट इज ऑलमोस्ट थ्रू आउट द ईयर बट इंटेंसिफिकेशन इज मोर इन द ऑटम सीजन, दैट्स वाई ब्रिटिश क्लाइमेट हैज ऑटम रेनफॉल। Hope you people got it. Now the rainfall pattern is completely associated with the wind of this different region. Okay. Are jet streams and polar vortex important for prelim, or they are only for the main oriented? Jet stream, you see that these are for mains only, but one basic things in the wind circulation, I will just tell you what is jet stream. बेसिक चीज पता होना चाहिए हमें. प्रीलिम में यहाँ पे भी यू मस्ट रिमेंबर कौन सा क्लाइमेट का कैरेक्टरिस्टिक्स क्या है विंड से रिलेटेड. जस्ट आई एम टेलिंग यू दिस रीजन हैव ऑलमोस्ट थ्रू आउट द ईयर रेनफॉल. कौन सा? हॉट वेट इक्वेटोरियल क्लाइमेट. ऑलमोस्ट थ्रू आउट द ईयर रेनफॉल. डबल रेनफॉल पीक. जब इक्विनॉक्स होगा, ड्यूरिंग द इक्विनॉक्स the sun will be overhead, so that is at that time highest rainfall you will have. मानसून में समर मैक्सिमम रेनफॉल होगा समर सीजन में. साउथ वेस्ट मानसून जो होता है हमारे यहाँ पे, सवाना में थोड़ा इंटरमीडिएट रेनफॉल होगा. हॉट डेजर्ट में थोड़ी बारिश होगा ही नहीं, मगर जो भी रहेंगे मे बी बिटिल ऑफ देयर. मेडिटेरियन में विंटर रेनफॉल होगा बिकॉज ऑफ द इम्पैक्ट ऑफ द वेस्टर्लीज इज स्ट्रॉन्ग. ऑटम में, ऑटम सीजन में हाईएस्ट रेनफॉल ब्रिटिश में थ्रू आउट द ईयर रहता है, साल भर बारिश होगा, बट हाईएस्ट इन द, no doubt throughout the year rainfall will be there, but highest in the autumn season because at that time the impact of the westerly is highest. Siberian climate, if you will see in the Siberian climatic type, the summer has maximum rainfall because of the sun rays, the snow field they got melt away, more evaporation will be there. Laurentia also summer season you have more rainfall. और ये cold area में बारिश almost नहीं होता है because the polar cold wind is coming, so snowfall is there, rainfall will not be there. So these are the things about these regions. So based on this, you know, यहाँ पे जो vegetation होगा hot wet equatorial climate में evergreen होंगे throughout their rainfall. ये deciduous होगा, बाकी सब deciduous रहेंगे, मगर ये polar region में जो vegetation होंगे they are like very cold condition, हेकिस्टोथर्म कहते हैं. We call it as हेकिस्टोथर्म. These are certain things about this. So easterly wind influences these regions. Now I will go for the westerly wind. Easterly wind. So easterly wind influences what? It influences which climate? Influences monsoon, monsoon climate, savanna climate, hot desert and equatorial climate. Equatorial climate ये सबको है ना. हाईएस्ट रेनफॉल इज हियर इन द मानसून इस पे होगा. नाउ कमिंग टू द वेस्टर्लीज विंड. वेस्टर्लीज विंड, वेस्टर्लीज विंड influences six climatic types. 6 climatic types को ये it is influencing 6 climatic types, isn't it? What are those? We have already said. This is like, you know, first one this side British, Mediterranean, Siberian, steppe, Siberian, steppe. Then we have Laurentia and China type. 6 type are influenced by westerly wind. Westerly wind will influence these 6 climatic type. ये 6 क्लाइमेट को ये इन्फ्लुएंस करेगा वेस्टर्लीज विंड. दैट्स व्हाट आई वांट टू से. आई होप यू गॉट इट नाउ. वेस्टर्लीज विंड विल इन्फ्लुएंस द क्लाइमेट ऑफ दिस 6. British, Mediterranean, Siberian, steppe, Laurentia and China type. Westerly wind influences the climate of this region, this 6 climatic zones. So here west coast will have more rainfall. Anyway, मैंने ये 6 क्लाइमेट का बात किया था. This 6 climate I am talking about, where intensity of rainfall may differ with respect to season. ये तो है विंटर में रेनफॉल देगा यहाँ पे मेडिटेरियन में, विंटर में रेनफॉल, समर में ऑटम मैक्सिमम ईयर राउंड, बट ऑटम मैक्सिमम Siberia summer, summer and all these are summer season. That's what I said. The intensity of the impact of these wind is more during this time. This is westerly wind system. Easterly and westerly is done. Now I will go for the next. Westerly wind, westerly winds are stronger in the southern hemisphere due to more water bodies and smooth surface. Smooth surface, more water bodies and more smooth surface. That's why it is westerlies are very strong. For example, roaring 40s, furious 50s, shrieking 60s, or screaming 60s. All these are westerlies at 40° latitude. At 50° latitude, at 60° latitude, at 60° latitude. This is roaring 40s. This is furious 50s. This is 60s. Okay. So screaming 60s. You must don't be confused on whatever I've written here. Can you see the name of this? And remember, 30° latitude is called as 30° latitude high pressure region. With high pressure region is called as horse latitude. Remember, ये horse latitude बोलने का क्या measure, what was the major factor behind this? Because earlier यहाँ से जो भी लोग लेके जाते थे ना, horses को लेके जाते थे from this side. So whenever they crosses this particular part, 40° जब आ जाते 30° में क्या है कि the high pressure condition. So ये अगर इधर से जा रहे हैं, it is low pressure here to high pressure while they goes, because they take horses, maximum number of horses from the steppe and these regions. इसको लेके इधर साउथ अमेरिका जाते थे. So on the way what will happen, because high pressure condition will have they have to cross. At that time pressure ज़्यादा होने के कारण क्या होता था, the ship started sinking. That's reason known as they have to throw some horses in the water because they have to navigate properly. That's why it is known as what? Horse latitude. इसलिए इसका नाम है horse latitude. 30° latitude is known as horse latitude. Please remember this. 30° is the horse latitude. You must remember. Okay. So these are the things here. Now if you look at the polar climate, I hope it is clear to you now. Polar easterlies climate, I just said in this climatic type polar easterlies, it influences, it brings cold waves and cold air mass of air very cold, air mass from the polar region towards from the polar region, it brings cold waves and cold air masses from the polar region towards the temperate or subpolar zone, subpolar zones. Please remember. So climate cold wave लेके आता है ये, because of that it is responsible for bringing cold wave to this part, cold air mass, bringing cold wave to the temperate regions. आसपास region में cold wave ले आता है. Please remember this. Done with this. Polar easterly climate. I hope you got it now. This is clear to you all. इसके लिए आप any question you want to ask from this particular table, can you give me any question if you need? The questions in the prelim are mostly characteristics of the climate or rainfall pattern, why and how it is. The horse latitude already asked. They asked why the hot deserts are in the tropical western margin, because एक चीज देखो, here you have one is high pressure condition, low rainfall, continental easterly wind is coming. Okay, also there are other factors like ocean current also this side there, which we will discuss later on. Mediterranean region says winter rainfall because of the intensity of the westerly is more in the winter. So these are certain things. In fact, they are different in terms of, if you look at this, they are different in terms of their characteristics and climatic type. You have maximum range of temperature, you will have the climate which is away from the equator, away from the coast, means Siberian climate has away from the equator, away from the coast. So this is Siberian climate, which is very important. For Siberian climate, you will have maximum range of temperature. Maximum range of temperature will be in the Siberian climate. Okay, is it clear? Right. So anything you want to ask, please go ahead. Okay, so easterlies and westerlies wind system, as I have just mentioned, I hope you got the wind. So wind are of different type. I have just said about one wind system, that is ground. So wind system, you remember this. This is surface air, surface wind, and upper air circulation, upper air circulation. One is surface wind, another is upper air circulation. The surface wind are of three types: planetary wind, regional wind, local wind. Planetary wind are of three types: Planetary wind can be easterlies, westerlies, and I have written the polar easterlies. I have already mentioned about this. रीजनल विंड में एक आते हैं जिसका नाम है मानसून. ओके. लोकल विंड आर ऑफ डिफरेंट टाइप्स. लू, लैंड ब्रिज, sea breeze. Land breeze, sea breeze, harmattan, sirocco, belly wind, mountain wind, fawn and chinook, etc. This you must know. Here it is a jet stream. Jet stream. These are the different types of, as I have just mentioned, different types of wind system. We'll look at this. I've already discussed about these winds. Easterly is done, westerly is done, and polar easterly. I hope it is clear to all of you. Now, regional wind monsoon. Monsoon is related with complete reversal of the wind system every 6 months. Monsoon is the wind which is associated with complete reversal with every 6 months. Please remember this. Complete reversal of the wind system every 6 months. Monsoon. It is a regional wind, complete reversal of wind system with every 6 months. Let me draw this is very simple. During the summer season, what happens? This region has the low pressure condition. So, wind blow from here. The wind will blow from here. Because of Corliss force, they move in this way. It blows almost parallel to the coast of Tamil Nadu. It will not give much rainfall here. You know that this is known as the southwest monsoon in the summer. Because of presence of the mountain here, and this is like this. This is the rain shadow area, no rainfall in these regions, rain shadow regions. But here you will get it. This is the branches here. I hope you know it. Southwest monsoon. Same way during the winter season what happen? During the winter, very important thing, here this side it forms a high pressure condition forms over this, and here you have the low pressure condition. In the lower part we have the low pressure condition. Low pressure, and due to which wind will blow from the high to low pressure area. Here only it gives rainfall to this part only. This is here is the monsoon known as, this monsoon is northeast monsoon. This is the northeast monsoon. Because of cold condition, high pressure, here is warm condition, warm ocean is there in the winter. Here is cold condition in the Himalayan regions. And here it is cool, here it is cool, high pressure condition, and here it is hot. These regions have low pressure, and here it is cool winter, this is low pressure. So the wind, देखो यहाँ पे, in the summer direction of this is this, opposite is in the winter. So this, that's why it is called as the complete reversal of the wind system here, and it is called as monsoon. Sir, are the jet stream and polar vortex? Sir, how polar easterlies brings icebergs to mid latitude from the pole? My friends, icebergs also it brings, of course, because of what, here, while the wind is blowing in this way, northern pole is a ocean. So when the wind is blowing, large scale displacement of the water also there, known as the ocean current. This ocean current brings them with the wind, this iceberg. So it is known as the mother of the iceberg, particularly which area? Labrador current is known as the mother of the iceberg, for that region only. You can see that. Summer southwest monsoon, winter northeast monsoon, complete reversal of the wind system. Best example of this one. I hope you got it, monsoon. Now, if I'll go for the local wind, Lu is a local wind, hot local wind. It blows in the summer from the northern part of India towards central India and Ganga plain. It is a local wind, hot or warm local wind, warm local wind. Land bridge and sea bridge phenomena, let us see. This is like this only. Land bridge, sea bridge is what you know. Like if you have a continental part here, this is the continent. This is the continent here. And here you have the ocean. Here also ocean you have, and this side you have the continent. Continent. During the daytime, let us say during the daytime it is hot, this is cool, or this is warm and this is cool. This is warm, this is cool. So warm है तो low pressure condition, this is cool mean high pressure condition. So wind will blow from the ocean to the continent. This is called as sea breeze. Sea breeze. differential heating and cooling leads to this particular phenomena. And here, during the night, what will happen? This is cool, this one is warm. So, here you have a low pressure condition, here you have a high pressure condition. Wind will blow from the continent to the ocean. Wind will blow from the continent to the ocean. This is called as what? Land breeze. Land breeze. Continent to the ocean, the wind will blow because of the wind will blow from the continent to the ocean. Why? It will blow from the continent to the ocean because continent is cool, so high pressure, ocean is warm, so low pressure. So high to low pressure wind will blow, and in the night time we have continent. You see that is completely different. Daytime from the cool ocean to the warm continental part wind will blow. This is every complete reversal of the wind in every 24 hours. This is land breeze and sea breeze. You see that is sea breeze, this is land breeze. Land breeze is during the what time? This is here is the land breeze. Please remember, land breeze. This is called as the land breeze. Why it is called a land breeze? Because it is coming from the continent. Continent से आ रही है इसलिए land breeze हो गया ये. Okay, land breeze and sea breeze phenomena. I hope you got it now. I hope it is clear to all of you. Land breeze and sea breeze, local wind. This can be asked. Okay, this is what you got it. Fine. Right. Next one, we have Harmattan. Harmattan, this is done, this is done. Harmattan, Sirocco, see, this is Africa here. From Sahara region, wind blows toward the Guinea coast. Guinea coast. This is Harmattan, this one is Sirocco. Khamsin in Egypt. See, a hot and dry wind during the summer season blows from the Sahara towards the Guinea coast, and this is called as Harmattan. Please note down. A hot and dry wind blows from the Sahara toward the Guinea coast, called as Harmattan. It brings relief from the hot and humid condition, so it is called as the doctor. Harmattan is called as the doctor. Remember, because it gives, this is hot and dry wind while it reaches the Guinea coast. Guinea coast is humid coast. Humidity is more. So it gives relief from this humidity, so known as the doctor. Sirocco is a hot and dry wind which blows from Sahara towards the Mediterranean Sea, known as Sirocco. Hot and dry wind. From Sahara to Mediterranean coast it blows. Okay. It is known as Khamsin in Egypt. So this wind while it reaches, this is Libyan desert here. Here you have the Libyan desert. You remember, this is, here is the Libyan desert. From the Libyan desert, it takes red dust particle, and in the Mediterranean Sea, this is Mediterranean Sea. Mediterranean Sea. This is the Libyan desert. So Libyan desert, from where it is takes the red sands, and from Mediterranean Sea it absorbs moisture, give rainfall in the regions. These are known as the Khamsin. These are known as Sirocco. Sirocco brings blood rain in the Mediterranean region. Blood rain means red color raindrops, because the dust particle is coming from where? This dust particle is from Libyan desert. So red color rainfall is there, raindrops known as blood rain. Again I am saying the blood rain name is given because of red color raindrops. Red color raindrops. Can you see these things? Okay, these are the local name for this. By the way, Sirocco you got it, Harmattan you got it. Valley wind and mountain wind, we will see now. What are valley wind and mountain wind? You see, if this is a mountainous region, it is a mountain here, okay. If it is the mountain here, below site one is, this is mountain, this is valley, this is valley, valley and mountain. During the daytime, what happens? During the daytime and during the night, let us say. During the daytime, it became hot in this part. So, you have development of low pressure. Here it is cool, so high pressure condition. This is cool, this is hot. So, wind will blow from, this is cool, high pressure. So, wind will blow from the valleys to up. These ascending wind are called as, valley wind. Valley wind. Differential temperature condition. High temperature, here it is low pressure, high pressure. So, wind will blow from high to low. During the night, what happened? This will become cool and cold hoga ye, cold, and this is warm, comparatively warmer area. So, you have like, this is in this case high, here you have the low pressure, here you have the high pressure, here the wind will descend from above and this descending wind is called as, this descending wind is called as what? This is mountain wind. Mountain wind, because coming from a mountain, this is valley wind, this is mountain wind. Please remember. So because of thermal gradient, pressure gradient only, these two local wind they develop. Please remember this, mountain and valley wind. Please draw this diagram and do this, please. Please draw this diagram and do this. I hope you remember. If you remember, then it's okay, fine. From valley to the mountain and mountain to the valley. This is because coming from the valley is a valley wind, coming from the mountain, descending from mountain, mountain wind. Two types of wind you have, valley and mountain winds. I hope you are well aware now and you know it now very well. Okay, so what happened? Another one, Fawn and Chinook. In fact, Fawn and Chinook, these are nothing but mountain winds. They are mountain winds. In fact, if this is the mountain Andes, this is the Rocky Mountain. So a wind descends from above. This wind is known as Chinook. Descending wind from the Rocky Mountain, and in fact wherever here you have whatever ice or snow accumulation is there in these regions, they are being, this is snow accumulation here. When the wind blows, आपको पता है, here it is cold, here become warm, cool, where it become cool, warm, and then it become hot. It melt away all these, in fact, melting of snow. So इसको बोलते हैं क्या? This region, this is known as the Chinook. Chinook is called as the snow eater. Snow eater. In which country this is? This is in USA. Same type of, from the Chinook is there from Alps mountain. Fawn is from Alps. Descending wind from Alps mountain. From Alps mountain, the descending wind is called as Fawn. You remember this. Fawn and Chinook both are descending wind, mountain wind. Is it okay? Alps mountain in Europe, यहाँ से जो descending है उसका नाम क्या है? Its name. Yes, anabatic and katabatic wind, local wind another. Yes, of course, anabatic, katabatic. एक temperature loss करेगा, एक temperature gain करेगा. Tell me which one will be anabatic, which one will be katabatic. Can you please tell me? What are anabatic wind and katabatic wind? Which one will be anabatic, which one will be katabatic? Can you tell me? Yes. Tell me. Katabatic. Katabatic, this is katabatic wind. अनाबेटिक जो ऊपर जा रही है अनाबेटिक विंड है, नीचे आते हैं काटाबेटिक विंड है. सो वैली विंड इज अनाबेटिक, माउंटेन विंड इज काटाबेटिक. ओके, can you just memorize this? So these are the things here. I hope you got it. These are the local winds I have just said. They are the local winds here. Is it done? Valley wind, Fawn and Chinook हो गया. Now jet stream. Jet stream is the upper air circulation. You will find this jet stream in the upper atmosphere at nearly 8 to 12 kilometer height. There is a very high velocity wind. They are known as jet stream. These jet stream are of three major types. यहाँ पे एक jet stream होता है polar night jet बोलते हैं. In the winter polar night you will find out. Polar night jet stream. At this part here you have the this is subpolar regions. Here also you have. This is subpolar region, we have a jet stream. Westerly jet stream we have having westerly. Subpolar regions also we have polar night jet stream, then polar jet stream, then you have like near the subpolar regions. Then you have another one is subtropical westerly jet at the subtropical regions. In the last session which I did mention about different type of different zones in the wind belt on the surface which I told you, let me give you the jet stream belts. I'll just tell you jet stream belt of different region, jet stream global wind belts. If you look at I would like to say one thing here. Please remember, in any regions of the world, just 1 minute. I'll just show you here this jet stream. You see, at the upper atmosphere, you see this is the Arctic zone, tropopause. This is the jet stream here. This particular regions you have high. Here you have a jet stream on a polar night jet, polar jet stream, subtropical westerly jet. Okay, three type of jet stream you are having in these regions. In the upper part, you have the polar vortex is like because of earth rotation you have more and more. This is like earth rotation. In the upper part we have whirling and sinking of the air. Okay, the air sink here and goes down, and this is polar vortex here you are having. But I am talking about the jet stream. Jet stream में ये देखो आप, here is the regions at the polar area. This is polar cell. So here polar jet is here. This is subtropical westerly jet. यहाँ पे एक jet stream है. Here it is not written here. This is here is known as the this particular jet polar night jet. ये है polar jet. Subtropical westerly jet होता है ये. Okay, because west to east. This is like these particular regions. As I have just mentioned about this area, these particular regions, the polar jet stream or the jet stream this is the equatorial region. Equatorial region, convectional instability is there. Here is subtropical westerly jet. It is called as subtropical westerly jet because it flows from the west to east. Subtropical westerly jet. This is polar jet stream. This is polar night jet. Sometimes it develops. So आपका ये जो है ना, in the winter night you have polar night jet with the vortex, polar vortex formation. By the way, these are the very high velocity wind which blows in the upper atmosphere at a particular band with the wavy band. The wavy band here, which is called as the Rossby or index cycle, we are having index cycle here. You see here. This is a jet stream which they blows. Can you see this? This is a jet stream. Another jet stream I told you, which usually forms during the winter night here, polar night jet, PNG. Also here it will get it. So it is polar jet stream, subtropical, westerly jet, subtropical, westerly jet, and this is. So by the way, the jet stream are responsible for triggering the process of different climatic phenomena over the earth atmosphere. Ye directly, indirectly they are having lot of impact on the earth atmosphere. Okay. It has more impact on the earth's atmosphere, I said. These are certain things I would like to say, right? See now, this is all about the wind system. I hope you got it. Some idea you got it now about the wind system, right? So, hopefully you got these two things now. I have just said about the wind system. I said about the climatic region, how they are related with the wind system. I'll go for now two things here, cloud and precipitation. Cloud and precipitation. Whenever, what is the cloud in fact? What exactly is the cloud? What are clouds? Condensed dust particles with the water vapor is called as cloud. This cloud are of different types. In fact, इसके लिए दो चीज चाहिए, एक तो dust particle, दूसरा है water vapor. Whenever this water vapor got completely condensed because of low temperature condition, freezing होगा, then it forms like cloud. Clouds are of different type, rain bearing cloud. Rain bearing cloud कौन कौन सा है? Mostly nimbus, nimbostratus, cumulonimbus. These are the clouds. Nimbus, nimbostratus and cumulonimbus are the cloud which are rain bearing cloud. They give rainfall. They give enough rainfall. These clouds are responsible for giving rainfall here. Okay, rain bearing cloud these are. Other clouds are mostly rainless cloud, but they are based on the height, their location, there are different type of cloud. I am saying based on its location, there are four major groups of cloud. Four major groups of cloud. Number one, first group is high cloud. High cloud, all these clouds are which are having cirrus, shir, as the suffix or prefix are high cloud. You see, here is the three cloud, cirrus, cirrostratus, and cirrocumulus. These are the three clouds which are high clouds. Cirrus clouds की average height जो है ना 6 to 12 किलोमीटर height होता है from the surface. From the surface the height is 6 to 12 kilometer. You remember this. Surface to its height is 6 to 12 kilometer height, and this type of cloud, they are high cloud because of height. They cool down very quickly and they form ice crystals. They have ice crystal. It comprises ice crystal. It comprises ice crystals. Ice crystals होंगे. Why ice crystals? Because of sudden cooling. Because it goes up. Cooling down of this leads to ice crystal formation. Cirrus cloud sorry. Cirrus cloud are those clouds which are in the upper atmosphere, as I said, they are white and dazzling cloud, and they are usually, they give no rainfall. These clouds are like, they broom shaped, like, mare's tail shaped cloud, you must remember this, mare's tail shaped cloud, ऐसे होते हैं ये, mare's tail shaped cloud, these are mostly mare's tail shaped cloud. Cirrus cloud, whenever you will get, remember there will be no rainfall at that time, there will have no disturbances. Stability it brings, it gives or indicates stability. Okay, cirrus cloud is okay. Cirrus cloud gives stability. I say cirrostratus, stratified cirrus cloud. So second is cirrostratus. Cirrostratus is a high cloud. Stratified cirrus cloud. So if we are standing here, this cloud is like here in these regions. This is cirrostratus, stratified cirrus cloud, while the sun rays or the moonlight passes through it. If you have the moon here, when the moon or sunlight, let us say, this is the sun here, light is falling over this, the moon या sun जो है ना clear दिखाई नहीं देगा. What will happen here? It will not, no clarity, no clear surface of the sun you will get, or the moon. This is known as the halo effect. Halo effect of sun and moon. This is like धुंधला सा चारों तरफ दिखाई देगा. You will not able to see this outer surface properly. Rather, there is a blurred vision when because of primarily due to this case. So, halo effect of sun and moon, cirrostratus cloud. Remember, whenever any stratus cloud you have, it will definitely give rainfall. मतलब drizzling it will give. Drizzling, that is fairly uniform raindrops. You will have fairly uniform raindrops. बूंदाबांदी होगा. Halo effect of sun and moon, fairly uniform raindrops. In this case, please remember cirrostratus. Now third one is cirrocumulus. Third one is cirrocumulus. Cirrocumulus cloud. Cirrocumulus. These are cumulified cirrus cloud. These are cumulified cirrus cloud. Cirrocumulus. These are cumulified, highly cumulified cirrus cloud. Cirrocumulus. Okay. Friends, you must remember one thing, because these clouds are cumulified, because of their change in the direction maybe of the clouds in the high cloud category. You just see what I'll say. Have you seen the scale of the mackerel fish? It will join this, like, you will have like this type of mackerel fish scale, like. Mackerel sky. Mackerel skies. Like school, it looks like as if scale of the mackerel fish. So I said mackerel sky. Cirrocumulus, mackerel sky. Cirrocumulus is mackerel sky. These are cumulified cirrus clouds, cirrocumulus. Oh, they will not give rainfall, please remember, but they indicate there will be a coming disturbances. All these are high cloud here. Now medium cloud based on the height, medium cloud, their height is from 3 to 6 kilometer height. And in this type of cloud, alto is the surface suffix or prefix, like alto cumulus, alto stratus, alto cumulus, and alto stratus. So it is cumulified cumulus, alto cumulus, alto. These are cloud generally found 3 to 6 kilometer height. They are dark in color mostly. Alto cumulus, dark to brown color, Alto stratus is stratified one. It gives drizzling. Alto cumulus, no rainfall. Not exactly dark, you cannot say, but you can say brown color, gray to brown color. White, they develop fast as the white color because of ice crystals and all this. They also have, like, glittering things, but ice crystals is in the upper level, no doubt, wherever it move upward because of convectional instability or something. But here you have like alto cumulus, cumulified one, brown color. To this is no rainfall here. Alto stratus keep drizzling. This is there. There is no much things about this particular cloud type. Then you have the low cloud. Low cloud, you remember what are those? It is up to surface to 3, up to 3 kilometer height. It is up to 3 kilometer height here. So remember, this is the low cloud from the surface up to 3 kilometer height if you will go. So here you have like cumulus and stratocumulus cumulus, stratocumulus, and what else? These two are very important, cumulus cloud and stratocumulus cloud first. And you have cumulus, stratus, stratocumulus. Three types of cloud. Cumulified cloud, these clouds are white and dense cloud. Dense cloud, white and dense cloud, they are cumulus cloud. While you'll see these things, sometimes very difficult to differentiate between this and your what you call fog in that region. White and dense cloud, cumulus cloud, they don't give rainfall. Stratocumulus, stratified one, this is, layer by layer, plus there is an alternate band of here, alternate band of stratus and cumulus cloud. Cumulus cloud, alternate band of stratus और cumulus दोनों alternate band में होंगे. Cumulified cloud, stratified, cumulified, stratified. So whenever you will have in the coastal area mostly you will find out, or after heavy rainfall you have this, suddenly you will get sunlight, then complete dark, then again sunlight, like this you will find out because of presence of stratus and cumulus cloud. So these are like white to grey होता है, ये केवल white नहीं है, white to grey color. This is cumulified cloud. So whenever its density is more, light cannot come inside and it will have like darkness, light and dark. Stratus cloud or stratified cloud, these are thin layered cloud. It gives drizzling, it brings drizzling, you remember. Whenever you are getting stratus cloud, it brings drizzling. Layered cloud, layer by layer, it brings drizzling. This cloud brings drizzling, and these are medium cloud, I said. Okay, medium cloud, all these three are medium cloud. Let me go for the vertically developed cloud. Fourth type of cloud is vertically developed. Remember, vertically developed cloud are very important one for your exam also. These are like, one is cumulonimbus. These are very dense, dark, with maximum vertical extent goes beyond 12 kilometer height. 12 kilometer height. These are cumulonimbus cloud, very dense, dark, with maximum vertical extent, goes beyond even 12 kilometer height. Okay, Now I am getting at your response. Since long I haven't got any response. Now I got it. Please. Where is thank you very much for your response. बहुत टाइम हो गया कोई कुछ बोलता ही नहीं है यार आप लोग. Immediately I am not getting your response. That's the problem. Now I got it. Valley wind is an anabatic wind or katabatic wind? Achha, let me see first. Sir, nimbostratus and stratus cloud is the same cloud? No. Nimbostratus gives rainfall, stratus will give drizzling. So आपको जो बताया मैंने nimbostratus यहाँ पे है. Stratus and nimbostratus, you can write nimbostratus. I am including the nimbostratus in the nimbostratus is included in both low category as well as in the vertically. I mean, it has some vertical extent also. From below, from the surface up to, it goes up to in fact around 5 kilometer. So दोनों category में आते हैं. So I'll discuss about that one, right? I'll discuss about this. Now the question is, the greatest problem, when I will not get any response, mean I am feeling like, okay, you got everything. Now I am getting this. You should very quickly should give the response. So, anabatic or katabatic, I have already mentioned about the wind. Katabatic, cold wind, that side is going down. Mountain wind is katabatic, yes. Fawn is, I told you, fawn is from the Alps mountain. Chinook is from the Rocky mountain. Okay, very good. Doldrum, what are doldrum? You said at the equatorial low pressure condition. At the equatorial low pressure zone, this part, because of the presence of both sides, you have having what? Wind, trade wind. At the middle part, you have a, what type of zone this is? At the middle part, we have a silent, calm and quiet zone known as, this is known as doldrum. Okay. This doldrums shift up or down. Could you explain movement of jet stream? Why not? I have already given. Jet stream has 3 jet stream. I have just given permanent one. The one here you have the jet stream move from west to east only. You remember here these 2 jet stream. This is polar jet. This is subtropical westerly jet. 2 plus you have a, in the winter night you have a jet stream here in the in the polar night jet stream. Here you have a sometime occasional jet stream is there, Finletter jet, or here Somalia coast, this is here is a jet stream. It is easterly jet. African easterly, tropical easterly jet also there. These are occasional, not permanent one. For prelim point of view, itna most than sufficient hai. Sir, nimbostratus and stratus cloud is the same cloud. No, they are different. Stratus cloud is stratified only. Nimbostratus has more moisture in this. Height of nimbostratus is more than the stratus cloud, and nimbostratus is considered only both in case of low as well as vertically developed cloud. What is the reason for the brown color of alto? Alto cloud is not only brown, white cloud also there. They vary. It depends on the dust particles in that and the level of where it is dust particles. These 2 things are there, and in many cases even white color you will get. आपने देखा होगा जैसे ही फ्लाइट टेकअप करता है कभी कभी कुछ भी दिखाई नहीं देता, केवल व्हाइट ही दिखाई देता है. दैट इज ऑल्सो कमिंग ऑन द मिडिल क्लाउड. यू रिमेंबर alto cumulus cloud, though I have said about brown gray color, it is also in white color. कभी कभी color may vary with respect to the quantity of moisture as well as the dust type. Okay, fine. Hope you got it. My request to all of you, participation. Participation will give you rather better quality. You have also, I also feel very happy on that. कुछ समझ में ना आए तो कोई फायदा नहीं है. आप लोगों का and you have to go quickly because this is for quick round thing, and I feel like you haven't got the information properly mannered, maybe because I thought like you are completely prepared and coming with the question, bombarding with the question. I am asking you several times, pucho, eh? Sir, I mean zigzag movement of the jet stream. Zigzag movement of the jet stream is because of index cycle. यो देखो यहाँ cold air is coming in this way, warm air is in this way, air mass, cold air mass and warm air mass. When both of them they meets, at that time, at the upper part now you think, wherever frontogenesis takes place, front development takes place in the upper part, and temperate cyclone develop in that regions. At that time, you have like the upper part, the flow of the wind will be there. This is not in a straight path because of three causes. First is this thermal gradient between two air masses. Second one is because earth is round. There is like to conserve the, because the earth is curved here. Okay, earth is curved here. So velocity, it cannot go straight like this. To adjust itself, the wind, in fact, the curvature path they have to take, and it became zigzag also. And as we know, this is like the cases of here index cycle development, which you call, because of differences in the density of air at different part and their pressure in the upper part in different level, gradient will differ at different place. So gradient यहाँ से इधर आया, इधर से उधर जाएगा. This gradient is also, gradient difference is also another cause. By the way, the jet stream zigzag movement again in the temperate cyclone type, I'll mention this. Okay, just to wait for that. Coming to the vertical developed cloud, cumulonimbus cloud, cumulonimbus, very dense dark with maximum vertical extent goes beyond 12 kilometer height. Okay, it has maximum charge differences and comprises ice crystals which quantity of moisture and supercooled denser it comprises ice crystal, huge quantity of moisture and supercooled denser ice up ice with dust particle with hygroscopic nuclei. Hygroscopic nuclei, which is responsible for disturbances in the cloud and subsequent precipitation, etc. Cumulonimbus cloud is very vertically developed cloud. They are responsible for. It is responsible for giving. It is dark in color, and is responsible for heavy continuous heavy rainfall, heavy to very heavy rainfall, heavy to very heavy rainfall, heavy to very heavy rainfall. Done. continuous heavy to very heavy rainfall for a very short time period. अच्छा, ये जो क्लाउड होगा इट हैज इनबिल्ट ऑफ cumulonimbus cloud. There is more charge difference, I said. 10 to 12 kilometer height up to which it is there. It is known as thunder cloud. क्या बोलते हैं उसको? Thunder cloud. It is responsible for lightning. Thunder cloud responsible for lightning. It is a thunder cloud mostly responsible for lightning. Heavy to very heavy rainfall it gives. Darker color, I said, and associated with mostly develops over the tropical region. So equatorial climate because of more convectional instability, more convectional instability leads to this. Cyclonic zones. Wherever you have a cyclone, you will get this. Mostly in the tropical cyclone regions, you have development of this one. So equatorial climatic zone and cyclonic zone, where you have this type of climate, mostly you will find this type of climate. Hope you got it now. So this is bringing heavy rainfall to heavy to very heavy rainfall. Okay, second type of cloud is, second one in this type is nimbostratus. Let me tell you, nimbostratus is coming under, this is a rain bearing cloud, stratified nimbus cloud. It gives rainfall, but for rainfall of low to moderate intensity. जो अगर क्लाउड ब्रस्ट होता है कहीं पे ना, इफ देयर इज ए क्लाउड ब्रस्ट इट इज cumulonimbus cloud, but you have temperate disturbances whenever you have an rainfall. This is mostly nimbostratus. It gives rainfall of low to moderate intensity, okay, for a long time period. For a long time period you have like this nimbostratus. It gives for a long time period. Please remember this. You got it? Stratified nimbus cloud. It gives rainfall of low to moderate intensity for long, mostly found with temperate cyclone. And in India, during western disturbances, winter rainfall, western disturbances, at that time also nimbostratus. Okay. Now nimbus cloud, these are white and dense cloud generally found in and tropical and you know even the temperate region, warm temperate region. It is a cloud, rainless cloud, which indicates clear weather condition, fair weather condition, fair weather condition, fair weather condition. It indicates fair weather condition here. This cloud indicates fair weather condition. Okay. वाइट डेंसर क्लाउड आपने देखा होगा जब आप टेकअप करते हो ना पूरे वाइट कंप्लीटली वाइट दिखाई देता है और ज़्यादा टाइम तक फॉर ए लॉन्ग टाइम विल नॉट सी एनीथिंग. दिस इज हियर इज दिस क्लाउड. This cloud has a different thing I said. White and dense cloud generally found in tropical and warm temperate regions. It is a rainless cloud which indicates fair weather condition I told you. Hope you got it now. These are the cloud types which I have just mentioned. Try to see it from, if you have the GC Leung book, you can see that. That will be enough for you. और ज़्यादा कुछ करने का नहीं है प्रीलिम के लिए. We will go for now precipitation. Precipitation generally occurs. Precipitation is the process of release of moisture from the atmosphere, release of the moisture from the atmosphere. So we have like a rainfall. Rainfall is in the liquid form. Then you have the snowfall in the solid form. Then you have sleet equal to rain plus snowfall. Then you have drizzling is fairly uniform raindrops. Drizzling. Then we have hailstone, white and opaque. Snowballs. Hail developed due to supercondensation. Okay, hail. Suddenly, if the air parcel move upward suddenly and supercooled condition develops, then you have hailstorm. Drizzling is fairly uniform. In case of you have your stratus, nimbostratus or stratus, altostratus, all the stratified cloud you have drizzling. They are the things here. Rainfall are of different type. You know it? No. One is you have your orographic rainfall, convectional rainfall, cyclonic rainfall. Orographic rainfall, convectional rainfall, cyclonic rainfall. Tropical cyclonic rainfall and temperate cyclonic rainfall. Orographic rainfall will be there where? If you have a mountain here, you have a mountain in this side, right? You have a mountain and the air is coming from this side, cold air is, moisture laden air is coming here. It will move upward and there is a possibility of formation of, here it will form cloud and this side only it will give precipitation. And in the opposite side you will have only dry air will go in this way for dry air. This area is rain shadow area, rain shadow zone. This is windward side. This one is the leeward side. This is the leeward side. Because of mountain as a barrier, if somewhere rainfall is there, this is known as orographic rainfall. The best example of this one we can see, here you have Bombay, here is Pune. Bombay has the rainfall, if you will see, around 200 centimeter rainfall and here it is have around 80 centimeter rainfall. Why so much of variation even if the distance is very less? Because of the Western Ghat mountain here. Here it is Western Ghats mountain. This is the major cause for this. Orographic rainfall is responsible. It is like, because of this only you have differences in the rainfall pattern in both. If nimbus and cirrus both have clear sky, then what's the difference? See, nimbus and cirrus. Cirrus is high cloud, white and dazzling cloud. In the winter you will find out. Nimbus you will get it in the mostly in the other season type. Nimbus, this is the high cloud is, you have your high cloud. Which one? Nimbus cloud is a low, it is a vertically developed one, nimbus cloud. Okay. Nimbus and these are very different. Cirrus cloud is very up. They have ice crystal. Nimbus cloud, they don't have the ice crystals. Please remember. Usually the cirrus cloud has ice crystals. ये बहुत height होगा उसका. Height is much more. Please remember. Okay? Is it okay? Right. The person who asked me, you got it? निम्बस क्लाउड की हाइट बहुत ज़्यादा होगा, सॉरी सिरस क्लाउड की, सर सिरस आइस क्रिस्टल है, ये कलरफुल स्काई देता है, because of when the sun rays falls over this past these regions, because of ice crystals, refraction will be there. But in case of nimbus cloud, you will not have such type of refraction. Please remember, कलरफुल स्काई नहीं भी दिखाई देगा निम्बस में, सीरस में दिखाई देगा. सीरस तो ऊपर एक सीलिंग जैसा ऊपर है और निम्बस तो नीचे से ऊपर तक है. डिफरेंसेस आर देयर, मच मोर डिफरेंसेस माय फ्रेंड. एनीथिंग यू वांट टू आस्क प्लीज? यू गॉट इट और नॉट? द पर्सन हु आस्क्ड मी एट 1:28. Okay. As we have seen about the orographic rainfall are generally occurs because of orographic rainfall is primarily due to relief features or a mountain as a barrier. Okay. So I have just given an example. Now what is convectional rainfall and what is cyclonic rainfall? We will see. Convectional rainfall. Convectional rainfall. Because of high temperature, due to very high temperature, the lighter air gradually, because of very high temperature, the lighter air gradually moved upward. Vertically it moved upward. Okay. And this upward moving air, subsequently it will form cloud here. And it gives subsequent precipitation also. Okay. This is called as convectional rainfall. Moisture laden, moisture rich, hot air moved upward due to convectional instability. This is what? Convectional instability. Okay. Because of the convectional instability, the air moved upward. While it goes upward, it spread out. You know why it spread out? Because density is very less in the air, so it will spread out. It forms a cool down and it forms cloud and give rainfall. Mostly the convectional rainfall you will find out in the equatorial zone, equatorial region, and of course tropical lowlands. There also you have. Wherever more high temperature is there and more convectional instability, you will have convectional rainfall. Okay, I hope it is clear to all of you. Convectional rainfall, where it is? Equatorial climate, equatorial region, equatorial climate, convectional rainfall. Okay. By the way, one question can be asked during the monsoon, our Indian monsoon. Whenever our Indian monsoon is there, during that time, majority of the rainfall is what type of rainfall? Orographic rainfall. Around more than 75% of rainfall in India is orographic in nature. Orographic. Okay, convectional rainfall is very less in India. Only the pre-monsoon disturbances is convectional rainfall. जो बारिश आता है ना इंडिया में, प्री मानसून डिस्टर्बेंसेस जो होता है ये कन्वेक्शनल से रिलेटेड है. इन द प्री मानसून डिस्टर्बेंसेस इन इंडिया, मानसून आने से पहले, व्हाट इज दैट? प्री मानसून डिस्टर्बेंसेस. प्री मानसून disturbances in India is generally convectional in nature, convectional in origin. My friends, you remember before the monsoon will arrive, there is a pre-monsoon disturbances which is known as Kal Vaishakhi in West Bengal, which is known as Bordoli Chera in Assam, or Bodoi Chila Bordoli-Chilla or Bodoi-Chilla. This is in Assam. The third one is pre-monsoon disturbances. Pre-monsoon disturbance in India is generally convectional in origin. Kal Vaishakhi, Bodoi-Chilla, mango shower. Mango shower is where? Mango shower is in Konkan coast and Malabar coast. Malabar coast in Kerala and Konkan coast of from Maharashtra, Goa, of course up to Karnataka and Kerala. So remember, if it is there, you must remember Karnataka is the first preference. Mango shower, Karnataka is the first preference. Then you have the coastal area, all the coastal area. Konkan coast, ये होता है बोलते हैं कानारा कोस्ट एंड मालाबार कोस्ट. ये रीजन्स है. पूरे रीजन्स को बोला जाता है मैंगो शावर की, बट इट इज स्पेसिफिकल स्टेट मीन कर्नाटका. सेम वे वी हैव टी शावर in Assam, and cherry blossom shower. Cherry blossom is in Karnataka. It is also known as nor'wester in eastern part of India, also called as the nor'wester in eastern part of India, eastern India, nor'wester. These are the important region here. I hope you will able to do. You might be now it is clear. These are the area here. All these are convectional instability which leads to this Kal Vaishakhi, Bodoi-Chilla, mango shower, tea shower, cherry blossom, nor'wester, all these things. Okay. Done. It is in the monsoon, pre-monsoon disturbances in India. Pre-monsoon disturbances in India. So convectional rainfall where it gives. Another one. Third type of rainfall is cyclonic rainfall. Cyclonic rainfall, remember my friends, they are the rainfall during a cyclone. If it is a cyclone are of different type, you know. It can be tropical cyclone or it can be temperate cyclone. So what is a cyclone? Let us see. Cyclone rainfall due to the cyclone. So there are different type of cyclone. Let us see now what is a cyclone first. We will see what is a cyclone. An intense low pressure condition with very high velocity of converging whirlwind system. An intense low pressure condition with very high velocity of converging whirlwind system is called as a cyclone. Okay, got it now? So cyclone is a very intense high velocity converging whirlwind system. Okay, so cyclones in a cyclone, low pressure zone is surrounded from all sides by high pressure condition, high pressure conditions. A low pressure zone surrounded all sides by high pressure condition. There are two major types of cyclone. There are two types of cyclone. Number one, tropical cyclone, and number two is temperate cyclone. Temperate cyclone. There are two types of cyclone, tropical cyclone and temperate cyclone. Please remember this. Tropical cyclone and temperate cyclone. Let me discuss about tropical cyclone now. Friends, as per our schedule, we were supposed to discuss this. We have already done these two. Now I will go for this cyclone and anticyclone I will discuss. Okay. So this part I will discuss now. With the rainfall, I will relate the things with the rainfall. I just tried to give you here wind system to cloud, wind system to climatic region, and wind system to cloud, cloud to precipitation, precipitation to this one. From there, I will go in this way. Okay. आपका जो discussion हुआ, in this way I have discussed the things. So what is a cyclone? Let us say. I have just said tropical cyclone first. Remember, tropical cyclones are those cyclones generally found between the tropical region itself. Let me do one thing. Let me classify this cyclone into two types as I have just mentioned. This is tropical cyclone, and this side I will go for the temperate cyclone at a time and discuss about this. Quickly you can see this. Tropical cyclones generally, what happened. Tropical cyclone is a cyclonic type in which, if I will see the location of this one, in both the cases, location first. Tropical cyclone found between 5 to 20 degree or up to 30 degree, 5 to 30 degree latitude. Temperate cyclones are developed at the, where you will find it this is between 45, 32 or 40 to 60 degree latitude. There is a difference, from here 5 to 10 degree and this is 40 to 60. Generally you will get, so technically 40 to 60, but as we call it 30 to 60 degree, but there is a variation here. Location is like this. Now, among these two, if I will say, second point here is like place of origin. It develops only over the tropical water bodies, tropical ocean. It can develop anywhere anywhere, both ocean and continents in the temperate zone. In the temperate zone. Okay. Third point. Conditions for development. Conditions for development. Tropical cyclone develop in the region. Temperature requirement is more than 27 degrees Celsius. Okay. Then you have presence of a weak trough, weak low pressure trough, presence of a weak low pressure trough, then weak vertical wind shear, weak vertical wind shear mean what? That's like, vertical, the whirling of the wind should not be there. Upper air divergence, convectional instability of air, here these are the condition it requires. Temperature should be more than equal to 27 degrees Celsius. Presence of a weak low pressure trough. Trough mean this type, weak low pressure condition like this. Trough. This is a trough. Elongated low pressure condition. If it is there, it will be good. One of your friend is asking, can we please discuss a little of air masses as well as in our session? Yes, why not? We will discuss. Why not? In the conditions for the development, I will do this now. In the temperature, these are the conditions. We need 27 degrees Celsius temperature, presence of the weak low pressure trough, elongated low pressure condition, that will be very good. Weak vertical wind shear, while the wind is moving upward, it should not, at the low height, it should not diverge. Upper air divergence. In the upper air, you have divergence, convectional instability of air. These are the basic conditions, ITCZ, when the ITCZ breaks, this ITCZ breaks, and they may form this type of trough also. These are favorable condition. Now, here is conditions for the development. Condition. Sorry. What are the condition here? First condition is presence of or development of convergence of two contrasting air masses. Now our friend asked me that, sir, can you have some detailed discussion? Why not? We will do that. Now what are the air masses? Let us see. Let me do it here. Air mass is a huge body of air experiencing homogeneity in any of the physical parameter. So based on the surface feature, air above this will have uniformity. Got it? So, because it is standing, it is, if you look at a mass of air, if it is here, it is stand still for long time over the polar area. ये पोल के ऊपर बहुत टाइम एक जगह पे रह गया, तो क्या होगा? Because of the heat transfer and all, it will develop, the entire regions will develop as a unity, and this air, mass of air will act like unity. The vertically, if you look at the thermal condition of this one, like if you go up, temperature will gradually decrease, it. But here the variation will not be there. Vertical variation in temperature, definitely it will be there, but it is very less. बहुत ही कम होगा. तो ग्रेडियंट में जिसमें कम होना चाहिए उससे बहुत ही कम होगा. I mean almost they act like unity. A body of air, a mass of air having uniformity in terms of its physical characteristics like climate, like temperature, humidity, pressure condition is known as air mass. If it is over the polar area, cold air mass. If it is the tropical warm condition, warm air mass. Two types of air masses. So, air mass, a huge body of air experiencing uniformity in its physical characteristics like, कैसा है? Characteristics like physical characteristics like a huge body of air experiencing uniformity in its physical characteristics like temperature, pressure, humidity, etc. Temperature, pressure, humidity, etc. is known as air masses. Now, it reflect the physical characteristics of what? Of the surface over which it develops. Surface over which is developed is called as source region. Source region. The surface over which it develops is called as source region. Source region are of different types, You can see here, if this is the earth here, right? And here you have the equator. Here, cold air mass develop in this region. Source region is polar source region. Polar zone. Polar zone. And here you will have the tropical zone. This side you have the tropical zone. Tropical zone. So, what will happen from the tropical zone will be, you can see here, tropical zone will be here, polar. From here an air mass will go toward this side. This will be air mass. From air mass which will come from this side, cold air mass. Okay. So, polar zone by cold air mass will form. Here it is warm air mass will form. Here you have the warm air mass. This is warm air mass. This one here it is a cold air mass. Cold air mass. Cold air mass. Cold air mass and warm air mass they meet and form the cyclone. Cold air mass, आप सोचो, when a cold air mass is going from the colder region this side, it try to cool down the surface. Warm air mass is coming from this side, try to warm up the surface, and both have completely different characteristics. Whenever cold and warm air mass, both of them they meets, what will happen at that time? Cold air mass are denser, very cold, heavier one is sink, and warm air mass rides over this. And there is a, in that regions, whenever they meet, they form a front. The front jo hoga na, front means the meeting place of both the air masses, it get inclined. Because cold air mass will sink down, warm air mass will rise up. And at that time, cyclone develop. Okay. Air mass are of different type, cold and warm, based on the source region, polar air mass and tropical air mass. P equal to polar air mass, P equal to polar air mass, S equal to T equal P polar, T tropical air mass, M equal to maritime means source region is over the ocean, C equal to continental. एयर मास को ना डिफर कर सकते हैं डिफरेंट टाइप में बेस्ड ऑन देयर सोर्स रीजन. इफ इट इज ओवर द ओशियन मेरीटाइम, इफ इट इज ओवर द कॉन्टिनेंट कॉन्टिनेंटल, इफ इट इज इन द पोलर रीजन पोलर एयर मास, ट्रॉपिकल रीजन ट्रॉपिकल एयर मास. आई होप यू गॉट इट नाउ. नाउ व्हाइल एन एयर मास मूव्स टू द फ्रॉम कोल्ड टू द वार्म एरिया, आप सोचो यहाँ पे प्लीज लुक एट वेरी केयरफुली. व्हेन ए कोल्ड एयर मास इज कमिंग इन दिस वे, cold air mass will try to cool down the warm surface. I mean it will warming from below. Cold air mass will have warm from below. Warm air mass if it is there, it will try to warm up the colder area. Matlab cooling from below. You got it what I am saying? Very very important. Cold air mass warming up from below, warm air mass cooling down from below. So उसके हिसाब से इसका भी डिफरेंसेस है. स्टेबल होगा, अनस्टेबल होगा. के मीन काल्ट और W मीन वार्म, K और W. सो देर आर डिफरेंट कोडिंग एंड डिकोडिंग सिस्टम यू आर हैविंग ऑन दिस. आपको इसके ऊपर डिटेल में पीटी में नहीं आएंगे. पीटी में आपने पूछा तो बस बता दिया मैं. whenever two contrasting air masses meets, there is warm air mass and cold air mass meets. The cold air mass sink down, warm air mass will lifted up, and there is formation of cyclone. And this is what is the temperate cyclone I said. So I hope this much you got it. Let me come to air mass के बारे में थोड़ा बहुत पता चल गया. यहाँ पे convergence of two contrasting air masses, cold air mass and warm air mass. cold मतलब polar continental air mass and tropical is the warm maritime air mass. डेफिनेटली साइक्लोन होगा. कोलर देखो आप, सी मीन कॉन्टिनेंटल, पोलर ये कोल्ड होगा, इस पे मॉइस्चर भी ज़्यादा नहीं रहेंगे, कोल्ड एंड ड्राई होगा. ये मेरीटाइम ट्रॉपिकल में क्या है, ट्रॉपिकल एरिया लॉट ऑफ मॉइस्चर इट हैज and it is warm, and these two air masses while they meets there will be more instability and there is a possibility of this. Second point is ये जो है ना presence of यहाँ पे एक होता है बी, देखते हैं डेवलपमेंट ऑफ फ्रंटल फ्रंटोजेनेसिस, प्रोसेस ऑफ फ्रंटोजेनेसिस मतलब फ्रंट फॉर्मेशन का प्रोसेस होगा वन टू कंट्रास्टिंग एयर मासेस मीट्स, दो एयर मास जहां मिलेंगे, बोथ द एयर मासेस बॉडी ऑफ एयर दे मीट्स, द ट्रांजिशन जोन इज नोन एज फ्रंट. Now this front will depend on what quality of air masses and their differences between the air between these two. If it is cold air mass try to sink down, warm air mass will goes up, and whenever they meets, the warm air mass has a moisture, goes up, cold air mass sink down, and in between there is cloud formation and there is also cyclonic activities. So यहाँ पे process of frontogenesis, front will develop, and it is now what will happen here conditions. यहाँ पे जैसे convectional instability, यहाँ पे advectional instability is there, advectional instability will have, मतलब कन्वेक्शन ऊपर जाते हैं वर्टिकल में, और यहाँ पे हॉरिजॉन्टल इंस्टेबिलिटी है, हॉरिजॉन्टल मूवमेंट ऑफ एयर इज नोन एज एडवेक्शनल, हॉरिजॉन्टल मूवमेंट ऑफ एयर इज नोन एज एडवेक्शन, advection is horizontal movement. So my friends, if the movement here is like, if there is a case of movement of the air from here to here, ये horizontal है, this is advectional, tropical to polar advectional, polar to the tropical region advectional. Advectional instability is responsible for development of the temporary cyclone. Convectional instability is for the tropical cyclone. Upper air divergence is near in tropical cyclone, but here two contrasting air masses convergence is required for temperate cyclone. Okay, this much is clear. Condition for the development. Okay, now fourth I will go for fourth point. I will see now. What happened here? The isobar in case of a tropical cyclone, the isobar will find out are circular in shape. I will ask me, sir, what is isobar? Is not it? This is the lowest pressure here. Here I said isobars are circular and closely spaced. I mean, there is gradient is more, but in this case isobars are elongated. Sorry. Isobars are elongated and widely spaced. Widely spaced. ये सब isobar क्यों widely spaced है? Because two contrasting air masses are meeting and they are fusing. यहाँ पे क्या है? They are circular because uniform surface, C surface on which convectional instability is there. All side uniformly you have temperature and the pressure condition will have this type condition. Okay? Fine. Okay. Got it? I hope you got it now. Fifth point. Friends, you must remember one thing. ये जो tropical cyclone है, it is thermal in, it is always convectional, it is very advectional. Structure को हम देखेंगे. Structure of this cyclone. You have an eye here. It is like this, you see. Let me draw it. Draw two diagrams for this. This one and this one. How the cyclones are there, you just see. You will get to know from these diagrams. This is the eye of the cyclone, and the air here suck and move upward. It will thrown up. You see here, cyclonic storm, it will rotate clockwise or anti-clockwise on the basis of which hemisphere it is. I told you earlier, if it is northern hemisphere, I have already said, if it is northern hemisphere, if it is low pressure condition, wind is converging in this way. If the winds are converging in this way, it will turn towards the right. Towards right. So, overall if you will see, in its cyclonic circulation, it will be clockwise or anti-clockwise. How it is? How is this circulation overall? ऊपर से अगर देखा जाए, anti-clockwise circulation. So, it will have anti-clockwise movement here like this. You got it? Anti-clockwise movement of this, not clockwise, anti-clockwise movement in northern hemisphere. So, it is anti-clockwise clockwise circulation in northern hemisphere and clockwise in southern hemisphere. Northern hemisphere anti-clockwise, clockwise in southern hemisphere. Cyclone. So for both of these you have like same thing. For any cyclone, clockwise, anti-clockwise based on this. I hope you got it now. Now ये circulation होगा. इसको बोलते हैं eye and this is called as the eye wall. This is the eye wall. Eye wall. Eye is the silent zone. This is silent zone. This is almost silent. At the middle part is silent one. The lowest pressure, but highest temperature, lowest pressure, but silent zone. This is the beauty of this area. Highest temperature, lowest pressure, but it is a silent zone. This is the eye of the cyclone. Okay. Center of the cyclone has an eye which has highest temperature and lowest pressure. Highest temperature, lowest pressure. On the contrary, this side you see there are two contrasting air masses. Cold and warm air masses, they meet here. Cold air mass and the warm air mass, they will meet, and subsequently what will happen? They form a front like this. This is the front. This is warm front here. This side is warm front. Warm front. This side you have cold front. Two types of front you will have. Cold air, warm air is here, it will be more dominating, तो warm front हो गया. Cold air and warm air, you see here, cold front and warm front they will develop. Cold air will sink down, warm air will move up here. And this is the front, warm front and cold front, two type of front you have. ऊपर की तरफ देखो, upper part you have the pressure of the warm air will be more. Below you have cold air will be more. So you have like these two type of front you will have, cold and warm front. And subsequently this will gradually bend, and there will be formation of, here you have like in this case you will have a different kind of characteristics you will have. cold front travels much faster than the warm front. ये इससे ज़्यादा आगे जाएगा. And for that reason, you know, it will have a here warm low pressure condition will develop here. See, this will lifted off very quickly, it will goes down. Then this particular point, this is going up no doubt. ये देखो आप यहाँ पे, this is going down and this is the heavier one. Cold front will cut this and there will be a kink formation like this, and you have subsequently you have cyclonic storm here. This is the cyclone. Cyclone will develop in a phased wise manner. Let me tell you, there are 5 stages of development of this one. This type of cyclonic storm, as I have just mentioned, the temperate cyclones are always, you remember, whenever 2 air masses meets, then only it will have. And the air masses here, in this case, of contrasting type of air masses you have. Completely contrasting air mass. Cold air नीचे गया, warm air को ऊपर उठा दिया. और यहाँ पे जो kink formation, I mean there is a formation, you can see here, it is like this. This is triggering the factor. Cold air मतलब high pressure हो गया, इधर low pressure हो गया. So in this way you have development of cyclone, and this cyclone gradually develops over these regions. And if this is one picture I have just given. If I'll draw another one, you see here what happened. As you were asking me about even the regions of temperate cyclone and jet stream movement, let me tell you, you have the cold air mass is stronger here, warm air mass is stronger here. You got it now? Here you have front formation. This is the frontal zone. This is the frontal zone here. Okay. So when it will goes down, this is going here inside. You have like this particular part will break off and forms a low pressure, and here it will comes as a high pressure. Here it will coming as a high pressure subsequently. And in this way, in these regions you have formation of both sides. You have a temperate cyclone, this side also you have temperate cyclone. On the vertically if you will see, it will be like this. For better understanding, I request you to read even GC Leung if you want. I am saying the cold air is coming this way, warm air, both of them they meets. Cold air sink down, warm air lifted up, and there is cyclonic storm. This is temperate cyclone in general. And this, there are different cases here. When the air moved upward, in the upper part you have, what is there? You know, differences in the pressure. This leads to the, in one end to another end, funnel like it develop, and there is pressure gradient, so air will move. And this air, while it move, it cannot move in one straight path because of the, to maintain earth curvature itself. So this is like, you know, in this particular regions, we have a completely different phenomena here. Do remember one thing, temperate cyclone, if at all any question will be there. So temperate cyclone will be, their process of the frontogenesis leads to temperate cyclone. You remember this. Okay. Okay, any other question, please go ahead. Ask me if you have any question. Done. Okay, now I will go for this again. Tropical versus temperate cyclone. Condition for the development, I hope you got some idea now. About the development, you got some idea now at least. About the conditions for the development, I hope you got it. Stages of development, you got it. Yes or no? Now, I will go for one more point here. This is tropical cyclone. This is temperate cyclone. Tropical cyclones, very destructive they are. It covers small area. Tempered cyclone, it covers large area. Tropical cyclone associated with very high velocity wind and most destructive. It is associated with tropical. Temperate cyclone associated with moderate to high velocity wind and less destructive than tropical cyclone, than a tropical cyclone. You remember this. Now, this is, I hope you got it now. You can see this. Tropical cyclone energized by the latent heat of condensation. Here, temperate cyclone energized by thermal gradient between the air masses. Thermal gradient between the air masses. Okay. Number 6, number 7, number 8. 6, 7, 8. I hope it is clear to you. Any doubt on this one? Whatever I said just. Yes, it covers small area, it covers large area. In the radius of this, if you will see, this is very important here. Again, I can say one more thing. Tropical cyclones are, there are specific name for tropical cyclone. Of different region. For example, you know that Hudhud came to India, strike. Fani in India, it has destroyed so much of regions of eastern part of India. Specific name, but there is no such name. No name given to temperate cyclone. I told you tropical cyclone has cumulonimbus cloud mostly. Temperate cyclone has less likely to have any cumulonimbus cloud. You must remember this. This is very, very important to see. I hope you got it now. Someone is asking how we calculate the time in longitude. Okay, I have already, please do ask me the question whatever now related with this topic, please. You can SMS me so that I can answer later on. Please remember, ये topic को divert मत करो ना. Energized by the latent heat of condensation, this is tropical cyclone, specific name, but here it is energized by the thermal gradient between two air masses, no specific name. It can have like, it can last for very short duration of time, for only 3 to 4 days. Tropical cyclone lifespan short. It can be for weeks, एक एक हफ्ते तक रह सकता है. टेम्परेट साइक्लोन शॉर्ट लाइफ स्पैन. Tropical cyclone has short lifespan. Tropical cyclone very short lifespan, for 3 to 4 days. Here it is moderate. It lives for 7 to 15 days. Moderate rainfall will be there in case of temperate cyclone. So many things are there. Tropical and temperate cyclone, if you look at their even the characteristics, they are completely different in fact in many cases. My friends, this tropical cyclone and temperate cyclone, as I have just mentioned about both of these, cyclone plays a very crucial role, basic role, very important role, okay, in atmospheric stability and instability. It brings atmospheric instability, disturbances. Okay, hope you got it now. Is it clear to you? Is it clear to you this part at least? Now, here is a question I think from someone. Sir, though tropical cyclone is silent, but there is formation of cumulonimbus cloud too. My friend, not silent. Eye of the cyclone is only eye of the cyclone is silent. आपका जो बोला ना मैं, आप थोड़ा समझो इसको. Eye of the cyclone, here it is silent. This is very violent or else. It suck up everything. आपने NCERT बुक में देखो अपना एक डायग्राम दिया होगा. इवन दिस इज हियर इज गोइंग डाउन, ऐसे ये सक अप कर रहा है. यहाँ वेरी कॉम्प्लिकेटेड फॉर्मेशन इट इज देयर. ऐसे जाके ये क्या करेगा, यहाँ से ऐसे करके इट विल गो अप, यहाँ से ऐसे होते हुए गो अप, सब एयर को ऐसे सक कर देता है इधर. इट इज सो आप जो बोल रहे हो ना, सो इट इज लाइक यू नो, दो ट्रॉपिकल साइक्लोन इज साइलेंट बट देयर इज फॉर्मेशन ऑफ क्यूमुलस क्लाउड टू. It is not silent. It is has very destructive, very dynamic, because of the spiral ऐसे location के वजह से ऐसे घूमता है ना. For that reason only at the middle eddy formation is there. So sinking of the air. That's why it is here silent. Eddy formation in the middle में, which is associated with thunderstorm and lightning. So how is it silent? No, it is not silent. I didn't say it is silent. Silent is only eye of the cyclone. Please remember, only eye of the cyclone is silent here. Eye of the cyclone because of more movement, rotation. Okay, please remember. Done. Please let me know if you need anything, any clarification. Is it done? Completed? Now, as I have mentioned about all these tropical and temperate cyclone classification I have done. In fact, so cyclone will be frontal in nature. Cyclone, temperate cyclone rainfall will be frontal in nature, and rainfall due to temperate tropical cyclone is convectional type. Convection, modification of convectional type, isn't it? So because air will move upward and it forms this. So wind system, we have like cyclone and anticyclonic system. I hope you got it. Cyclone. Now I'll go for the anticyclone. What is an anticyclone? Opposite to cyclone is an anticyclone. एंटीसाइक्लोन क्या है? opposite to a cyclone. Okay. So a high pressure condition associated with the divergence of air, okay. Due to strong divergence at the ground, air vertically air sinks downward, and develops clear sky, no cloud. Clear sky means no cloud. In case of a anticyclone, there will be no cloud. Cloud nahi rahega. Anticyclone doesn't have a cloud. In case of anticyclone, you will not have any cloud. Anticyclone doesn't have cloud. Anticyclone doesn't have cloud. Please remember this. Anticyclone doesn't have cloud. How it is? Let me tell you. If this is a region here, wind will blow from here. If the wind will blow from here, now this is the high pressure condition it is saying. अगर कहीं पे विंड अगर डाइवर्ज होकर ऐसे चला जाता है, आप सोचो अभी, बिकॉज प्रेशर डिपेंड्स ऑन वर्टिकली एयर पार्सल. यहाँ पे जितना वजन है एयर का उसी के हिसाब से है ना ये वाला का एयर. ये हाई प्रेशर अगर है, डाइवर्जेंस हुआ तो ये एयर अगर इधर से चला गया तो सिंकिंग होगा कि नहीं? दे विल बी सिंकिंग ऑफ एयर, होगा कि नहीं? सो इट विल हैव सिंकिंग ऑफ एयर. Here it is divergence. Sinking of the air and divergence you will have. Now आपको पता है if you will go up, temperature decreases, coming down it will increase. So if it is like here it is cold, warm, cold, cool, warm, hot, cold, cool, warm, hot. Temperature will gradually sinking air temperature will increase. आपको बताया था मैं adiabatic cooling and this. If you go up temperature decreases. If you are coming down temperature will increase. If you go up temperature decreases. If you come down temperature will increase. So in this case देखो here divergence is there, so divergence leads to sinking of the air. Divergence leads to sinking of the air here. The divergence is primarily divergence is here and the sinking of the air, consequent sinking of the air. I hope you got it now. So in case of anticyclone, there is a divergence of the wind and there is a great sinking of the air. Air will sink down and divergence will be there. Both the cases. Air will sink down and there is divergence of the air. Now, as I have just mentioned about this, hopefully you got some idea like of anticyclonic conditions. anticyclonic conditions. Okay. What type of question they will give you? They have asked one question earlier. What type of wind circulation in case of an anticyclone? Now you tell me, northern hemisphere में कैसा होगा? So the anticyclones are anticyclone experiences नॉर्दर्न हेमिस्फीयर में क्लॉकवाइज होगा एंटी क्लॉकवाइज होगा? बताओ, क्लॉकवाइज और एंटी क्लॉकवाइज? टेल मी. क्लॉकवाइज और एंटी क्लॉकवाइज कैसे होगा बताओ तो मुझे. टेल मी हाउ इट विल बी. कैन यू प्लीज रेस्पॉन्ड. In case of an anticyclone in the northern hemisphere, it will experience as clockwise or anti-clockwise. कैसे सर्कुलेशन होगा? What type of circulation you will have? Clockwise in northern hemisphere, anti-clockwise in southern hemisphere. Okay, thank you. अरे requesting you all to give फटाफट आंसर दो ना यार. Okay, clockwise in northern hemisphere, anti-clockwise in southern hemisphere. Very good. Because this is in the northern hemisphere. अगर ये northern hemisphere में है, so what will happen here? Turn towards right. It will turn towards right, is not it? ऐसे होगा. I hope you got it. How it will be? It will turning towards right, northern hemisphere में. So it is clockwise in northern hemisphere. It is clockwise in northern hemisphere. Okay, ठीक है, thank you. So the clock or anti-clockwise, it is depends on, I can say, or we can say here that this is related with where exactly it is, clockwise circulation, anti-clockwise circulation. Do you need any more explanation on the topic which I discussed earlier, including the climatic region? कुछ चाहिए तो बोलो. Can I expect that you will able to do? Questions will be about climatic area, but if I will go in detail of climatic characteristics, each climate will take at least more time. So in brief, I just said because of that only. If you need anywhere any explanation, please let me know. अभी तक जो कराए थे उस पे बताओ. If you need any explanation anywhere. Yes. If you need any explanation anywhere, please let me know. In the questions earlier, from the climatology, you got good number of questions. Questions are like direct one. Some of these like they have had low pressure is clockwise in northern hemisphere, anti-clockwise southern hemisphere. High pressure is clockwise in northern hemisphere, anti-clockwise in southern hemisphere. This type of statement 1 and 2 both are correct. One is correct. None of these are correct. Like this, the question they have asked. Cyclone and anticyclone. डिफरेंसेस यू नो नाउ यू able to do. एक बार क्वेश्चन सबको देख के करो. एंड एज यू आर सेइंग it is needed certain more practice, Only limited people are interacting. Thank you, Vanshika. And I need all of you must do this. I am requesting you all to look at. Okay. So, by the way, as I have just done with this climatic classification regions, this we have done wind system, cyclone, anticyclone, cloud, precipitation, climate region में हुआ कोई दिक्कत नहीं है. Now, from the climate, what can we expect this year? I feel because of there are lot of in fact problem associated with the weather condition, change in the weather condition, El Nino, La Nina and all these things. I will just tell you certain things in the ocean current. Okay. Frontogenesis type. See, whenever two air masses meets with each other, ये हो गया आपका warm air mass. This is here is cold air mass. Whenever both of them they meets, cold air mass try to influence the warm try to influence the cold. In this way, this is a transitional zone developed known as a front. Development of front is known as frontogenesis. Now, based on the force, what will happen? This particular अभी क्या करेगा ये ऐसे हो जाएंगे. क्यों ऐसे होंगे? Because of the development of I am saying here pressure will be more, and for this pressure will be more here, and for that regions the front will get tilted now. ये फ्रंट जो है ना ऐसे हो जाएगा. ये फ्रंट जो था ये इधर पे ऐसे टिल्ट हो जाएगा. ये फ्रंट ऐसे हो गया अभी. Because of this air masses here, it will have more velocity as compared to here. Strains will be more. Here it will have more pressure in the upper part. Why we have more pressure in the upper part? Because the air is lighter here. And the colder air will go much. Here it will level like this. ये थोड़ा इधर ज़्यादा जाएगा, वो इससे ज़्यादा इम्पैक्ट पड़ेगा. दिस इज द कॉज देयर विल बी ए inclined front. This development of front is frontogenesis. There are different conditions for the front development. Okay, दोनों का transition zone है frontogenesis. और death of the front is frontolysis. There are different type of front: stationary front, warm front, cold front, occluded front. Okay, fronts are of different type. One is stationary front. ये हमें ये जो एक जगह पे हुआ तो स्टेशनरी फ्रंट. Then second one is warm front. Then you have cold front. Then you have occluded front. Different type of fronts are there. ये स्टेशनरी फ्रंट है और ये पार्ट जो होगा ना यहाँ पे ये वार्म फ्रंट होगा और लोअर पार्ट विल बी कोल्ड फ्रंट है. ये कोल्ड फ्रंट है और दिस वन इज द वार्म फ्रंट. समझ में आया? जैसे दोनों फ्रंट जब मिलते हैं जहाँ पे एक से होता है, ये कोल्ड फ्रंट है अगर ये वार्म फ्रंट है. दिस इज द किंक एंड ये कोल्ड फ्रंट, दिस इज वार्म फ्रंट, किंक हियर. दिस रीजन्स विल हैव साइक्लोनिक स्टॉर्म. So, kink formation. Then these two front, warm and cold front will meet. Both of them they will meet, and there will be the distance will be less. Okay, and because of this cold and warm front, whenever these two front they are coming closer to each other, then you have the formation of occluded front. दोनों फ्रंट जब मिल जाएंगे, कोल्ड फ्रंट एंड वार्म फ्रंट, this is the cold front, this is the warm front. वार्म फ्रंट ऐसे हो रहा है, ऐसे था, ऐसे गया. कोल्ड फ्रंट वाज लाइक दिस. देखो पहले क्या था, ऐसे था, मूव्ड अप टू लाइक दिस. कोल्ड फ्रंट मूव फास्टर देन द वार्म फ्रंट. ये कोल्ड फ्रंट ऐसे चला जाएगा, समझ में आया? It moved faster than the warm front. It was here. It moved to this place much faster than the warm front. Warm front was here. You see, warm front का डिस्प्लेसमेंट कितना है? बहुत ही कम है. कोल्ड फ्रंट की डिस्प्लेसमेंट ज़्यादा है. कोल्ड ओके, ऐसे टाइम आएगा कि दोनों फ्रंट जब मिल जाएंगे यहाँ पे, ये लेट अस से दिस इज द कोल्ड फ्रंट एंड दिस इज द वार्म फ्रंट. Occluded front, cold front, वार्म फ्रंट, ये दोनों मिल जाते हैं ना, कोल्ड और वार्म मिल जाएंगे तो ये जो हुआ ऑक्लूडेड फ्रंट हो गया. ये धीरे धीरे कम होते जाएगा. ठीक है ना? डिफरेंट टाइप ऑफ फॉर्म फ्रंट्स आर देयर. कोल्ड फ्रंट, वार्म फ्रंट. ऑक्लूडेड फ्रंट के बाद फ्रंटोलिसिस स्टार्ट होगा. Whenever the occluded front start, it is frontolysis. क्या बोलते हैं उसको? Frontolysis. Death of the front. Then the cyclone will gradually dies out. Cyclone will gradually dies out. फ्रंट का डिफरेंट टाइप ऑफ फ्रंट होते हैं, एंड दिस फ्रंट्स आर ऑफ different type. How and why they form? Fronts are formed only because whenever both of them they meet towards each other. Fronts जो होते हैं ना, different fronts होते हैं. Whenever cold and warm air masses meets, there is formation of this. Just 1 minute, I will show you how all these things are happening. मैं लाइव दिखा देता हूँ आपको. देखिए, see, as I was talking about the northern hemisphere anti-clockwise low pressure, देखो आप यहाँ पे, can you see this? Carefully you can see, you will find out how the wind is blowing here. देख रहे हो, ये लो प्रेशर है, तो दिस इज क्लॉकवाइज और एंटी क्लॉकवाइज. यू कैन सी दिस. क्या है ये? क्लॉकवाइज है, एंटी क्लॉकवाइज है? बताओ. क्लॉकवाइज सर्कुलेशन, व्हाई इट इज देयर, बट साइक्लोन इज एंटी क्लॉकवाइज in northern hemisphere. We can see here, just 1 minute, let me show. you see, this region you see here. Temperate cyclone they develop. Although one more thing remember, temperate cyclone develops in groups. एक फैमिली के साथ होगा, एक ने एक साथ 8-10 एक साथ डेवलप करते हैं, क्योंकि एक वेवी नेचर में होता है. ये देख रहे हैं ना, ये वेवी नेचर पे है ये. सो दैट्स वाई दिस इज द केस. यू कैन सी हियर हाउ एंटी क्लॉकवाइज सर्कुलेशन इज देयर इन दिस केस. कैसे देखो ये एंटी क्लॉकवाइज है कि नहीं, एंटी क्लॉकवाइज है ये. दिस एन एंटी क्लॉकवाइज सर्कुलेशन यू कैन फाइंड आउट. ओके हियर. एंड यहाँ पे देखो क्लॉकवाइज सर्कुलेशन कहीं पे होगा. इन केस ऑफ योर एंटी क्लॉकवाइज बिकॉज ऑफ द फॉर्मेशन. दिस इज द लो प्रेशर सेल हियर. साइक्लोनिक कंडीशंस आर देयर. अच्छा, हाई प्रेशर कंडीशन पे देखते हैं. इफ देयर इज हाई प्रेशर कंडीशन, देखो यहाँ हाई प्रेशर है, कोल्ड वेव. wherever high pressure here, wherever you have high pressure like this is in southern hemisphere. You see we have cyclone is there, clockwise low pressure condition. Can you see this, how it is in the southern hemisphere? Now these are so easy, and you can get the things, in fact it's very easy. About the, so far as this one is concerned, I would like to tell you one thing, that you must see these different type of fronts and all, depends on different stages. Prelim में नहीं आएगा ये सब question. Prelim में I think you will get question from other like differentiation can be asked on this. थोड़ा देख लो previous year question and MCQ. Do this. Any problem, let me know. I am fearful that whether you are able to, whether you are concentrating or not, you are doing it or not. I request you all to go ahead with this. Friends, one thing you must remember, what is more important is your confidence level and your commitment, your perseverance and your dedication. How you are doing these things. Now it is very important, at the very less time, how you have to complete the things that you need to see. Most important part, only start doing these things, like revise the things and go for this MCQ and questions, and give me questions if you have any. So I'll now from here I'll go for, as I have just said, I'll go for now ocean bottom relief on the climatic type. In the ocean bottom relief, ocean current के साथ साथ मैं कराऊंगा क्या, El Nino La Nina. El Nino La Nina will do it. I need some mapping part also, so I just want mapping. We have to do the mapping part. I'll tell you the important points that you need to see. I think you will get question from the map. The regions are very, very important. We have very less time now. Okay. In the oceanic part, we have one very important area, ocean bottom relief. Remember, like the continent, the ocean also has huge variation in terms of its relief features, and you have mountain, plateau, plain, deep gorge like features. Everything is there inside the ocean also. Now ocean and continent are first order landform. Inside this you have second order landforms, like trenches is a second order, mountain is a second order landform, and all Ocean. The largest ocean is which one? The southern hemisphere. The southern hemisphere is called as is called as water hemisphere. Water hemisphere. Southern hemisphere is called as the water hemisphere. You know it. Hope you all are well aware about this. Southern hemisphere is called as the water hemisphere, right? And the ocean wise, if all the water bodies, over the ocean, over our earth crust is combinedly called as hydrosphere. All water bodies over our earth crust is combinedly called as hydrosphere. This is called as hydrosphere. Okay. Ocean bottom relief, southern hemisphere is called as water hemisphere. I told you, all water bodies over our earth crust is combinedly called as hydrosphere, I said. And you know, among these in the hydrosphere you have the Pacific Ocean, the Atlantic. Pacific is the largest. I am just giving some information, factual information before starting for in deeper all other things. Atlantic Ocean, the Indian Ocean, we have the Pacific, Atlantic, Indian, Southern Ocean, Arctic Ocean. You know about this, all these ocean, that depth wise, if you will see, Pacific is the deepest one, largest and deepest. Atlantic is second deepest. You know about this, Indian Ocean is second deepest is Indian Ocean, second largest is Atlantic Ocean. So we have like this, these facts you know it. Now one thing you need to be very clear on one particular point here, that the entire hydrosphere which I was talking to you, look at here. You see, this is the earth and here is North America, South America. This is, you know, that here you have the North Atlantic, South Atlantic. Here you have the Indian Ocean. This is Southern Ocean. You know, upper part, this is Arctic Ocean. This is Arctic Ocean. So all these water bodies are here. You know it. All these water bodies are here. My friends, one thing you remember, and one thing very, very, very important, this ocean water, as you see, it is very dynamic. We have already discussed earlier about different type of wind system. I said that in the wind system, the impact of the wind over the water bodies leads to different type of oceanic phenomena. Among these, one is ocean current. The most important one is ocean current. Ocean current is here. Ocean current We have like, if there is wind, only wind related oscillatory movement is UC wave. The displacement of water is called as what? Ocean current. Okay, these are the things which we are going to discuss today. And first I will go for the ocean bottom relief. As I said, inside the ocean, if you look at, like, there are lot of variation inside the ocean. As we have seen, this is the temperature map, but if you will go for, this is based on the satellite or radar, I have just given this. So this is here in this particular things, ocean bottom relief is not shown here properly, as not, so that I will just take one thing like ocean bottom relief. Directly you can see this. Like the continental part, the ocean also can be divided into several physical units. One such thing is known as continental shelf. So first we will say ocean bottom relief features is or can be divided into the following major units. Number one, continental shelf. Number two, continental slope. Number three, continental rise. Number four, abyssal plain. Okay, and you have number five, you can say mid or oceanic ridges. And trenches. My friends, these are like, most important few regions. Continental shelf. What are these continental shelf? What are the continental shelf? Continental shelf is nothing but, continental shelf, it is the submerged part of the continent inside the ocean. Continental shelf is submerged part of the continent inside the ocean. So the shallow sea region these are. Remember, this regions is very, very important for us, both in terms of economic significance as well as an ecological aspect. Let us note down few points about this. Continental shelf. I said continental shelf continental shelf is the submerged part of the continent inside the ocean. Continental shelf is the submerged part of the continent inside the ocean, and as I just mentioned, it is a shallow sea region. Shallow sea region mean, again, depth is less. So shallow sea region these are, and mostly, what happened, this continental shelf area, because at the ocean margin they are the transitional zone between two parts of the two ecosystem. Transitional zone between two ecosystem, terrestrial and marine ecosystem. Okay, they are rich in biodiversity also. Let us look at something more about this. This continental shelf is very wide in some regions of the world. Okay, where it is widest shelf lies in north of Siberia in the Arctic Ocean. Okay, continental shelf, widest shelf is located north of Siberia in the Arctic Ocean. In the Arctic Ocean. Okay. Here you have the widest shelf. This area is continental shelf region, continental slope region, continental rise region, abyssal plain region. This is continental shelf. This is continental slope. This is continental rise, abyssal plain. Okay. You can see here, I have just drawn this like based on the different characteristics, we can divide them into different part as I said. This is the continental shelf, continental slope, continental rise. The abyssal plain, etc. Okay, hope you have drawn this. See, continental shelf is very broad in the Atlantic and very narrow in Pacific. You remember this. Broadest or widest in Arctic Ocean. Arctic तो होगा ही, Arctic तो widest one. Arctic Ocean. It is also broad in Atlantic, but very narrow in Pacific. Okay, you must remember this. Narrow in the Pacific Ocean, it is mostly narrow in the Pacific Ocean. And this continental shelf, these regions, if you look at the entire marine environment, nearly 7.5% area, in fact, of the marine environment is continental shelf, nearly. So, the thing is, they can ask like where you have widest one in India में कहाँ है भाई? Which part of India will have that wide continental shelf? Can anyone tell me? Which part? Arabian Sea or Bay of Bengal? which part of continental shelf is wider? This is Arabian Sea, this is Bay of Bengal. One or two? Which part is there? Widest continental shelf in India. Which area has widest continental shelf in India? Arabian Sea. Thank you, Bansika. Thank you. Arabian Sea part. Yes. This part you have more. Wider continental shelf. Here you have narrow continental shelf. Bay of Bengal. Wider continental shelf because this area got submerged under the water. This area got submerged under the water. I told you earlier, it got submerged because of what? Faulting and during the evolution of our drainage system of peninsular drainage system. By the way, continental shelf are helpful for what? First is, you can note down 3 points here. First, continental shelf is a ecotone, rich biodiversity. First one, continental shelf has rich biodiversity. Second point, helps in the development of fishing grounds. Helps in the development of fishing grounds. You see, these are very important. They are generally rich in mineral deposits. What type of mineral you have here? Among the minerals, if you will see, first, petroleum was around 65-70% petroleum. Now reserve is in the continental shelf area. Shallow sea and continental shelf regions has maximum deposits of petroleum and natural gas in the world. First thing, we have polymetallic nodules, we have different type of material, minerals which will found from the ocean. Even continental shelf regions are rich in coral reef also. Coral reef, which are the tropical rainforest of the ocean. Coral reef, which indicates the status of the marine environment, quality of this marine environment of a region. So, it's so important this is. These are here continental shelf, wider continental shelf are there. Atlantic Ocean has a wider continental shelf, I told you. Let me now go for the continental slope. Continental slope, these are very steep slopy zone. Continental slope is the steep slopy zone with only bedrock. देखो आप यहाँ पे steep slopy zone with the bedrock, where the sediment will not get deposited, the sediment will glide quickly. In this region, sediments will glide quickly and they got deposited down slope, and where it is called as, the deposited one is called as continental rise. So, continental slope is nothing but the bedrock of the region, ocean floor. It is the bedrock, B-E-D-R-O-C-K, bedrock of the ocean floor. Then continental slope is the bedrock. ये हो गया आपका bedrock of the ocean floor. Now continental rise, depositional one, all the depositional material which got deposited down slope the continental slope, it is known as the continental rise. Continental rise. Remember, Geologically, part of the continent is up to continental slope. Up to continental slope, you consider it as the part of the continental. Geologically, part of the continent is up to the continental slope. Beyond this, you have oceanic floor. Okay, though it is also the oceanic floor, but geologically we consider up to continental slope as the margin between the continent and the ocean. Now, you see here, this is continental rise. Continental rise is depositional platform, I told you. Now, abyssal plain. Abyssal plain is the deep sea plain regions. Abyssal plain is the deep sea plain region. Vansika is asking, can you please clarify the continental shelf? It is 40% of the world total or 60 to 75%. See, Vansika, this is like, petroleum and natural gas or petroleum only. Okay. Petroleum and natural gas, 60 to 75%. Petroleum and natural gas, everything if you will include. Natural gas, majority will get it also in the shelf area. You can check it out, you will get the things from even statistics, that's the book from where you will get it, resources. Or I'll check it out and I'll confirm it tomorrow. Exact data, approximately this is the case. Okay, I just tried to give you some idea about the concept about this. This is the part of the continent we got submerged. This is the steep slopey area. This is here is deposition of sediments. In general, oceanic and continental plate or oceanic and oceanic plate meets here forming a trench. Trench, trench is the convergence zone between two different plates. A plate can be oceanic or oceanic continental. Here it will be definitely oceanic continental plate. Whenever there is oceanic continental plate, convergence of oceanic and continental plate, there you have a trench where one plate is subducted below another plate here. Trenches will form. The deepest trench is Mariana Trench. Do you know about this? What are the major trenches? Deepest trench is Mariana Trench. Mariana Trench is 11033. Tonga Trench. Achha, in the prelim they can ask question on trench. Yes. Let us see. Trench, their location. Depth will likh do. Depth, approximate depth. Okay, I don't know. I have to or else refer the data, depth and their location. This trench and the location I can say 100% correctly, but data, you just need to see few things depth related, but I hope you will able to do. First one is Mariana Trench, Mariana Trench. Mariana Trench in the Pacific Ocean. Mariana Trench in the Pacific Ocean, North Pacific Ocean. You know about this? North Pacific. 11,033 meter. North Pacific Ocean. Mariana Trench. Can you see this in your atlas? Tonga. Tonga Trench or Eldridge Trench. Eldridge or Tonga Trench, it is in the Southwest Pacific, it should be Central South Pacific. Central South Pacific. Central South Pacific, Tonga Trench, Eldridge Trench. Otherwise, Eldridge Trench. 10554 meter around North Pacific, Northeast, Northwest Pacific, Northwest Pacific, Pacific. Okay. Got it? Northwest Pacific. Japan Ramapo Trench. Japan Trench Ramapo deeper trench. North Pacific. 10554. Kuril Trench. Kuril Trench. KURIL. Kuril Trench कहाँ है? जापान के ऊपर है. Kuril Trench. Kuril Trench is also somewhere 10,000 something it will be, and it is in North West Pacific, west of north of the Ramapo Trench or Japan Trench. You will get it. It is nearly Kuril Trench is in fact 10498 meter. Kuril Trench. So these four you can remember. Other trenches depth I cannot say, but exactly Philippines Trench or Sware Trench, Aleutian Trench. Philippines Trench, Philippines near Philippines in your Pacific Ocean. You can see Northwest Pacific, Northwest Pacific. It is in the North Pacific Aleutian Trench. Depth is not needed for this. पहला आपको पता होना चाहिए. This is the deepest one. बस. Mariana Trench is the deepest one. बस. Aleutian Trench, you got it? Puerto Rico Trench. पुर्टो रिको वेस्ट इंडीज में है ना. Nearly 9,000, 8,000 something it will be. Puerto Rico Trench near West Indies. Near the Puerto Rico island here, Puerto Rico Trench is there. Near the Puerto Rico island. Can you see this in the north? Puerto Rico will be in the Puerto Rico central, you can say that Atlantic Ocean central part near West Indies, so central, north central in Atlantic, north central part, Puerto Rico. ये सब ट्रेंचेस को देखते हैं. रुको, लेट अस सी ट्रेंचेस ऑफ द वर्ल्ड. See the trenches which I said, this is Mariana Trench. This is Philippines Trench. This is Japan Trench, Kurilian, Aleutian Trench, Tonga Carbatic Trench. Oh, this is the Java, Sunda, Java Trench. Please see these trenches. ये कौन सा है? टोंगा ट्रेंच लिखो. टोंगा ट्रेंच इज इन व्हिच पार्ट? टोंगा ट्रेंच इज इन साउथ पैसिफिक. कर्माटेक इज बिलो दिस साउथ पैसिफिक. कैन यू सी दिस? ये ट्रेंचेस में इनका लोकेशन बहुत जरूरी है, जानना चाहते. पेरू चिले ट्रेंच इज हियर. कल बताया था मैंने आपको प्लेट टेक्टोनिक्स. पेरू चिले ट्रेंच इज इन दिस रीजन्स. एलुसियन ट्रेंच, क्यूरिल ट्रेंच, जापान. इजू एगास्वारा नहीं चाहिए, रियोकू ट्रेंच नहीं चाहिए. फिलीपींस इज मेरियाना. जावा इज वेरी इंपॉर्टेंट. दिस इज जावा ट्रेंच टुवर्ड्स दिस साइड. सुंदा ट्रेंच और जावा ट्रेंच. साउथ सैंडविच ट्रेंच इज हियर. साउथ सैंडविच ट्रेंच. ओके, okay, fine. We'll see that. Trenches. As you know, trenches are like this, very deep profile. I have already in the last class I did said, at the trench one plate moved below another, it will melt and it will have volcanic eruption also. We have already discussed in the last session. This is here like this. Okay. All these trenches as I just given, trenches of the world, you can see this has given a very interesting thing on the trenches. We can see. देखो यहाँ पे ये दे रखा है. This is Puerto Rico trench. Can you see this? Puerto Rico trench is here. Puerto Rico trench. South Sandwich trench is here. Tonga trench is here. Carmatic. Bougainville trench is this side. Not important. Please remember Mariana Trench, Philippines Trench, Sunda or Java Trench, Tonga, very important, Tonga Trench, you have Puerto Rico Trench and you have Japan Trench. Can you see this? These are the trenches here. Location of the trenches is important for us. Okay. Now, after these trenches you got it. There are sea mount and goyards also. Goyards are what? Flat top sea mounts are known as goyards. ये ऊपर फ्लैट होगा बिकॉज ऑफ इरोजन. Flat top sea mounts are called as goyards. Flat top sea mounts developed due to erosion. These sea mounts were developed due to erosion. Sea mount are mountains which are submerged inside the ocean, sea mounts. Now coming to abyssal plain. It is the deep sea plain, please remember. Abyssal plain is the deep sea plain. Next point likho. It is the widest and largest physiographic unit of the ocean. It is the widest and largest physiographic region of the ocean. Okay. A very important point, you must remember this. Now it comprises mostly, क्या कहता है? It comprises mostly sediments. It comprises mostly sediments. What type of sediments you have here? Three types of sediments you know: cosmogenous, biogenous, as well as cosmogenous terrestrial one. That is, it has the abyssal plain comprises terrigenous, cosmogenous and biogenous sediments. Here they will give you terrigenous क्या है? From the earth causes sand, silt, clay. Cosmogenous is cosmic dust particles. Biogenous you have ooze. Ooze क्या होता है? Highly decomposed organ materials of living plant and animal. When they dies out, the plant and animal, they are decomposed material. Please note down. Ooze is the highly decomposed. It is the highly decomposed gel-like substances generally found inside the ocean. There are different types. If I'll go for the deposits, ocean deposit में deep sea deposit को बोलते हैं pelagic deposit. This is where known as pelagic deposit. Oozes will have biogenous. You have abyssal plain. Abyssal plain is deep sea deposit. They are biogenous. Ooze can be of different type. Ooze are, I'll give you detail of this one. These ooze are highly decomposed remains of and weathered materials of dead plant and marine animals. तो ऑर्गेनिक है ऊज. ऊज इज एन ऑर्गेनिक मटेरियल. अभी आते हैं क्या कितने टाइप का ऊज है, व्हाट आर द टाइप ऑफ ऊज एंड हाउ इट इज इंपॉर्टेंट. लेट अस सी नाउ. देखो, ओशियन डिपॉजिट ऑफ डीप सी डिपॉजिट नोन एज पेलाजिक डिपॉजिट. क्या बोलते हैं उसको? पेलाजिक डिपॉजिट्स. पेलाजिक मीन deep sea deposits here. It can be organic matter or inorganic matter. Two types हो सकते हैं, ऑर्गेनिक और इनऑर्गेनिक. दो तरह के हो सकते हैं. मटेरियल कैन बी ऑर्गेनिक वन और इट कैन बी inorganic one. If it is organic one and highly decomposed one, it is known as a ooze. Organic one, ooze कहते हैं. Okay, organic one is the ooze. Now these ooze are of two different types. One is rich in calcium, another one is silica. Calcareous ooze, another one is siliceous ooze. Here it is called as, this one is, here it is, inorganic mein, red clay is the most important one. Red clay is a very good example of inorganic one. Calcareous, pteropod and Globigerina ooze. Calcium rich material, pteropod and Globigerina ooze are best example, pteropod and Globigerina. Okay, and you have the siliceous radiolarian ooze and diatom. So I hope you got it now. Pelagic deposit जो है ना मिड सी और डीप सी डिपोजिट है. डीप सी डिपोजिट आर ऑफ अगेन एज आई सेड यू नो डिफरेंट है ये. इसके अंदर जो है ना यू विल गेट ऑर्गेनिक मैटर और इनऑर्गेनिक मैटर. If it is dead plant and animal, calcium rich calcareous, silica rich siliceous, calcareous are pteropod and Globigerina, and siliceous is radio R होगा ये radiolarian and diatom. Okay, so these are pteropod, Globigerina. ये नाम याद करना है. Which one of the following is calcareous? Which one is siliceous? Mostly in inorganic material found in pelagic deposit. Pelagic मतलब मैंने deep sea है. Deep sea deposits. Deep sea deposits are called as pelagic deposits. Please remember this. Inside the deep ocean water, the deposit is called as pelagic deposit, my friend. You must remember this. Pelagic deep sea. It covers the largest area in the ocean. Please remember. Pelagic deposit, this is the largest area over the ocean. वो मैं बोला था आपको sedimentary rock is more because of this only. This pelagic deposit are huge regions where you have this. Okay, very important here. Red clay, if you look at, it is you know the deposits are much high than whatever. इतना याद हो जाएगा. I hope you will able to memorize this much at least. Okay, this is about the ocean bottom relief. Now, one more thing, there are two important aspects. One is temperature in the ocean and another one is about salinity. They are asking question from temperature and salinity in the ocean. Do you remember that the temperature of the ocean like the atmosphere, you know, it also changes with respect to, there is a great change in the temperature with respect to latitude as well as with respect to your depth. Okay, let us see now. Temperature in the ocean. See, like the atmosphere, there is a great change in the temperature condition of the ocean also. As you know, more than 70% of the surface is ocean here. So, whatever sun rays falls over the earth's surface and in the ocean, 80% nearly absorbed by the ocean. Remember, upper 10% of the ocean, upper 10% has ocean has whatever heat energy, it is more than the heat in the atmosphere. Energy is so much. Upper 10% of the ocean energy is, I said, more, upper 10% than the entire atmosphere. So, this is the what? It is a huge storehouse of heat energy, we can say. Huge storehouse of the heat energy. The temperature varies with respect to latitude. The temperature varies with respect to latitude. You remember one thing. The average temperature of the ocean is varies from 26 degree to 23 degree somewhere. 26 to 23 degree variation. Okay. 26 degree Celsius at the equator. 26 degree average temperature at the equator you have. But anyway, temperature will vary with respect to latitude. At, as I said, like at equator 26 degree temperature, so it gradually decreases towards, it will gradually decrease. Temperature gradually decreases from the equator towards the pole like the atmosphere. But there are some deviation because of ocean current. Due to the presence of the ocean current, there are some deviations. Some deviation due to the presence of the ocean current, I said. So, let us see what are those deviation and what exactly is the position. I would like to discuss about that. At what latitude, what is the temperature conditions and all. They are not asking on that. I was just looking at the previous year paper where I got to know that on what conditions you have temperature changes and what are the most important characteristics here, latitudinal and longitudinal distribution of temperature. That is what they have asked. Just give me 1 minute, let me see a question at least. The questions here is primarily based on, yes, questions will be based on the isotherm. Isotherms are not straight. Isobar also are not straight because of differential heating and cooling of the ocean and the continent. In the winter and summer, their behavior is different. Why it happens? Can anyone tell me why the behavior of isotherm is different? Everybody is claiming like as if like they have done. Behavior of the isotherm, if you will see, this is the NCERT book. You can see these things like, how the temperature will differ. Look at here, month of January. Can you see this? Is from the NCERT I have taken. This question already asked in your exam. See, this is the month of January. In the month of January, the isotherm behave differently. The isotherms are, is it clear? Is it visible? दिखाई दे रहा है क्या ये? क्लियर है? जस्ट फोकस करिए इसको. Okay. It is the January mean it is winter. Winter in north hemisphere, in northern hemisphere. Because it is winter in the northern hemisphere, it is summer in southern hemisphere. You remember one thing, because of more variation in the continent and the ocean, water bodies and land masses, the thermal gradient will be more in the northern hemisphere than southern hemisphere. क्योंकि continent get heated up quickly, cool down quickly than the ocean. So what happened here? The continent here it is the 25 degree. Let us say it's 25 degree here. In the ocean, in the same place, same. If I'll say here it is 25 minus 25 degree, or let us say here it is 10 degree. Okay. In the continent it is 10 degree. In the ocean, at the same place here it is 20 degree. Can you see this? At the same line, 20 degree in the ocean. So 10 degree in the ocean will be somewhere here in this case, 10 degree. So if I'll draw this line, like it will go like this. Even 10 degree will be here in this case. So why it is? Then again, देखो यहाँ पे, here again it is increasing because of continentality. 10 degree will be here. So again it is coming in this way. So you see, during the winter, it goes towards poles. Because the sun is in the southern hemisphere at that time, and this is winter season in the northern part, summer in the southern hemisphere, differential heating and cooling, continent get cooled down very quickly, then the ocean, and it will taper towards north, tapering towards north like this. Now this will taper same way, all these lines they will have tapering like this. At the near the equator it will be less, but it is there. Now what will be in the southern hemisphere? Southern hemisphere has more water bodies, uniformity is more. So near the continent more variation will be there. देखो यहाँ पे, here is some variation. Because it will also goes taper towards north, mean toward the equator tapering होगा. Because the sun is going, in this case sun is in the southern hemisphere and cool down very quickly, warm up, ये cool होगा, ये cool होगा water, ये warm होगा water यहाँ पे. And आप देखो behavior of this, एक ही hemisphere का देखो, only one hemisphere you can see. Is it clear to you why it is? In the same line, if you see same plane, it is different. In the same plane, if you see, the temperature is different. I hope it is clear to you all on this. This was a question. Same thing will be it will be different in case of summer season. समर में ये विंटर में ऐसा है जनवरी में. इफ आई टेक नाउ जनवरी की जगह पे हम लेते हैं ये देखो, हियर इट इज जुलाई. इफ इट इज जुलाई, जुलाई में ऑपोजिट हो जाएगा. देखो इन जुलाई इन द कॉन्टिनेंट दे आर गोइंग अप एंड इन ओशन गोइंग डाउन. कॉन्टिनेंट में अप है, ओशन में कम है. दे आर गोइंग इन द कॉन्टिनेंट इन द अप, कॉन्टिनेंट दे आर गोइंग अप, इन द ओशन दे आर गोइंग डाउन. You see here, July is summer season, summer in northern hemisphere. So the ocean is cooler than the continent. Continents are generally warmer, so from the equator towards up, ज़्यादा दूर तक temperature ज़्यादा रहेंगे, more temperature. This is the major cause here. Hope you got it. Is it clear to you? This is a very important one. Information, please look at here. In this NCERT it is given very nicely. This diagram I am talking about. Hope that you got it now. Got it? This is the range it is given, range between temperature range of this. ये बहुत important है. You must see this diagram. Okay. Hope you got it. I would like to now tell you that there are various factors responsible for this. One thing, very important one, that if I'll look at the vertical one, in the NCERT it is something given very nicely. You can see this, you will find out a very, all of them again they have given their own name. From NCERT, I show let me tell you, you can see your NCERT will get it. In fact, in the NCERT itself, the temperature gradient inside the ocean will be different with respect to depth. There is a zone of sharp changes in the ocean also. It's like thermocline, vertical distribution of temperature of the ocean, if you will see, up to nearly 200 meters from the surface, it is almost constant, 200 meter. Then after 1000 to 1100 meter, sudden change in this. This is known as the thermocline. Zone where there is a sharp change in the temperature you have, thermocline. Okay, there is a sharp change, the depth of the ocean, vertical change in the temperature, vertical distribution of temperature in the ocean is not uniform. It suddenly changes from 200 meter to 1000 meter or 1200 meter. This is called as thermocline. Sudden change hoga. Then there is less gradient area, above we have less gradient. This type of things. My request to you, you must see the NCERT book. You will get all those things. In the NCERT you will find out all this. Okay. Tomorrow I will start from this thermal characteristic temperature in the ocean. Okay. From which I will start. From the temperature in the ocean, okay, we will start it, and hopefully we will able to do tomorrow as per the target, we will able to complete the things. Okay, so thank you very much. Thank you very much. See you tomorrow then. Bye bye.